First of all, welcome to the course. I am Sagar, your instructor for this course, with experience in designing and developing several software projects. This course begins with right from the basics of programming and followed by object-oriented programming features. And object-oriented programming features are very important for you to understand because that's what really makes the difference between a normal programmer and a professional application developer. And it also uses visual representations so that you get a real feel of what is happening in memory. And it is followed by the other Java language features and JDBC and a mini project. JDBC helps you interact with the database, and a mini project will help you understand how the components are layered in a typical software development project. If you have any simple doubt, such as a equal to 5, what is happening there, please feel free to reach out to me. Use the Q&A section properly so that you get the best out of this course. Overall, you have all the resources required, including the notes lectures as well. So, it is up to you to make the best use of this course. I am confident that this course is going to be very useful for you. Looking forward to your active participation in the course. Let's get started. Before you can start writing your first program, you need to know a few things about Java programming language. First of all, Java is a platform-independent programming language. And what do you mean by platform independence? This means you should be able to run the program under any operating system. Programs written in high-level language such as C or C++ are human-readable, but unfortunately it is not directly understood by the computer. Hence, it should be translated. Once the translation is done, it is converted to machine language, that is the language understood by the machine. That's fine, but there is a problem. This translation makes it bound to the underlying operating system in many different ways, and one among them is operating system specific service calls, which enables us to access the file system, network, etc. And hence, if the application is targeted for Windows, it includes Windows specific calls. If targeted for Unix, then it includes Unix specific calls, and so on. Hence, it is platform dependent. Then how Java managed to achieve platform independence? Yes. Here is what it does. When you submit a Java program for translation, say to the compiler, it translates the code to bytecode. That is, it generates the class files that contain the bytecode. Bytecode is then translated to machine-dependent code with the help of Java Virtual Machine, which takes care of operating system specific translations. JVMs are available for majority of operating systems. Applications written in Java will be executed under specific platform with the help of JVM, and hence they are platform independent. Let's see how to build a simple Hello World application in Java. Before that, you should install Java in your machine. Please follow the instructions in Getting Started PDF. Now let's begin. You can write this program through Eclipse directly, which is covered in the next lecture. First, let's see the manual approach. Open any of the text editors. Now just assume whatever you write should be part of some class. Let's say class and followed by the class name. Let's say first. Now you need to begin and end this class. And this is called a block. That's fine. Now for any standalone application, the entry point for the program is a main method, just like main door for a house. And this is how we should write the main method: public, static, void and main, and followed by string array arguments. And this is your main method. Don't worry, you will understand this. Things may not be completely clear for you in this video. Just follow the lectures. You will be able to understand these things. Now to print some hello message, we need to use system.out.println and the message hello, followed by semicolon to indicate the end of the statement. Now it will print the hello message in the console. You will know what is system.out in the coming lectures. Okay, you are done. Now you need to save this file. Let's say select some examples folder here. Let's create one. Okay, let's do examples. and save this file as first.java. Good. Now to compile and execute this program, you need to open the command prompt. Now I'll open the terminal here. Now let's move to the folder cd examples. And for compilation, first you need to use the java c command. Java c, here C for compiler, and followed by the file name, that is first.java. Now let's list the folder. You can see we got a class file here, first.class. Now suppose if there are 5 classes in the file, then you will see 5 class files for each class after the compilation. And to launch the program, we need to use the Java tool, that is Java followed by the class name that contains the main method. And here it is first. To recap, open any text editor and write a class with main method and save this file as some filename.java, that is say first.java, and open the terminal, and to compile the program use Java C and followed by the file name. Now you will see several class files for each class in the Java file. Now to run the program, use Java and followed by the class name that contains the main method. That's it. This process is further simplified with the use of Eclipse. You will see how to use Eclipse in the subsequent lectures. Now let's understand the structure of the main method. In Java, the main method should be part of some class, and it acts as the entry point for the program execution. And it is public, means we are not restricting access to this method. That is, it is given public access. And static means you can call this method directly, that is first.main, without creating the object. You will get to know what is an object and what is class in future lectures. And void here means this is not going to return anything. And again, what is the return value? You will know in the coming lectures. And string array arguments. They are used for accepting the command line arguments submitted to the program. Just to give you a heads up, when you write a command like this, copy a.txt space b.txt, here a.txt and b.txt are the arguments passed to the copy command, and these are called command line arguments. For a Java application, they are passed to the main method, and through these arguments, we can access the values passed through the command line. So just to recap, public means unrestricted access, static allows you to call the main method directly using the class name, void means you won't be returning any value from this method, and string array args for receiving the command line arguments passed to the program. Anyway, if you are still not clear, don't worry, you will know these things once you are familiar with the language. Let's see how to write a simple Hello World application in Eclipse. First open Eclipse. Now refer to the Getting Started guide for step-by-step instructions. It prompts for workspace. Workspace is the location or folder where you will keep all your examples or projects. You can choose whatever you want. Let's say example WS. Yeah, now if the folder is not there, then Eclipse will create it for you. Now you can close this welcome screen. And this is called Java Perspective. A perspective is composed of several views that enable us to build the applications easily. You can close the views whichever are not required, and still you can reopen them when required using the window menu, and you will find under the window menu show view. You can select the view whichever you want to open. Okay, let's create a new Java project. So open file menu, now select new and select Java project. Or you can also right click on Package Explorer and say new and then select Java project. Both are same. Now let's choose the name of the project, say Hello World. Now you can see Eclipse sets up the project for you. Here SRC stands for source, that is the folder where you will keep the Java source files. Now select the SRC, right click and say new class. Now let's say the name of the class is first, and also select the main method here. Now you can see it created a class structure for you with the main method. Now let me increase the font. Okay. Make it. Now here this is a comment. So that is a simple text that serves as a documentation for the developer. Now you can remove this for now. Now let's put the statement that prints the hello message. You can do that using system.out.println and hello. Now put a semicolon to indicate the end of the statement. Now to run this program, you just need to right click and select Run As and Java Application. Good. You can see the output in the console view. Suppose if you didn't find the console view, you can get it through Window, Show View, and then Console. That's it. You can see how simple it is when you use the IDE. Here IDE stands for Integrated Development Environment. Just nothing but a set of tools which enable you to build the applications faster. Let's take a look at what are primitive data types in Java. Before getting into the topic, let's see how we can associate them with real-world examples. We will pick a basket if we need to store fruits. Now, we will pick a glass if we need to store water. So, we are selecting the container based on content. Hence, we need to know what is the type of content that we are going to store. Similarly, we need to pick the container based on the type of data that we are going to store in it. In programming, we may classify data into numeric types and non-numeric types. We can further classify numeric types into integral types and floating types. Integral types hold only a decimal point value. That is, it doesn't include any fraction part. Examples such as 10, 20 and so on. Floating types allow fraction parts in the data such as 10.2, 20.4, etc. You can see different names under integral types. They vary in size, that is the number of bytes that they occupy in memory. Byte takes 1 byte, that is 8 bits. Short occupies 2 bytes. Integer takes 4 bytes. Long takes 8 bytes. How does it impact you? Let's say we have different sized glasses. Then you will pick the one based on the volume of content you are going to store. Similarly, you can pick byte for storing small values, range between -128 to +127. The value range will increase with the increase in memory size. Our preference will be integer or long in our programs. In case of floating types, there are two different data types, that is float and double. Float occupies 4 bytes in memory. Its full form is floating point value. Double occupies 8 bytes in memory. It stands for double precision floating point value. Accuracy is more in double when compared with float. Our preference will be double whenever we are trying to store some floating point value. Under non-numeric types, you will find character, boolean, and string is a special case in Java. Character can store a single character. It occupies 2 bytes in memory. It holds a 16-bit Unicode value for that character. Example characters are A, B, etc. They are enclosed within single quotes. A boolean holds either true or false. Its size is not clearly stated in Java. All the above are called primitive data types. In case of Java, you can also consider string as primitive data type, considering the special support given to it by the language. It is a sequence of characters enclosed within double quotes. Examples such as apple, a, etc. You can see that even a single character a, if enclosed within double quotes, it becomes a string. Now, let's take a look at variable declarations. Suppose you are looking to hold 100 ml of water. First of all, what will you do? You will take a glass or a bottle which is capable of holding the quantity. Similarly, when you are looking to store a value, you first need to obtain the memory block which can hold that value. For example, in the below statement, we allocated an integer block of size 4 bytes in memory. It can hold some integer value in it. Here, A is called an identifier for that block. Whenever you are referring to A, we mean that we are referring to the memory block associated with A. The assignment statement A equal to 5 will store the value 5 in the block allocated for A. When we say A equal to 7, it will replace the value of A with 7. You are able to change it because this memory block is changeable. Hence the name variable. In full, we have to say A is an integer variable. That is, a memory block which is capable of storing an integer value and it is changeable. Opposite of variable is a constant. A constant, as the name indicates, once initialized, it cannot be modified. For example, final int b equal to 5. In this case, the value given to b is final and you cannot modify the value post initialization. If we try to assign a different value to b, compiler will reject this assignment because b is declared as final. Hence, it is constant. It cannot be modified after initialization. Now let's see what are the best practices followed while naming the identifiers. For a variable name, we start with the lowercase letter and we will capitalize the first letter of each word within the name. In the below example, we declared a variable total count. Within that, we used lowercase for the first letter and capital case C for the next word. Give proper names for the identifiers so that they represent the kind of value that they are going to hold. This notation of changing each subsequent word with capital letter is called camel notation. It is extensively used in Java. In case of constants, we use only capital letters and each new word is separated with an underscore. As you can see in the below example, max count is all capital and max and count is separated with an underscore. This way, when we are analyzing an expression, we can predict if it is a variable or a constant. A small test for you. In the below expression, classify the identifiers whether they are variables or constants. I'll give you 5 seconds. Yes, x is a variable. Y is again a variable. A is a variable. Max should be constant because it's all capital. Let's take a look at literals. Literal is a source code representation of a fixed value. In simple words, it is a direct value which is present in the expression. In this expression, 10 is said to be a literal value. Even the literals should be given a type as they might be stored in memory. Let's see what are the data types associated with literals. By default, 100 is taken as an integer. With suffix L, it is treated as long. When you take 10.23, it is treated as double. 10.23f, that is with suffix f, it is treated as float. Also, integer literals could be represented in 3 different formats, that is decimal, hexadecimal and binary. In this example, 26 is written in decimal form. When we prefix 0x, it means it is a hexadecimal number. When we prefix 0b, it means it is a binary number. Binary format is supported from Java 8. For floating point numbers, we can either directly specify a value or we can use scientific notations for that. When we say 1.234 E2, it is equivalent to 1.234 into 10 square. Character literals are enclosed with single quote. You can also represent special characters with escape sequence slash. /t for tab character, /n for new line feed, /u for specifying Unicode character. String literals are enclosed within double quotes. Let's take a look at what are the standard streams available to the program. Before that, I used the term process here. It is nothing but a program in execution. A program is given 3 standard streams: input, output and error. They can be accessed through the class system, but their source or destination won't be determined until the runtime. Let's analyze. Assume that this input is connected to keyboard and output and ERR are connected to monitor. Now can you tell where this read is getting the data from? Yes, you are right. It is reading from keyboard. Okay, good. Now where this println is sending the data to? Correct. It is monitor. Don't think that this is same for all cases. Let's observe a different scenario. Assume process 1 is connected with process 2. Now the output of first process is the input for second process. Now when you execute the read in process 2, are you getting the data from keyboard or from process 1? Yes, you are right. Now it is the output of the first process given as input to the second process. By now, you might have noticed that these three might change based on how the program is launched. Hence, you just need to think that whenever you are sending the output through system.out, you are sending it to standard output stream and not simply monitor. As far as you are concerned, just keep in mind that you can access the three streams available to you through the class system, and they are in for input, out for output, and ERR for error. These three are called standard streams and they will be determined while the application is being launched. Now, let's see how to read the data from standard input stream. For now, let's say it is keyboard. We have a class called scanner in the package java.util. You need to import it. This import statement and other terminology will be explained during the future lectures. For now, just think that you are indicating to the compiler that you are using the class scanner from java.util package. Now, create an object for scanner and connect it to system.in. Here, the standard input stream is the source for scanner. Now, when you call scan.nextInt, it is going to read the data from standard input stream and will return it as an integer to you. Suppose that you have typed 10 and pressed an enter key. Scanner is going to read that value from standard input stream and then it is going to return that value, and you are storing it in the variable named value. Now, let's see how to write a simple program to add two numbers and display the result. First, create a new Java project. Let's name it add_prj. Okay, now let's create a class with name main and also select the main method. Now, let's declare three variables, name them A, B, C respectively. Now let's put some value into A. Okay, let's put some value into B. Now let's write an expression to add the two numbers A and B and put that into C. This is the expression. The added result of A and B is assigned to C. Now let's display value C. Let's run the program. You can see the output in the console. Let's solve one more problem. We need to calculate the area of a circle and the formula is pi r square. Good. If you are a beginner, let's develop some programming mindset here. Whenever you are solving some problem, first divide the problem into three parts: input, process, output. In case of this problem, what is the unknown to you? You are right. It is R. Put that under input. Now, identify what is the procedure. Given the radius, what's your process? Calculating the area through the expression, it's your process. And this is your expression. Now, display the area. That is your output. Now, we have identified what is the input, what is the process, and what is the output. Similarly, whenever you are solving any problem, you just put these 3 points in mind. Divide what is the input, what is the process, and what is the output. This mindset will be helpful during the initial stages of your coding. Let's see how to code this problem. Now let's create a new Java project. Name it area_prj. Now let's create a main class. And also select the main method. Now we need to declare the variables for holding the data. So we need two variables, one for area and one for radius. Now to read the radius, we need a scanner object. Create the scanner object and attach it with system.in. Now let's prompt so that user will be able to know what is expected. Now enter radius is our prompt. Now let's read the radius. Because radius is double, we need to use scan.nextDouble. Now calculate the area. Area equal to 3.14159 into R into R. Now let's print the area. Okay, save the file and run the program. Now you can see the prompt. Now enter some value for radius and you got the output. Let's take a look at what are the various operators available in Java. The first one, arithmetic operators. Plus for addition, minus for subtraction, / for division, asterisk for multiplication, modulus for remainder. Let's see them with an example. The value of C is 7 plus 4, that is 11. The value of D is 7 minus 4, that is 3. The value of E is 7 divided by 4, and you will find 1. You will know why it is 1 in the coming lectures. The value of F is 28. The value of G is 3, that is the remainder when 7 is divided by 4. Can you try the below expressions? Okay, so what is the value of 11 mod 2? Yes, it is 1. What is the value of minus 11 mod 2? You are right, it is minus 1. What is the value of 11 mod minus 2? Here it is 1. What is the value of minus 11 mod minus 2? Here it is minus 1. You can try it yourself. Okay, so the shortcut is the sign of the result will be equal to the sign of the numerator. Here are the very famous operators from C language, plus plus and minus minus. They are called increment and decrement operators. They should be used over a variable and not over a constant. The purpose of this operator is to increment the variable by 1, but their meaning will change based on their position around the variable. When we use plus plus after the variable, it is called post increment. When we use plus plus before the variable, it is called pre increment. Let's see how the behavior changes with this position. Given the value of variable a is 5, now either a plus plus or plus plus a is going to make it 6. You will not see much difference when it is used alone, but when it is part of an expression, you will see the difference. Let's see how it varies. Now let's see the post increment case. The value of variable a is 5. Now when we say a plus plus, you are indicating that a should be incremented later, which means the value of a 5 is substituted in the expression. This makes b equal to 5, and then a is incremented by 1, that is a becomes 6. But when we say plus plus a, you are indicating that a should be incremented before substitution, which means a will become 6 and then the value 6 is substituted in the expression. This makes c as 6. So the value of a will be 6 and c will be 6. Similar is the case with minus minus operator. It is going to decrement the value of a variable by 1. As a shortcut, just think that when we say a plus plus, increment a later, but when we say plus plus a, increment a before. That's it. Now let's take a look at what are relational operators. They are greater than, less than, greater than or equal to, less than or equal to, and not equal to. They identify the relation between two numeric values. They return true if the corresponding relation is satisfied, otherwise false. In this example, a is 5 and b is 6. A less than b is true. In the second case, b greater than c, that is 6 is greater than 6, is false. 6 is equal to 6. Hence, the third case will be true, second one will be false. Since these expressions are returning true or false, we took the variables d, e, f as Boolean. Now let's take a look at what are the logical operators available. This is AND, OR, and NOT. They operate on the logical values of the expression, that is, the Boolean values of the expressions. Hence, they are called logical operators. AND is going to return true when both the expressions are true. OR is going to return true when either one of the expression is true. NOT negates the expression, that is, if the expression is true, NOT will return as false. If the expression is false, NOT will return true. Now let's understand this through an example. The value of A is 20, B is 15. 20 is greater than 15, condition is true. In the second part, A is 20, C is 35. 20 is greater than 35 is false. Hence, one of the expression is false and is going to return false. Now let's take a look at the second one. 20 greater than 15 is true and OR needs only 1 to be true. Hence, the result is true. Now in the third one, 20 greater than 15 is true. Not true is false. Hence, the value of f will be false. There is an interesting fact about these logical AND and OR operators. So that is their short-circuiting nature. In case of AND, if the first expression is false, it is not going to evaluate the second expression. Predict the values of A, B and C in the below expression. I will give you 5 seconds. Because A++ is evaluated, A will be 11. But it is a post increment. So the current value of A, that is 10, will be substituted here. And 10 is greater than 10 is false. Hence, AND is going to return false because first expression is false and AND will not continue with the second expression. So the value of C is false. Because the second expression B++ is not evaluated, B will remain as 20. Similarly, OR is not going to evaluate the second expression if the first expression is true. Let's take a look at what are bitwise operators. Supported bitwise operators are bitwise AND, bitwise OR, bitwise XOR, and complement. They operate on the individual bits of the given number and hence the name bitwise operators. Let's take a look at it through an example. Here, when we say C equal to A ampersand B, we are trying to perform bitwise AND operation between A and B. Let's see how the operation is performed. The value of A is 5. Now when we write it in binary, its value is 101. Now the value of B is 6. So in binary, its value is 110. Now perform a bitwise AND. 1 and 0, 0, 0 and 1, 0, 1 and 1, 1. Hence the answer is 4. Now let's do bitwise OR. 101 bitwise OR 110. 1 or 0, 1, 0 or 1, 1, 1 or 1, 1. Hence the answer is 7. Similarly, let's do bitwise XOR. The shortcut for performing the XOR operation is if opposite bits means 1, if equal bits then 0. So 1 XOR 0, opposite bits, hence 1. 0 XOR 1, opposite bits 1. 1 XOR 1, equal bits 0. Now the answer is 3. Here is the interesting operator, complement. To understand this, we need to understand a bit more about how the memory structure is organized for an integer. As we know, the size of an integer is 4 bytes, that is 32 bits. Out of 32 bits, the leftmost bit is called sign bit. If the sign bit is having value 0, then this number is said to be a positive number. If the sign bit is having a value 1, then this number is said to be a negative number. Now when we say A equal to 5, we need to know how it is stored in memory. Because it's a positive number, sign bit value will be 0. And then in the rest of the bits, we will find the binary equivalent for 5, which is 101, prefixed with zeros. Now when we do the complement, all the zeros will become 1 and all the 1s will become 0. In this case, it turns out to be all 1s followed by 0, 1, 0. Now because in the result, the sign bit is 1, this number is a negative number. So the rest of the bits doesn't represent the original number. They represent the 2's complement of the original number. Now to get the original one, we need to do a 2's complement of this number and then take it as a result. For that, you need to do a reverse of this number again, and then you should add 1 to that, which makes it 110. Hence, it is 6. Hence, the final answer is -6. Let's take a look at what are shift operators. As the name implies, they shift the individual bits of the number to either left or right. Now, first let's take a look at what is a left shift operator. It shifts the bits in the given number to the left. Now, in this example, when we say a less than 2, we are asking the shift operator to shift a by 2 bits to the left. In such case, you will find the leftmost 2 bits getting dropped and gaps are added to the right, and these gaps are filled with 0, and this will be the resultant number. There is a small variation in case of right shift. You will find two different right shift operations. One is signed right shift and the other is unsigned right shift. Anyway, in the right shift, you will find the rightmost bits getting dropped. Now the variation is what is filled in the gaps which were formed to the left of the number. In case of signed right shift, the gaps will be filled with the previous sign bit value. In case of unsigned right shifts, they are filled with 0. Hence, in case of signed right shift, if the number is a positive number, the filled bits will be 0 because sign bit will be 0. Now, in case of a negative number, the filled bits will be 1 because sign bit will be 1. In such case, you will see that the negative number remains as negative. Now, if a negative number is right shifted using unsigned right shift, then the number immediately turns into positive. Now, let's take a look at what are assignment operators. The main operation of the assignment operator is to assign the value obtained on the right hand side to the variable on the left hand side. In the first example, the value 10 is assigned to variable a. There is a special property for the assignment operator. It returns the value which was assigned. Now, in this case, when we say b assigns to c assigned to a, c is assigned the value of a, and also as part of that expression, it returns the assigned value. Because the value of a is 10, it returns the assigned value, that is 10, and which is then assigned to b. Can you predict what will happen when we say a assigned to b assigned to c assigned to 0? Yes, all three variables will be assigned the value 0. There is another set of assignment operators, that is arithmetic assignment operators. They will evaluate the RHS value and they will perform the given arithmetic operation over the variable and they will assign the result to it. In this example, when we want to add 5 to b, instead of writing b equal to b plus 5, we can simply write b plus equal to 5. This is going to add the value 5 to b and the result is again stored back in b. That is, after this expression, b becomes 15. Now let's take a look at what is a ternary operator. It is also called as a conditional operator. It has three parts to it: the conditional expression, expression 1 and expression 2. Expression 1 will be evaluated if the conditional expression evaluates to true. Expression 2 will be evaluated if the conditional expression evaluates to false. Let's take a look at it through an example. Here in this case, a is 10, b is 2. When we say a greater than b, question mark a colon b, if a greater than b condition is true, then a will be the result. Otherwise, b will be the result of the expression. Now, based on this example, 10 is greater than 2, hence condition is true. So, a will be the result and a is assigned to c. Hence, the value of c is 10. Because we know the values, we know that a is assigned to c. Otherwise, c will take the biggest among the two. That is, it could be either a or b, whichever is the biggest. Up to now, we have classified the operators based on the operation performed. We can also classify the operators based on the number of operands that it accepts. First of all, in the expression a plus b, a and b are called the operands and plus is the operator. Now, based on the number of operands that it accepts, we can classify the operators into three types. One is unary, binary and ternary. Unary operators, they take only one operand. Examples such as minus a, complement of a, or not of a greater than b, etc. Now, in case of binary operator, you will find two operands. A plus b means a and b are two operands and hence the name binary. In case of ternary operators, we will find three operands, hence the name ternary. Let's see how the type conversion happens during the expression evaluation. When an arithmetic operation is performed, both operands should be converted to the same type before the expression could be evaluated. Let's see what happens in the below scenario. What should be the type for C? A is an integer, B is long. When an integer is operated with long, integer is implicitly promoted to long. Hence, A will be promoted to long for this expression, and then the result will be long. Hence, the data type for C should be long. Can you guess what should be the type for C? Yes, C should be float, because when an integer is operated with a float, integer should be converted to float, as it doesn't incur any data loss. In this case, A is an integer, B is a float. Now integer is converted to float. Result will be float. Hence, the data type for C should be float. Now guess what should be the type for C? Yes, it should be double. A is long, B is double. Long is promoted to double. Now double when operated with double results in a double. Hence, the data type for C should be double. Having seen the previous conversions, can you guess what is the value of C? It is 5.0 and not 6.25. Let's see why. A is an integer, B is an integer, integer by integer. Since no conversion is required, it results in an integer. Now that is 5 by 2, which is 2, and not 2.5, because we took only the integer part of it. Now 2 is an integer and 2.5 is double. Now integer is converted to double, hence it is 2.0. 2.0 into 2.5, answer is 5.0. There are two ways to fix this problem. The first one is swap the elements in the expression. Now let's say that C equal to A into 2.5 by B. In this case, A is an integer, 2.5 is double, B is an integer. Let's evaluate. Integer into double. Now integer is converted to double. That is, the value of A is 5. Now it is converted to 5.0. Now 5.0 into 2.5. Answer is 12.5, which is a double. Now double by integer. Integer is converted to double. Hence the value of B is 2, and now it is 2.0. Now 12.5 by 2.0, that is 6.25. Another approach is an explicit cast. Let's take a look at it through the below expression. Now here A is an integer. Now we explicitly casted A as a double. Hence, as part of this expression, compiler promotes this operand as double. Now double by integer. Integer is converted to double, result will be double. Hence, it is 2.5. Now double into double, which is a double. Hence, the answer is 2.5 into 2.5, that is 6.25, and it is assigned to C. Hence, make sure that when you are writing an expression, it is properly casted to get the right end result. One more important aspect to remember. Java doesn't directly support the data assignments which might incur data loss. In case of first example, it stops you from assigning A to B because A is long, B is an integer. If you assign A to B, there is a possibility of data loss. Hence, such assignments are blocked. If you are forced to do such assignments and you are absolutely sure that there is no data loss, then you might typecast and assign. Also, in case of second example, you might not directly notice any problem with this expression, but if you can recollect, floating point literals are by default double. Now 2.4 is double and f is a float. Hence, you cannot directly assign. You either need to use the suffix f or you can typecast. Let's take a look at if statement. If statement allows you to make a decision before executing a statement. There are three variations of if statement: simple if else, and nested if. In case of simple if, statement is executed only if the condition is true. If the condition is false, statement will be skipped. In case of if else, statement 1 is executed if the condition is true. If it is false, statement 2 is executed. That is, if the condition is true, then this is the statement to run. Otherwise, this is the statement to run. In case of nested if, you will find an if statement within another if statement. In this case, statement 1 is executed if condition 1 is true. If the condition 1 is false, next statement to be executed will again depend on another condition, that is condition 2. If it is true, then statement 2 will be executed, otherwise statement 3 will be executed. Let's take a look at a simple example. Here we are trying to find the biggest among 3, that is A, B, C, and it will be stored in big. And this is our statement. Our first condition is A greater than B and A greater than C. A greater than B is true, as the value of A is 25 and B is 20. 25 is greater than 20. But A greater than C is false, as A is 25 and C is 30. 25 is greater than 30 is false. Hence the control will go to the else part. Now again we have one more condition, that is B greater than C. The value of B is 20 and C is 30. Hence B greater than C is false. Hence else block is executed and C is assigned to big, and you will see 30 printed. Here is an important aspect you need to remember. In this example, if day is given as 2, then what is the output? You might think that nothing is printed, but you will get everyone. And this is because if considers only one statement under it. Hence only this statement comes under if. Although the second statement seems like it is under if, but it is not. To make both the statements as a single statement, we need to use braces, that is curly brackets. It will combine multiple statements into a single one. It is also called as a block. Now, because you combined these two statements into a block, the entire block is executed if the condition is true. Otherwise, the entire block is skipped. Now, let's solve a simple problem. We need to accept bill amount and we need to apply the discount and then display the net amount. Now, the discount will be if bill amount is greater than 1000, then you should apply 10% discount. Otherwise, you should apply 5% discount. Let's see how to code this problem. First, create a new Java project. Let's name it ifprj. Now create a new class. Let's name it main and also select the main method. Let's declare two double variables, bill amount and net amount. One for holding bill amount and the other for holding the final amount. To read the bill amount, we need a scanner. Let's create it. Now let's prompt enter bill amount. Now read the value. If you remember the statement, we need to apply 10% discount if amount exceeds 1000, otherwise 5%. Now let's put that into the condition. And the condition is if bill amount is greater than 1000, then net amount equal to 90% of the bill amount. Otherwise, net amount is 95% of the bill amount. We are done. Let's display the net amount. Now let's run the program and let's enter some value for it. Now let's enter 2000 and you can see it applied 10% discount. Let's run it again. Now let's enter 500. Now you can see it has applied 5% discount. Let's understand switch statement through an example. Create a new project. Let's name it switch prj. Let's create main class and also select the main method. In this example, we are going to print the day of the week based on the given number. Say 1 for Sunday, 2 for Monday, etc. Let's declare a variable. Let's name it day of week. Now to read the data, we need a scanner. Let's create it. As usual, display the prompt. Now let's read the value. Now let's write the logic. Switch day of week. Now let's begin the block. Now in case 1, let's print Sunday. Now in case 2, let's print Monday. Now we need to break each case because after executing the logic associated with the case, we need to stop the switch statement. Let's write the default case. Default case will be selected if no other case matches with the expression. Now let's close the switch statement. Now if you look at it, it looks more readable. We seldom use the switch statement anyway. Let's run the program. Let's enter some value, say 2. Now you can see the result. Run the program again. Let's enter some invalid value, say 9. Now you can see the default case getting executed. Let's see what happens if we remove the break statement. Let's remove the break for one of the case. Let's say 2. Run the program. Now enter 2. You can see the output associated with case 2 and case 3. What happened here is, when the control enters into the case, it proceeds till the end of the switch statement, or it should encounter break statement. Let's take a look at it through an example. If you can see this example, there is a common logic for the case 1, 2 and 3 and the same for the case 4, 5 and 6. In such cases, you will find the switch statement like this one. Let's take a look at while statement. It is an iterative statement which helps us to repeat a particular statement as long as needed. It needs a conditional expression and a statement to repeat. As you can see, this is how the flow looks like. If the expression is true, then it executes the statement and goes back to recheck the condition. If the conditional expression is still true, it comes inside and executes the statement. And this happens as long as the expression is true and comes out when the expression becomes false. Here is a simple example that prints the hello message for 5 times. Let's evaluate. N is initialized to 1. 1 less than or equal to 5. Condition is true. It comes inside and prints the hello message. N++ implies n becomes 2 and control goes back. Now check the condition again. 2 less than or equal to 5. It is true. Comes inside and prints hello. N++, n becomes 3 and so on till n becomes 5. 5 less than or equal to 5. Condition is true. Comes inside, prints hello for 5th time. N++, n becomes 6. 6 less than or equal to 5 is false and hence while stops. Let's solve one more problem. Let's find the factorial of the given number. First of all, n factorial is the product of all the numbers from 1 to n. Here we took 3 variables, n, I and fact. Fact will hold the factorial value. I is the counter variable. Let's see how it works. N is initialized with 5. That is, we are trying to find the factorial of 5. Fact is initialized with 1 and I is initialized with 2. I less than or equal to n, that is 2 less than or equal to 5. It is true. Comes inside. Fact equal to fact into I, that is 1 into 2. 2 replaces the value in fact. Now I++, I becomes 3, goes back. 3 less than or equal to 5 is true. Comes inside. fact equal to fact into I. So 2 into 3, that is 6. 6 replaces the value in fact. I plus plus, I becomes 4. Fact equal to fact into I, 6 into 4, that is 24. I plus plus, I becomes 5. 5 less than or equal to 5, condition is true. Fact equal to fact into I, 24 into 5, 120. I plus plus, I is 6. 6 less than or equal to 5. It is false, comes out, and the value of fact, that is 120, printed. Let's solve one more problem to check if the given number is prime or not. Let's see how to code this problem. Create a new Java project. Let's name it while prj. Create a class, name it main, and also select the main method. We need to find if the given number is prime or not. A prime number has two factors, that is 1 and itself. Let's solve the problem through simple approach, not worry too much about efficiency. To hold the given number, let's declare a variable n. To read the value, let's create a scanner object. Now prompt and accept the value. Now we want to check if the given number is prime or not. Let's declare a variable count to keep track of number of factors and also I for the sake of the loop. Let's initialize count with 0 and I with 1. Now the condition is we need to repeat the loop for each value of I from 1 to n. Hence while I less than or equal to n. Begin the block. Check if I is a factor of n. That is, if n mod I equal to 0. Then you found a factor. Now increment the count. Take next value for I, that is I plus plus. Now you can see that count is incremented for each factor of n. After the loop, for n to be prime, count should be 2. That is, it should be incremented once for 1 and again for n. If the count is equal to 2, you can say that n is prime, otherwise not. Let's run the program. Let's enter n, say 7. You can see it is prime. Run the program again. Let's enter 8. You can see it is not prime because factor count will be 4. We understood the while statement. Now let's take a look at what are the other options available for us. We have two other options, that is do while and for. In total, these are the three iterative statements available. The main task of these three statements is to repeat a statement for required number of times. Then why 3? Let's compare. You already know the while statement. In this example, this is the initialization. This is the condition. And as long as the condition is true, it will execute this particular statement. And this is the next increment for I. Now, these three parts, that is initialization, condition, increment or decrement, all three are at 3 different locations. It will be more readable if they are kept at one place. And for that, we have for statement. In for statement, you see initialization, condition and increment at one place. Initialization part is executed only once, that is before entering the first statement. This condition is verified each time before getting into the block. Like while statement, for will execute the block or the statement only if the condition is true. And from the second iteration onwards, the increment part will be evaluated before checking the condition again. In case of do while, no initial check happens. Control will enter the block, and to go back, condition will be verified. That's why it is called exit control statement. And the other two, that is while and for, they are called entry control statements. Can you analyze what is the output? In case of while, you will not see any output because I is 11 and 11 less than 10 is false. Hence, the statement won't be executed at all. In case of do while, you will see hello once because though I is 11, there is no initial condition check. Hence, statement is executed once and hello is printed. Now I is 12. To go back, we have a condition check. 12 less than 10 is false, hence the statement is stopped. But you will see the hello output once. Let's see what is a break statement. You have seen it earlier with switch statement. Similarly, here in loops, it gives you an opportunity to stop the loop in the middle. This is for scenarios where we might have got to a conclusion in the middle of the loop and there is no need to proceed with the rest of the iterations. In such case, we will use break statement. Let's see what happens here. I is 1. 1 less than or equal to 10 is true. 1 printed. 1 equal to 5 is false. Hence the break statement is skipped. Next I becomes 2. 2 less than or equal to 10. Condition is true. 2 printed. And this happens till I becomes 5. Now what happens when I equal to 5? 5 less than or equal to 10. Condition is true. 5 printed. Now 5 equal to 5 is true. Hence the break statement is executed and the loop will be terminated. Control comes out of the loop. Now let's take a look at continue statement. Unlike break, continue will take you back to the next iteration without executing the rest of the block. In this example, when I equal to 5, I is incremented and continue will take you back to the next iteration. Hence you will see 5 skipped in the output. Let's see what are arrays. An array is a collection of homogeneous elements. All the elements are identified using a single identifier. Individual elements could be accessed using their index. Index begins with 0. That is AF0, AF1, AF2, etc. The main advantage you get from an array, you can write some logic on AFI and simply change I from the desired starting index to ending index. The same logic is applied on all those elements. Let's understand how to create and manipulate an array in Java. Before that, you need to understand what is a pointer. Here is a house with some address. Assume I have a piece of paper with the address in it. When you look at it, you may feel like it is pointing to that house. Similarly, if a memory block is holding the address of another block, then it's called a pointer. Java doesn't support pointer arithmetic or pointer based operations directly, but all reference variables in Java are nothing but pointers. Let's see them in operation now. When we declare a variable like this, we are creating a reference variable or a pointer to an integer array in memory. It's like you obtained a piece of paper where you can write the address, but still you need to identify the house first. Now let's see how to allocate memory for A. And this is the allocation statement. Here, we allocated an array of 5 integers and assigned its reference to A. Just like this one, you constructed a new house and you kept its address in this block. Now you can access the elements through their index, that is AF0, AF1, etc. Only thing you need to remember is you cannot access the array beyond its boundaries. You cannot use AF-1, in this case AF5. If you do so, Java will throw array index out of bounds exception. Let's see how to initialize an array. Java supports two approaches. This is how we can do during the declaration itself. If you skipped it during declaration, Java supports another approach. You can do it this way. One more important thing to note. In the first case, a is a reference variable to an array of integer variables, but b is simply an integer variable. In the second case, both a and b are reference variables to an array of integer variables. Let's see how to write the logic to find the biggest among an array of integers. Here is an array with values. Now we want to find the biggest among them. Let's assume that the first element is biggest, that is 10. We will start from 1 and will go till length minus 1. We will check if any element is greater than big. If we find 1, then we will replace big with that. Let's trace it. Start from I equal to 1. A of 1 greater than big, that is 5 greater than 10, is false. Let's move forward. I becomes 2. A of 2 greater than big, 15 greater than 10, it is true. Now change the value of big to 15. Move forward. I equal to 3. A of 3 greater than big, that is 2 greater than 15, it is false. I equal to 4. A of 4 greater than big, 41 greater than 15, it is true. Change big to 41. I equal to 5. A of 5 greater than big, 3 greater than 41, it is false. At the end of the loop, you will see that big is holding the biggest value among the array of values. Let's see how to code this problem. Create a new Java project and name it ArrayPrj. Create a main class and also select the main method. Let's create an array and fill it with values. Let's declare a variable big and initialize it with a of 0. Now, we have assumed that the first element is biggest. Now, let's iterate through the rest of the array. That is, for I equal to 1, I less than a dot length, I plus plus. Here, a dot length gives you the length of the array. Now, check if a of I is greater than big. If so, change the big to that value. After the loop, big will hold the biggest value among the array of values. Now let's print the big. We are done. Let's run the program. You can see the result. Instead of using the index-based for loop, we have an enhanced for loop for arrays. That is, for int value colon a. You can read it as for each integer value in a. The variable value will take the first value and then the second value and so on. Now, you can read the entire logic as for each integer value in a, if value is greater than big, then change big to that value. Finally, print the big. Let's run the program. You can see the result. Now let's take a look at how to write functions. Before learning functions, we need to understand the necessity behind it. Assume these are the instructions. You can see there is a repetition. Now when the memory was too costly for a mere kilobytes, this repetition is not acceptable. To avoid repetitions, macros concept was introduced. Assume we have defined a macro for ABC, say X. Then these instructions could be replaced with macro calls, such as this. Advantage with this is you have reduced the repetitions, but the disadvantage is you have not reduced the code length. And that is because wherever there is a macro call, translator will replace the actual call with the definition. Hence, the code length is not reduced. To solve this problem, functions concept was introduced. It not only reduces the repetitions, it also reduces the code length in memory, as it won't be expanded. In this case, assume x is a function with definition containing ABC. Now let's evaluate and see what happens here. Assume execution begins here. It executes 1, then 2. Then there is a call to x. Hence control goes from here to here. Then it executes ABC, which are part of x definition. Once done, control comes back to the calling function and proceeds with the rest of the instructions, that is 3, 4, and again there is a call to x. Control goes from here to here, executes ABC, and comes back, proceeds with the rest of the instructions, that is 5. It should be clear for you now. Functions has not only reduced the code redundancy, but it also reduced the code length. Let's see how we can define functions. Mathematically, if I give you a function like this, big of a comma b equal to a if a greater than b, b otherwise, then what are the values of x, y and z? Yes, the value of x is 10, y is 20, z is 21. Here, inner call is evaluated first and then the outer one. This is the function definition. These are the function calls. Now, what is the role of a and b? Yes, they are here to accept the incoming values. Their values are determined during the call. Let's translate this function to a function in Java. Big is the name of the function. A and b are the names of the parameters. We must specify the data type for a and b. Let's say double. Just think, do you need to return any value from this function? Yes, you need to return the double value, because what you are going to return is the biggest among a and b. A and b are of type double, and hence you will be returning a double value from this function. Let's write the function definition. If a greater than b, then return a. Else return b. This is how you can write a function in a program. The variables here are called parameters, and they are going to accept the incoming values. And this is what you will return. The values which we pass to the function are called arguments to the function. Let's write a sample program. Create a new Java project and name it function prj1. Create a main class and also select the main method. Now, let's write a function big with parameters a and b of type double. Let's specify the return type as double. Let's begin the block. And this is the logic. If a greater than b, return a, else return b. Let's change it to static, and for now just remember it. We will cover this in the future lectures. Let's test the function. Double x equal to big of 5, 10. double y equal to big of 15, 20. Now first time we are calling the function big with values 5 and 10 for a and b, and this function is going to return the biggest among those two, that is 10, which will be assigned to x. In the second call, we are passing 15 and 20 for a and b, and it is going to return 20, which is then assigned to y. Let's see how it is executed through debugging. Let's put a breakpoint here. Right click and select debug as, and also select the Java application. It prompts for debug perspective. Choose yes. You can see the execution stopped at the breakpoint which we mentioned. You have two important options here, step into and step over. When you want to look inside the function and see what is happening, then you need to select step into. When you are familiar with the function and you don't want to look inside the function and see what is happening, you can simply execute the function through step over. Here, let's do step into. Now you can see a is 5 and b is 10. Let's get in. If a greater than b, yes, the condition is false. Control enters the else part. Return b is executed. It returns 10. After executing return b, control comes back to the calling function. Return value is then assigned to x. Similarly, you can trace the second line as well. Let's select step over because we are already familiar with big. And you can use the resume button to simply proceed with the execution till the next breakpoint or till the end of the program. In this example, we have written a simple function named big which accepts two values, that is for a and b, and it will return the biggest among these two. Once we define the function, we can call the same function again and again with different set of values. The values which we pass to the function are called arguments. Variables which receive those values are called parameters. The return statement enables you to return a value from the function. Main purpose of this statement is to take the control back to the calling function. In this example, we are going to calculate the value of NCR, and the formula is n factorial by r factorial into n minus r factorial. We need to calculate the factorial for three different values, that is one for n, one for r, and one for n minus r. Create a new Java project and name it function prj2. Create main class and also select the main method. Let's declare two variables here, n and r. Create scanner for reading the data. Let's prompt and accept the values for n and r. Now that you got the values, let's calculate n factorial. And for calculating the n factorial, we need to multiply all the numbers from 1 to n and hold the result in a variable. Now let's write a loop that starts with 1 and goes till n. Multiply each value of I into n fact. Now at the end of the loop, you calculated n factorial value. Now let's calculate r factorial. we need a variable to hold the value of r factorial. Hence declare a variable rfact and initialize it with 1. Now let's write a loop that starts with 1 and goes till r. Capture the product of I in the variable rfact. Now at the end of the loop, you got r factorial. Now we need to calculate n minus r fact, and to hold that, let's declare a variable n underscore r fact. Minus is not valid for an identifier, hence we used underscore. Let's initialize it with 1. Now let's write a loop that starts with 1 and goes till n minus r. Capture the result in n underscore r fact. Now at the end of the loop, you calculated n minus r fact. Now let's calculate the result. Result is n fact by r fact into n underscore r fact. Print the result. You are done. Let's run the program. Now give the value for n, say 5. Now give the value for r, say 2. You can see the result. If you can observe the program, we have calculated the factorial thrice. That is, we have repeated the logic for n fact, r fact and n minus r fact. This is redundant. Now we need to reduce it. In order to reduce the repetitions, let's create a function fact which accepts a value m and returns m factorial. Let's write that function. Let's name the function fact and accept m, which is an integer. The return type for fact is int because we will be returning an integer which is a factorial of the given number. Begin the definition. Let's capture m factorial in the variable f. Write the loop that starts with 1 and goes till m. Now calculate the product. At the end of the loop, you captured m factorial in the variable f. Return f. We are done with the function. For now, add static before the function fact. Now, you can replace the loops with function calls. Let's remove n fact loop and now change it to fact of n. Here, we are calling the function fact with value n. In return, we are going to get n factorial. Now, replace r fact with the function call. In this case, we are passing the value r, and in return, we are going to get r factorial. Now replace n minus r fact logic with function call. In this case, we are passing n minus r value to the function, and in return, we are going to get n minus r fact. Rest of the things will remain the same. Now if you can see, we have replaced the entire logic with 3 different function calls. First time, you passed n and you got n factorial. Second time, you passed r and you got r fact. Third time, you passed n minus r and you got n minus r fact. Let's run the program. Enter the value for n, say 5. Enter the value for r, say 2. You can see the result. Let's take a look at one more interesting aspect that you need to know about functions. Before you can say you are good at functions, I am going to write a code snippet. You need to tell its output. Tell me what is its output. Let's run the program. You can see it is 10. Why it is not 15? Let me explain. Here, n is a local variable with value 10. And when you call the function change with value n is copied into m. Now m is going to get a copy of 10. When you are adding 5 to m, you are modifying m. Local variables are going to get destroyed immediately after the end of the function. Hence, m gets destroyed, and when you come back, when you print n, you are going to see 10 because we didn't modify this block. Now I am going to change the program slightly. Tell me what is the output. Let's run the program. You saw 0. Why? Let me explain. When you passed a to the function, we are copying the value of a into b, which is nothing but pointer to the same block. Within this function, if you can see, b is also pointing to the same memory block. Now when we refer to b of 1, it will change the value in this block. Now at the end of the function, b gets destroyed, but not this block. When we come back and try to print the value of a of 1, you can see the value 0. And this is the difference between passing the value and passing the reference. When you are passing a reference to the original object, you need to remember that the original object could be modified from within the function. Let's start with the fundamental element of object-oriented programming, a class. A class is a template to design an object. You can assume this rubber stamp as a class, and the imprints that you get from it are objects. You can observe each object owns a copy of attributes. One more example. Let's say ABC are humans. Then here, human is a class, and ABC are instances, also called as objects, of type human. I think by now you can identify the difference between a class and an object. Let's understand this with an example. Let's create a Java project and name it classes prj1. Create a main class and also select the main method. Let's design a class bike. A class combines two things, data are attributes, and operations, also called as methods or behavior. Just think, what are the attributes of a bike? I can think of color, model number, engine capacity, weight, whether the power is on or off, etc. For this example, let's take power as a Boolean variable. True indicates powered on, false indicates powered off. Also, let's add speed, which holds the current speed of the bike. What operations you can perform on a bike? We can start a bike. We can stop. We can accelerate. Let's say print state. When we start, let's switch the power on and set the speed to 0. When we stop, let's switch the power off and set the speed to 0. When we accelerate, set the speed to the new speed. In the print state, let's display the value of the attributes. Now you can see we have defined the class. These are the attributes of the class, and these are the operations which are allowed. In order to make use of this class, first we need to create objects, and then we can start performing operations. Just like, in order to start a bike, you first need a bike, isn't it? When we declare B1 and B2 of type bike, we are not creating two objects. Instead, we are creating two reference variables, which can point to an object of type bike. In this case, when we say B1 equal to new bike, we have created an object of type bike in RHS, and we have assigned its reference to B1. When we say B2 equal to new bike, we have created a different object, and then we assigned its reference to B2. As you can see, B1 and B2 will have their own copy of attributes. Now when we say B1.start, the start operation is performed over B1, hence attributes from B1 are used. When we say B2.start, operation is performed over B2, hence attributes from B2 are used. When we say B1.accelerate of 50, accelerate operation is performed over B1. In real time, you can imagine this with starting a first bike, starting a second bike, and accelerating the first bike. When we say B1.print state, it prints B1's state, that is, the attribute values of B1. When we say B2.print state, it prints B2's state, that is, attribute values of B2. Now you can imagine what is meant by a state of an object. It is nothing but the attribute values. So what is the state of B1? It is on and moving at a speed of 50. Now what is the state of B2? It is on and idle. To summarize, a class is a combination of attributes and operations. By nature, it is a template to create an object. Object represents a physical instance of a class with its own attributes. Attribute values represents the state of an object. Each object will possess its own state. Object dot operation is nothing but performing the operation over the given object. In the previous video, we have seen what is a class. Before we can dive deep into it, we need to understand what is encapsulation and data hiding all about. In structured programming, we normally see data and operations over the data as two separate entities. And because of that, we could not restrict direct access to data. Hence, client code could access both data and operations. In case of object-oriented programming, data and operations are combined as a unit. This process is known as encapsulation. With the help of this process, we can restrict direct access to data and allow only operations to operate on it. And this process is known as data hiding. Now let's take a look at it through an example. Create a new project and name it classes prj2. Create main class and also select the main method. Now let's design the class account. To keep it simple, let's declare only one field, say balance. Initialize it with 0. This initialization is not mandatory because by default, all the data members are initialized to 0 and reference types are initialized to null by default. Anyway, just keep it for readability. We are looking to support three operations here. Debit certain amount, credit certain amount, show balance. Now, let's define the debit operation. Deduct the amount only if it is valid and there is sufficient balance. Now let's define credit operation. Credit the amount only if it is valid. In show balance, just display the balance. Now let's create an account object and perform few operations on it. Account A1. Here A1 is a reference variable. Let's create an object and assign its reference to A1. When we say A1.credit 2000, we are requesting the credit operation to be performed over A1. Let's say A1.debit 1000. When we say A1.showBalance, it will display the balance. Up to now, this is fine. Now what happens when we directly assign minus 2000 to balance? As you can see, we are not restricted. Let's see what is the balance after this. Let's run the program. You can see second time it displayed minus 2000. And this is the problem we are looking to solve. We don't want the data to be modified directly. Now let's adjust the code. Change the access modifiers for these methods to public. Change the access modifier for balance to private. We will talk about these modifiers in detail in future videos. As you can see, we are not allowed to modify the balance directly now, because balance is a private member in the class account. That is, it is given internal access, which means only the members of the class can access it now. We can only call any of the defined operations. Now if we change this to either debit or credit, either of them will not accept this amount because it is negative. This way, by means of going through the designated methods, we can ensure that the proper constraints are enforced while modifying the data. Please note that this is not anywhere related to security. Here we are trying to structurally organize the code. That's it. If you look at the class account, there are 4 members: balance, debit, credit, and show balance, out of which balance is a private member, that is internal member for the class. Debit, credit, and show balance are made public. That is, they are given public access. Now whoever is accessing this class, they cannot directly access balance. They can only call any of these operations. We could do this because we have combined data and operations as a unit, which is known as encapsulation. And restricting direct access to data is called data hiding. It is not hidden. It is only hidden for direct access. Now let's see what actually an object is and what is its need. Create a new Java project and name it classes prj3. Now let's create a main class and also select the main method. For an absolute beginner, it is slightly tricky for them to identify attributes, methods, and so on. Let's try now. We will design a class shopping cart and we will try to keep it simple. Let's support only 2 operations: add to cart and order. Why I started with operations first? For a beginner, if you are unsure of what attributes to add, just start with operations. Now just think, if someone calls add to cart and gives you a product, you need to store it somewhere, and it looks like it is not going to be a single element. They may add as many products as they like, and hence some collection is the best choice here. As part of the Java library, you will find several implementations for collections under java.util package. You will find them in detail under collections lectures. For this example, let's use linked list. For now, assume that this products collection is our data part. Now add the given product to the collection. In this order method, we will just print the selected elements to keep it simple. Now let's see its usage. We need a cart object to add the selected products. Let's create it. Now let's add 3 sample products to the cart. Now order them. Let's run the program. You can see the ordered products here. Let's analyze. What is cart object doing here? If we can visualize, objects holds data, and also it is responsible for capturing the information between operation calls. And also, if you create multiple cart instances, each cart will have its own selections. Although selections might be same among them, they stand different as they are different objects. Now, let's take a look at what is method overloading. It is a process of having two or more functions with the same name under the same scope. Now let's see that in action. Create a class sample. We will add a method print that accepts an integer. Here we will just print the value, say int followed by value. Now let's write one more method with the same name. Only difference is change in parameter, that is double. Now let's add one more, that is print with string a. Now we have three methods here. Print that accepts integer, print that accepts double, and print that accepts string. If you can observe, they all are having the same name, that is print. When someone is calling print, how the compiler can recognize which print method is invoked? It is based on the arguments passed to the function. If integer is passed, then this is picked. If double is passed, then this is picked. If string is passed, then this is picked. Let's see its usage. We need to create an object first. Sample obj equal to new sample of. We created an object. Now let's call print with 10 and print with 10.2 and print with ABC. First time 10 is an integer and hence this function is invoked. 10.2 is double, hence this function is invoked. Now ABC is a string and hence this function is invoked. Let's debug. Put a breakpoint here by clicking on the vertical bar. Right click and select debug as and Java application. Let's see where it goes. Select step into. You can see it went to print that accepts integer. Now in case of 10.2, it went to print that accepts double. In case of ABC, it went to print that accepts string. What is the advantage you get from this? It is cumbersome to maintain separate names for each method such as print int, print double, print string. You can simply maintain a single name for single functionality. You can see several examples in Java API itself. Println itself is an overloaded method. Now hold the control button and click on the println. It will take you to the source code. You can see println with string parameter. Here it is a character array. Here it is a double, float, long, etc. You can see that different definitions for the same method println is available here. Here what we did is a simple simulation of the same. Let's take a look at what are the do's and don'ts of function overloading. While overloading a function, we need to change at least one parameter. This is a valid case because you have an integer here and double here. Now in this case, this is integer and it is integer as well, but there is a change. Here it is double and here it is string. Hence this is acceptable. So you need to ensure that at least you change one parameter. Here this is not acceptable. You cannot overload the function by simply changing the return type. Because you can see 10 is an integer and both functions are capable of accepting this call. Let's take a look at method overloading through a different example. Let's define a class searchUtil. We are going to write a function that searches an integer array for the given element and returns its index if it is found, otherwise returns -1. We will iterate through each element of this array and check if any element matches with ELE. Let's begin. For int I equal to 0, I less than a dot length, I plus plus. Now, if a of I is equal to ELE, then we found the element, hence return the index, that is I. In this loop, if any element matches, then control returns with its index. Once control comes outside the loop, it implies no element matched, hence return -1, because we didn't find the element. So, this is our first definition of the search method. Now let's support one more that performs search from the given position. Here, we need to search from the given position. For this method, the entire logic remains the same, hence copy the code and paste it here. And instead of starting from 0, we will start from the given position. Both the logics are same, and the only difference is this begins with 0 and this begins with the given position. If you see, we have two variations of search method, one that searches from 0, other that searches from the given position. These are two different methods. Because functionality is same, we have retained the same name, that is search. Now let's see the usage. Let's create an integer array and initialize with some sample data. Our search element is 30. Create an object for class searchUtil. Now let's say x equal to obj.search arr, ele. Here we are selecting the first one. Expected result is 2. Let's say y equal to obj.search arr, ele, 3. That is, start searching from 3. Expected result is, when we start searching from 3, that is 0, 1, 2 and 3, now we can find the same element at 4. Let's print the values. And run the program. You can see the first value is 2 and second value is 4. In the first case, we call the search method that accepts integer array and element. In the second case, we selected the second method, that is, start searching from the given position. If you don't specify any position, it will search from 0. So the user has two options now. One, search without specifying the position, and the other, search with position. Users can choose either one of these two. Hence, if you can observe, overloading is handy in scenarios where users of the class can choose different argument combinations for the same functionality. One important thing, you should notice that we have repeated the logic twice. Here we have written the logic and here we have written almost the same logic. Both are almost same. To avoid redundancy, we can change it to a call to the other search method with position as 0 and return whatever it returns. As a matter of caution, don't write redundant code. Let's take a look at one more interesting aspect, that is variable arguments. It is supported from Java 5. Let's create a class sample. Add a method sum with integer parameter a. In this case, sum accepts only one argument. When we add one more parameter, it accepts two arguments. That is, it can now find the sum of two integers. Then how can we calculate the sum of n integers? We can put three dots between data type and identifier, and this is called ellipsis. It informs compiler that it supports arbitrary number of arguments for this parameter. Please note that it is acceptable only for the last parameter in the parameter list. Now let's calculate the sum. Say result equal to 0. How to access the arguments passed to a? It is simple. We just need to consider that this is an array. So I equal to 0, I less than a dot length, I plus plus. Result plus equal to fi. Return the result. Now we are done. In this example, we can add any number of arguments passed to the function. Let's see its uses. Create an object for sample. And say int x equal to obj.sum of 10, 20, 30, 40. Print the result. Let's run the program. It has calculated the sum of all the arguments passed to the function. And this is the concept behind printf, which is familiar in C language. It is introduced in Java 5 as well. As you can see for printf, first parameter is format string, and second parameter, args, supports arbitrary arguments. Based on the position of the format specifier, it picks the argument. One more important thing to note is that this ellipsis should be given only for the last parameter. Let's say we have some simple test method with int x, double y and string s as parameters. In this case, we cannot put ellipsis for x and y. It is allowed only for s. This is valid, allowed only for the last parameter, not for x and y. Let's look at one more fact. Suppose we have an overloaded version of sum with two parameters a and b. This method supports two parameters, and this method supports n parameters. See what is picked. Let's say int y equal to obj.sum of 10, 20. Now in this case, which function definition is selected? Will it select this one or this one? Both are capable of handling this call. Put a breakpoint here and right click, debug as Java application. We are in the debug perspective. Let's see what it will choose. Will it choose one with variable arguments or two argument one? What is your choice? Yes, let's select step into. It went to two argument one. Why it selected this over variable arguments 1? And this is because variable arguments is introduced in Java 5, and this two argument 1 is considered old definition. Normally, new features introduced in future versions should not affect the existing code. Now for this call, compiler first looks for the exact match, and this is an exact match, and hence it is picked. Variable arguments is picked only if there is no exact match. Members of a class are classified into two types, that is static and non-static. It is absolutely essential to understand the difference between them. Assume the class sample with data members x and y. Here, x is a static member and y is a non-static member. Because x is static, entire class will share a single copy of x, whereas each object for sample will get its own copy of y because it is non-static. Let's see. As you can see here, because x is static, only one copy of x is maintained for the entire class. Here, we created 3 objects. Each object will get a copy of y, but they all will share the same copy of x. Because x is associated with the class, it is referred as class member. As you can see, y belongs to object, and instance is another name for object, hence it is referred as instance member. Similarly, static could be applied to the methods as well. If a method is static, it belongs to the class. If a method is non-static, it belongs to object. Because f of is static, it could be invoked directly using the class name itself. We don't need an object for invoking this. Whereas g of is non-static, it belongs to object, hence we need an object to invoke the method. So, in case of static member, we can refer to it using the class name. In case of non-static member, we need an object. Okay, let's understand this through an example. Let's create a class myMath with 2 operations add and subtract. Let's define add with x and y as parameters and return x plus y. Let's define subtract with x and y as parameters and return x minus y. These two are very simple operations. Add is going to return the added result and subtract is going to return the subtracted result, which should be fine. Now to call them, we need to create an object. Let's create. And then int a equal to obj.add of 10, 20. And say int b equal to obj.subtract of 5, 2. This is fine. Let's print a and b. You did it right. Now let's run the program. You can see the results 30 and 3. This is absolutely fine. But now, what is object doing here? Add method returns the added result. Then what is the role of object here? Normally, we use the object to capture the state between operation calls. For example, shopping cart object for holding product selections. Let's see the role of object with a simple example. We have a class sample with int value as data member and set method that sets the value. And get method that returns the value. If you see this example, we created an object for sample. Yes, it is storing the value that is set and supplying it back when get is invoked. In this case, having object is fine. But in this case, what we are storing? Here no information need to be shared between operation calls. As each interaction is an independent interaction, we have supplied values and it gave the added result. Nothing need to be captured and hence object is unnecessary. We are forced to create the object because these methods are non-static. Let's change them to static. Now they don't need object. We don't need object here. Just change it to class name dot operation. We don't need it here as well. We don't need object. We can remove this. Now as you can see, we don't need object anymore for add and subtract as they are static. Whereas in this case, we are using object to capture the value. You can refer to this kind of scenarios in Java API itself. The class math itself is a best example. Let's go to the source code of this method. You can see these are static methods. Now you should notice that static methods normally serve as utilities, which doesn't need any object. They are associated with the class and work as global functions. Hence identify such scenarios and declare them as static so that you don't force object creation unnecessarily. Let's see how to write utility methods with one more example. Let's create one more class, say main1, and also select the main method. Let's suppose you are writing some utility stuff. Best approach to write an utility method is make it static. Let's define a class, myDateUtil. We are defining a method, getFormatedDate with date as parameter. The goal for this method is to format the given date to the specified pattern and return it. Let's say our target pattern is mm/dd/yyyy. Now we need simple date format for formatting the date. You need to import this class. Let's use the format method to format the date and return that value. Simple date format is date formatter for us. It will read the given date and format the date according to the selected pattern. The format method will format it for us. We need an object for invoking the getFormatedDate. Create the date object. It will create the date as per the current system date and time. If we print the date, it will print according to the system date and time format. Now when we say string formatted date equal to util.getFormatedDate, for now, we'll get the formatted date. Let's print it. You can see the formatted date according to the pattern. Now, why do we need to create an object? We are forced to because it is non-static. Instead of this, we can make it static. We can remove this. We can change it to the class name. Only adjustment is because we made this static, it belongs to the class and not object. Hence, a static member can only refer to other static members of the same class. And because this is non-static, you cannot refer to it directly from within the static member. What we need to do is just change it to static. Now keep in mind that a static member can only refer to the other static members of the same class directly. We need an object for referring to non-static members. So we have eliminated the need for object creation in this case. Use static methods for defining the utility methods so that we can avoid object creation whenever it is not needed. Let's take a look at initializers. As the name indicates, they are meant for performing initialization activities. We have a class sample. When we write static and followed by a block, it is called a static initializer. When we simply start a block, then this is called non-static initializer. In the previous lectures, we learned that static is associated with the class and non-static is associated with object. Hence, non-static initializer is responsible for initializing the object, whereas static initializer is responsible for initializing the class. To demonstrate, let's put some sample output. Let's print, say, static initializer. Let's print non-static initializer. Now let's create 3 objects for this class. Here is the first object. Here is the second object. Third object. In this case, we have created an object. Immediately, non-static initializer is executed for this object. And it happens for each object. Can you guess how many times non-static initializer message is printed? Yes, it will be 3 times. Now what about static initializer? Static initializer will be executed only once for the entire class. That is, when the class is loaded into memory. Here, you need to note that Java performs dynamic class loading. That is, a class is loaded only when it is needed. When class is loaded, immediately static initializer gets executed for that class. It is a one-time activity performed when the class is loaded. Use it to perform any activities that should be done immediately after loading the class, before you can say that the class is available for use. Non-static initializer is executed once per object, used for object level initializations. Let's run the program. You can see static initializer is executed only once, whereas non-static initializer is executed once per object. You can write any number of static and non-static initializers for a class. They are executed in the sequence in which they are defined. Anyway, we don't normally use it. We normally use static initializer for configuration specific activities. Assume we have a class some configuration provider. Assume there are few properties to be loaded. Now we use the static initializer to load the properties, and suppose this should be done only once. And we want to load the properties before you can start fetching the configuration from this class. And also, because it gets executed only when the class is loaded, it gives us the advantage of lazy fetch as well. Let's see what is a constructor. It is a feature that allows you to dictate how the object should be created. Let's see that in action now. Let's begin with a simple example. Say we have a class called sample. Apart from methods, we can write a method like this. It is a constructor. Its name is same as that of class name, but with no return type. This is what we call a constructor. Let's print a simple hello message. Now whenever you create an object for this class, constructor gets invoked automatically. Its primary purpose is to initialize the object. Let's create an object for the above class. We have created an object here, and when you run the program you can see that hello gets printed automatically, and this is because constructor runs immediately after the object creation. Let's change it to a slightly different example. Let's create a class sample again with slightly different structure. Say we have a private field value and a public method print that prints the value. Let's create an object, say sample s equal to new sample, and say s.print. When we run the program, you can see that its value is 0. What we are going to do here is, we are going to add a constructor sample and initialize this with value 10. Now when you create object, first object gets the essential memory block for all its data members, that is value here. Post memory allocation, object must pass through the constructor, which is then responsible for all the initializations. Here it initializes the value with 10. Once construction is done, object is ready for you. Here we call the print method and you must see the value 10 in the output. Like other methods, we can also overload constructors. This argument constructor is a second option to the user. They can supply the value instead of fixed value. Let's initialize the value with the given value. Now users have two options. If they don't want to provide the value, they can choose this constructor. If they want to supply a value, they can choose this one. Let's say sample s1 equal to new sample of 100. Say s1.print. In case of the first object, we have selected the no argument constructor. In case of the second one, we have supplied the value. Hence n is 100. This constructor gets invoked and value will be initialized with 100. When you run the program, you can see that the first one is 10 and the second one is 100. To summarize, constructor is responsible for initializing the object. Its name is same as the class name but with no return type. Like methods, we can also overload constructors. Let's see the role of the constructor. Here s is a reference variable. In RHS, we have created an object. First object will get the memory for its attributes. And its reference won't be assigned to s. First it has to pass through the construction phase before it is ready for use. This new object will be passed through the constructor. Here in this case, we have selected the no argument constructor. Once you pass it through the constructor, you get the fully constructed object which is ready for use. And then its reference is assigned to s. So whenever we create an object, object must pass through the constructor before you can perform operations on it. Let's see constructor overloading through a different example. Let's create a main class. Let's say main1 because main is already there. You can choose whatever the name you want to give. In this example, I am going to create a class for complex number. If you are not sure of what is a complex number, it is of the form a plus bi or ib, where a and b are real numbers. For example, 5 plus 4i. Here 5 is a real part and 4 is imaginary part. Now let's design the class complex. And there are two data members in it, say real and imaginary. It's a good practice to put them under private so that we don't allow direct access to them. Now let's define a simple public method, print. It simply prints the complex number. So when we create an object, by default real and imaginary will be initialized to 0. Through constructors, let's provide users with the options to initialize the object. Let's make it public so that outsiders are given the access. And this is the no argument constructor, and it is selected when they create object without supplying any value. In this case, we are making real and imaginary as 0. We don't need to assign it as they are 0 by default. Let's support one more. If they want to supply only real part, initialize the real part with the given number. And initialize imaginary part to 0. Let's define one more. Let's give them the option to supply both the values, real and imaginary. So we have defined 3 constructors here. One is no argument constructor, one is argument constructor, and 2 argument constructor. Now we have given 3 options to the user. So while creating object, they can choose any one of it as per their need. Let's create 3 complex numbers. Say C1, C2, C3. These 3 are 3 reference variables. Now let's say C1 equal to new complex. Here we selected no argument constructor. Say C2 equal to new complex of 10. Here we selected one argument constructor. Say C3 equal to new complex of 50, 4. Here we selected 2 argument constructor. Let's say C1.print, C2.print, and C3.print. In case of C1, we selected no argument constructor. That is this one. So the object created will be initialized using no argument constructor. That is, the real and imaginary parts become 0. In case of C2, we selected argument constructor. That is this one. The given value is assigned to real part and imaginary part becomes 0. In case of C3, we selected 2 argument constructor. R is taken as real part and I is taken as imaginary part. Let's run the program and check the output. You can see the results now. Now let's see the variations. What happens if we don't write no argument constructor? When we remove no argument constructor, you cannot choose it anymore. So we don't have this option. Now we need to choose either one argument or 2 argument constructor as per this class. Also, we can hide a constructor. We can make it private, which makes it internal to the class and not meant for the outsiders. Now you can see that you can't choose one argument as well. Let's bring that back. Now if we say this is public, let's say this is private and this is public. Now user has only 2 options. They can select this one or this one. They don't have this option. You can see that they can't select one argument constructor because it is private. Where these scenarios are used, normally we will not define no argument constructor if we cannot proceed with object creation without certain values. Let's see that with an example. We have already seen a class called scanner. Let's go to the source code of it. Now you can see 4 constructors here. Let's see that. This is 2-argument constructor. This is an argument constructor with readable source. This is an argument constructor with input stream as source. And this is a 2-argument constructor. We don't have no argument constructor anywhere here. And this is because creating scanner object doesn't make any sense unless you associate that with some source. Now you must understand that constructor is used to mandate how object should be constructed, alongside providing options to initialize the object. Suppose that we don't have any constructor at all. We don't have these 2 options now. You are selecting no argument constructor. Is there any no argument constructor in this class? No, we don't have. Then how can you select it? Where is this no argument constructor coming from? Actually, if you didn't define any constructor, compiler will generate one for you. You can see that through the generated class. Let's open the navigator view. Under the project, bin directory, you can see the generated class file. Open the complex.class. You can see that there is one constructor defined here. It got generated for the class complex. This is what we call default constructor. And here you are selecting this constructor. You need to note that compiler generates default constructor for a class only if there is no constructor defined for that class. If it finds one, then it will not generate. And also, its modifier is same as that of class. That is, if a class is public, then the generated constructor will also be public. Let's see what is this keyword. It is an important one, as it is the only way to access the current object from within the non-static member function. Suppose we have a class sample with a field int value and a public method set to set the value. And if you can observe, there is an instance variable named value and also a local variable named value. And this is what we call shadowing. In this case, local identifier value shadows the instance variable value. Now when we say value assigned to value, both occurrences are referring to the same identifier, that is the local one. Now how to access the instance variable? We can use this to resolve it. Here this means current object. You should also note that value is a non-static variable and hence associated with object. Each object will get its own copy of value. In this case, this dot value is nothing but current object dot value. This is one of the usages of this. Let's write one more method. Say print. Just print the value. Here also you can access the value through this. Though not required here, still we can use it. Let's create 2 objects for sample. We created the first object. Now we created the second object. Say s1.set 10. Say s2.set 20. Let's print those values as well. Now in this call, s1.set, when we get into the set method, this will refer to s1. That is, when we say this dot value, it is nothing but s1 dot value. When we say s2.set, this within the set method now points to s2. Now in this case, it is nothing but s2 dot value. So you can use this to resolve the naming conflicts between the local variable and an instance variable. There is one more feature to consider. Suppose we have 2 different constructors. Assume there is no argument constructor with logic that should be executed with defaults. And an argument constructor with logic that should be executed with given values. Assume that this logic is slightly complicated logic Instead of repeating this logic twice in both the constructors, we can make a call to the other constructor using this, say 10. Here we are calling the other constructor with the value 10. Once it is done, control comes back just like any other method and proceeds with the rest of the statements if any. Remember that it should be the first statement within the constructor. Let's see how we can achieve code reuse using inheritance. Suppose that we have a class called basic calc with add and subtract methods. Say return a plus b, and one more method, say int subtract with parameters a and b, return a minus b. Now this is a simple class with two methods, add and subtract. Now let's create object for basic calc. Say bcalc1. Now we can call add and subtract methods through bcalc1. Say bcalc1.add of 10, 20. And also one more, bcalc1.subtract of say 10, 20. Now this is fine. We call the add and subtract methods here. If you see the output, you get 30 and minus 10. This is fine. Suppose you are designing a class called scientific calc. Here, you can see that we need the functionality of basic calc with some extensions. Instead of redesigning the entire functionality, we can make use of existing functionality. How can we do that? We can say extends basic calc. With this, scientific calc has inherited the functionality of basic calc. Even if we don't add anything to scientific calc, we still get the basic calc functionality. Let's see that. Let's create an object for scientific calc. Now you can see that we can call the add and subtract methods through scientific calc object. Now the question is, did you define add and subtract in scientific calc? No. Then how can you call these methods? This is because scientific calc extends basic calc and hence it inherited the properties of basic calc. What we can do is, we can also add more methods to this class. Let's say double sign with degree as parameter. Now let's convert that to radians, that is degrees into pi by 180. Now we got the radians. Now what we can do is, we can call math.sign and pass the radians to get the sign value and return it. Now scientific calc has three methods now, add, subtract and sign. Now we can call sign method through scientific calc object. Now when we create object for scientific calc, we can call basic calc methods as well as scientific calc methods. But through basic calc object, we can only call add and subtract. Let's put a break line just to separate the outputs. Now let's run the program and check the outputs. Let's see what we have done. We have add and subtract functionality as part of basic calc. In case of scientific calc, because it extends basic calc, it inherited the functionality of basic calc and added sign method. This is what we call inheritance, and it forms an easier relationship between the classes. That is, scientific calc is a basic calc. What is the advantage you get from it? Let's see that. Basic calc bcalc2 equal to new scientific calc. Can we do this? Yes. This is because bcalc2 is a reference variable. It can point to any object of type basic calc. What is expected is a basic calc object. What is given is a scientific calc object. Because scientific calc is a basic calc, this assignment is valid. The reverse is not true. If we say scientific calc scalc2 equal to new basic calc, in this case, the assignment is not valid. This is because the given object cannot handle all the calls from scalc2. For example, if we call sign, then the basic calc object cannot answer it. And in short, when basic calc object is expected, we can also supply the derived class object, that is scientific calc object, because it forms an easy relation. And also, derived class object can handle all the calls made through base class reference variable. Now the other point is, we cannot call the sign method from bcalc2. Let's try that. Let's see bcalc2.sign 90. You may feel that this is valid as it is a scientific calc object. bcalc2 is of type basic calc. It can only refer to the members of basic calc because compiler only knows the type information and not the object. Hence, members referenced through bcalc2 should be a member of basic calc. Now, if you know that the object is of type scientific calc, then you can safely typecast it to scientific calc and then call the sign method. Problem rises if the actual object is not of type scientific calc. You will know about instance of operator in future lectures, which help you identify the object before you can cast it. Let's see what is overriding with an example. Suppose that we have a class called base with two methods, f of let's say print f of in base and g of, say g of in base. Now we have two methods, f and g. Now let's create an object. Say base b1 equal to new base b1 dot f of and b1 dot g of. We have a class with two methods and we created an object and we invoked f and g. When you look at the output, you can see that f of in base and g of in base. Now let's add one more class, derived, extends base. This is what we call inheritance. In this case, derived has acquired all the properties from base. When you create an object for derived, you can see that we can call both f and g. Now let's add one more method to derived. Say void h of. Let's print h of in derived. In case of derived object, we can also make a call to h of. In case of base, we have only f and g. In case of derived, we have f, g and also h. When you see the output, you can see that f and g in base in the first two calls. In case of derived object, we have f and g are from base and h from derived. This is fine. Now what happens if we write g of? You can see g is already available from base, but here we have replaced the inherited definition. This is what we call overriding. This is done in order to modify the functionality obtained from base. Now in this case, what will be the output? Let's check that. If you see the first object, it is of type base, and hence f and g are taken from base. In case of second object, f will be from base, whereas g and h will be from derived because it is derived object. Now just add one more. This is critical to understand. Let's suppose you have base b2 equal to new derived, b2 dot f of and b2 dot g of. Can we say b2 dot h of? No, because b2 is of type base, hence it can only refer to the members of base. Now for f and g, guess what is the output? Let's run the program and see. You can see f of is from base, but g is from derived, because whether we can call a member or not is determined by type, but which method is invoked is determined by object. For method call f, first go to the object specific class, that is derived. Do you have any definition here? No. Then go to its base class. This definition is selected. Again for g, because it is a derived object, first go to the derived class. Is there any matching definition available? Yes. Then this is selected. To summarize, this is in base. Here it is base, because it is base object. This is base. In derived, because it is derived object, and in derived. In this case, b2 is of type base, but the actual object is derived object. F of in base, because f of is not overridden. G of in derived, because it is derived object. Replacing an existing method from the base class is called overriding. This is done in order to modify the functionality obtained from the base class. We'll take a look at what is a super keyword. Suppose we have a class called base with a method print. Let's print hello here. Let's create an object for base and call print method. It should print hello. That's fine. Now suppose we have a class derived that extends base. And then let's override print method. Now let's print world here. For base object, the print method is this one. For derived object, the print method is this one. It's always a good practice to add override annotation here. It ensures that we override properly. If we try to do any mistake here, compiler can immediately show error, and it helps us to check if we are overriding the right method or not. Let's create object for derived, say d1. Say d1.print. We are actually printing world here. Let's run the program. This is because we don't have println here. But anyway, to make it clear, let's put a break line between both the print method calls. Because it is base object, this print method is this one. Now in this case, it is derived object. Hence the print method call is this one. Let's run and see the output. Now the first one is the result of print in base. The second one is the result of print in derived. Now suppose in derived we want to print hello first and then continue with printing the world. Then how should we do that? If we call print, then it makes it a recursive call. That is the same method call here. And it will lead to Stack Overflow error. How to solve it? We want to call the print method of the base class. Now we should use super keyword. If we use super.print, we are calling the print method of the class base. Once it comes back from that method, we can continue with further logic. Let's run the program. You can see first hello got printed and then the world. Now super is also useful during base class constructor selection. Let's see that with an example. Let's create a new class, say main1, because main is already there, and also select the main method. We will see constructor selection during inheritance now. Let's take a class point2d. Say we have two fields x and y. Suppose we want to support two constructors here. That is no argument constructor. We don't need to initialize x and y because they are 0 by default. Another constructor, point2d of int x comma int y, a two argument constructor. You can see that the local variable x shadows the instance variable x. To solve it, we should say this dot x equal to x and this dot y equal to y. Let's add one more method called print. Let's simply print the point. Instead of println, let's use printf. And we can use %d for placing the value and %n for new line. You can also use /n. Now we have a point2d class with fields x and y and with two constructors. If we don't supply any value, they will be 0 by default. If we supply the value, then they will be initialized with the given values. And we do have a print method that prints the point. Now let's create the first point. Point2d p1 equal to new point2d. We created an object here. Next, p1.print. It should print 0, 0. Let's create one more. Point 2D, p2 equal to new point 2D of 10, 20. p2 dot print. It prints the second point. Let's see. Run as Java application. You can see that the first point is 0, 0 and the second point is 10 and 20. Let's create one more class, point 3D, that extends point 2D. This class extends point 2D with the z attribute. Now let's add a new argument constructor. We don't need to set 0 anyway. One more constructor, point 3D of int z. Initialize attribute with the given value. And then print. Let's take the same point and print the third point z. First thing, x and y are not visible. Why? Because although point 3D extends point 2D, it won't inherit the private members of the base class. Now these two are private members and they are visible only for the members of the same class, but not for derived class or any others outside the class. Now if you want to allow access to x and y, there are two approaches. Either you do this way, like adding a getter method for x and returning x, and then here in the subclass, instead of referring to x directly, change it to the getter method to get the value of x. This is one approach. Suppose we don't want to do it this way. The other approach is you can make them visible to the subclass by changing the modifier to protected. Protected members are visible to the members of the same class and also for subclasses. If x and y are protected, we can access this here and also here. Now you can see the errors were cleared. This is because x and y are visible now. Let's create objects for point 3D. Point 3D p3 equal to new point 3D. And then p3 dot print. It should print 0, 0, 0. What happens when we say point 3D p4 equal to new point 3D of 10, 20, 30? Say p4 dot print. Can we do this? First of all, we don't have a 3-argument constructor in the class point 3D. We have only 1-argument constructor here. 3-argument constructor is not there. It is not acceptable. We can give only one value. Now if you see point 3D, internally it does have a point 2D object. Then how is point 2D initialized? It is initialized using no argument constructor of point 2D. Let's see the output. Oh, okay. Run it again. You can see that for first object it is 0, 0, 0. For second object it is 0, 0 and 30. This is because point 2D portion of the object is initialized with no argument constructor. Now how to fix this? Say we want to accept values for x, y and z. We need to pass on these two values to this constructor. How can we do it? This could be done through super of x, y. This should be the first statement within the constructor. And now this initializes the point 2D with the 2-argument constructor. And once it is done, it comes back and proceeds with the rest of the constructor block. Now you can see that we have only two constructors, no argument constructor and 3 argument constructor, and we don't have 1 argument constructor. You can see the error here. Let's change it to 3 argument constructor selection. Now in this case we are passing 3 values. They are obtained here, and now there is a call to the base class constructor. It goes there and initializes x and y with the passed values, and comes back and initializes g with the given value. Let's run this program. You can see the values of x and y and z. This is good. What if we remove no argument constructor in point2d? To make it more visible, I'll keep it side by side. Assume we don't have no argument constructor. You can see here, there is no constructor call. Compiler adds a superof by default. Because there is no argument constructor in point2d, this constructor call is invalid because it is selecting no argument constructor which is not there. You only have an argument constructor. Second one is not a problem because we are making a call to argument constructor. Here, because we haven't selected any constructor, it is selecting no argument constructor of point2d. To solve this, we need to select argument constructor, and we have solved this problem. If we have no argument constructor, we can ignore the selection from our side because it is the one which is selected by default. Now you can see there is no error here. Let's see a few more topics related to inheritance and overriding. Java doesn't support multiple inheritance directly. That is, you cannot extend more than one class. Suppose you have a class A and then class B. What you cannot do is, you cannot extend more than one class. That is, say class C extends A, B. This is because Java doesn't support extending more than one class. You should extend either A or B, but you cannot extend both. So this is the first point. And also, suppose you have written a class called sample and you didn't write any methods inside it. When we say sample s equal to new sample, we created an object. When we say s dot, you can see few methods coming up here. You can see these methods are not there in the class sample, but they are available from the class object. Object is the base class for all Java classes. Even if you don't select any base class, by default it is object. Println s. When we say s, it is also equivalent to s dot toString. What is the output of toString method? Let's see that. You can see it is class name followed by hexadecimal form of the hash code. Is toString method available in this class? No. It is coming from the class called object. Let's see that. Hold the control button and click on this method. You can see it is coming from the class object. Now in case of toString, you can see it is the class name followed by hashcode method. Even if you don't call toString, you can see by default it selects the toString output for printing. Object is a very important class in Java. There are few other methods in it which are absolutely essential. You will see them in the future lectures. If you want to print your own output, then what we can do is, we can override the toString method. Say return hello. You can see override annotation is not producing any error, and this is because object is the base class for sample. Because we are trying to print the object directly, by default toString method is invoked, and we have overridden that method to produce our customized output. No matter even if you simply say yes or s.toString, both are same. Now let's see how to write generalized code using inheritance. Suppose you have a class called vehicle. And have a subclass called two-wheeler that extends vehicle. And you have a class called four-wheeler extends vehicle. And you have a class called bike extends two-wheeler. Let's put them in single line. And a class called car extends four-wheeler. Now you have this inheritance hierarchy. Just guess what happens here. Test vehicle. Now, which objects could be passed to the test method? We can pass new vehicle. We can pass new two-wheeler. We can pass all these objects. Now, if we say argument type is car, you can see it is applicable only for car. When we say bike, this code is applicable only for bike, not for other classes. When we say two-wheeler, now this code is applicable for two-wheeler and also bike. When we say vehicle, it is applicable for all vehicles. Suppose that we have a class called human. Can we pass human object to the test method? No, because human is not of type vehicle. If we say object, then you can see this code is applicable for all objects because object is the base class for all Java classes. Okay, let's keep vehicle here. Now you can see this code is applicable for all vehicles. Writing the code for the base class generalizes the code, makes it applicable for all its subclasses. One more important thing to note is, suppose you have a class called base with a public vehicle getVehicle method. Return null for now. Now in the derived class that extends base, when we are overriding the method, we cannot reduce the visibility of that method from the base class. Here the method is public and here you reduced it to protected, which is not acceptable. The opposite you can do. Suppose it is protected here, you can make it public. And one more thing, in the base class you are returning vehicle. Now in the subclass, you have to retain the same return type, or you can change it to any of its covariant, that is a subclass. Example, we can say bike here, but we cannot say human. So it should be a covariant. You can change it to any of its subtypes, say bike, even it works. Now when we add an argument, it is not overriding anymore. Actually we are overloading here. If we remove overriding annotation, this is valid. So as far as base is concerned, this is the getVehicle method. Now as far as derived is concerned, we have two options. We have getVehicle with no argument and getVehicle with integer argument. Let's see what are abstract classes. Suppose we have a class called graphic with 2 points x1, y1 and x2, y2. Let's add a method, say set start with x and y parameters. And this will set the first point x1 and y1. And one more method, say set end with x and y as parameters. This will set the second point x2, y2. And one more method, draw, to draw the graphic. At this point, we are not sure what to draw, and hence let's put no clue. Let's say we have a subclass for graphic. Line extends graphic. Now you know what to draw. Hence, let's override the draw method. We are not drawing anything at the moment. Let's just print draw line from x1, y1 to x2, y2. That's it. You can see here, x1, y1 and x2, y2 are private fields in the class graphic. They are not visible to the subclasses. To allow subclasses to access them, let's make them protected. Now line knows what to draw, and hence it has overridden the draw method obtained from the base class graphic. Similarly, say we have one more class called rectangle that extends graphic. Let's override the draw method and change the text to draw rectangle. Now this is fine. Let's create a graphic object, say new graphic, say g.start, say g.end, and g.draw. Similarly, let's create a line object, say L equal to new line. Now let's say L.setStart. Now let's run the program. In case of the first one, the draw definition is from graphic. Whereas, in case of the line and rectangle, they have overridden the draw method. Why did they override? This is because the existing logic obtained from graphic is not sufficient. Hence, they have replaced the logic according to their need. And this is the primary goal for overriding. Let's change this to graphic G2. Also change the dependencies. Let's change this to graphic G3 and dependencies as well. Even this is valid because what is expected is a graphic and what is given is also a graphic. This assignment is valid only because of extends relation. Suppose if it is not there, then it is not valid. Let's write a simple util method. Say drawUtil with parameters x1, y1, x2, y2 and graphic. Say g.setStart. g.setEnd and g.draw. Let's make it static because main is a static method and hence it can only call static methods directly. Let's use that method. drawUtil. Here we are passing the graphic object. Now drawUtil, and here we are passing the line object. Now drawUtil. Here we are passing the rectangle object. If you look at this method, this is applicable for all graphics. Here it is expecting graphic and we have given the graphic object. Here for graphic we have given the line object. Here we have given the rectangle object. We can call setStart, setEnd and draw because they are members of the graphic. This draw method is dependent on object. If graphic object is supplied, then it will be draw in graphic. If it is a line object, then it is draw in line. If it is a rectangle object, then it is draw method in rectangle. Let's see the output. You can see that it is same. When you refer to a method through Z, because Z is of type graphic, it should be a member of graphic. What if draw is not a member of graphic? Then you cannot make a call through G. Unless it is a member, we can't call it. For that reason, you need to keep it. What is the advantage? If we say line G, then you can see it is applicable only for line. If it is written for rectangle, then it is applicable only for rectangle. If you write code for graphic, then it is applicable for all graphics. If you see this code, it is applicable for all graphics and hence it is generalized code. If we look at it, creating graphic object doesn't make any sense because it is still incomplete and because we are not sure what to draw. There are two ways of handling this. If you are not sure, we can simply leave the definition empty, but still need to have this because it allows us to make a call to the draw method through graphic reference variable. And the other approach is we can make this method as abstract. We are not supposed to define the method. Abstract methods just act as declarations. They will not have method block. If you have an abstract method, then the class should be abstract as well. Now this class is an incomplete class with abstract methods. It can just act as a base class for the other classes. You cannot create objects for this class directly. If you see, this is not valid anymore. You cannot instantiate graphic. If you see, this class is providing the common functionality and deferred certain method definitions for subclasses. And the rule is the subclass must implement the draw method. If they didn't, then they too become abstract. Most importantly, if you write code for base class, then it is applicable for all its subclasses. This way we can generalize the code, and making a class as abstract allows us to restrict object creation for that class directly. Let's take a look at what is final. Final modifier has multiple uses. Now let's see them in action. Here we have declared a variable, which means it could be modified. If we say pi++, it is valid. And this is not what we want. We want this pi to be constant. In that case, we need to declare it as final. Once we declare it as final, it cannot be modified anymore after initialization. Particularly for local identifier, we can do initialization after declaration, such as this one. Because it is final, once initialized, it cannot be modified anymore. Ideally, constants are declared at the class level. That is public, static, final, double pi equal to 3.14159. When declared at the class level, final identifier should be initialized immediately. Normally, you'll see declarations like this. They are meant for public, and static means entire class will get only a single copy. And then final means it cannot be modified anymore. And for constants, we normally use identifier names in all caps. And because it is static, we can directly refer to pi using the class name itself. Say double x equal to main.py. This is one of the usages of final, that is to declare constants. And another case, if you can see, suppose there is a class called base with method void f(of), and there is a class called derived that extends base and overrides f(of). Now when we declare this method as final, we cannot override it anymore, and this is done in order to stop overriding. This means that the definition provided for the method f(of) is final, and it cannot be modified anymore. One more usage is, if a class is declared as final, it cannot be extended anymore. And hence, final classes cannot be extended, final methods can't be overridden, and final identifiers can't be modified. Now let's take a look at what is the difference between abstract class and concrete class. We have already seen about abstract classes in our previous lectures. Now we will see a few other technical things related to the abstract classes. Now let's suppose there is a class called base. Now there are two steps involved during object creation. And the first step is creating a reference variable. Now here b is a reference variable. Now when we say b equal to new base, now in RHS we are creating an object and we are assigning its reference to b. And this is what we call a concrete class. When we say a class as a concrete class, now we can create objects for that class. Now when we declare the class as abstract, now we can create a reference variable, but what we cannot do is, we cannot create an object for that class. You may question that there are no abstract methods in this class, but still why we are making it abstract? Yes, we may do this in order to restrict object creation for that class. For now, let's remove abstract. Now suppose let's write a method f of. Now when we put a block like this, we have already defined the method. Now when we don't want to define the method f of, if we remove this block, then this should be an abstract method. This means that this method is only declared but not defined. Because this method is abstract, now we need to declare the class as abstract as well. Because this class has an incomplete method and we cannot instantiate this class because it is not complete. Now let's add one more abstract method to this class. Say void g of, and add one more method h of, and let's define this method. Say h of in base. Now you can see that an abstract class could have partial implementations and partial leftovers. Now this class is meant to be a base class and you cannot directly create an object for this class. Suppose there is a class called derived, extends base. Now derived is supposed to implement both the abstract methods obtained from the class base. Assume that we are overriding the method f of. Say f of in derived. Now what about g of? Now we need to override g of as well, but there are two ways. Let's suppose that we have defined g of. Now when we override g of, we are making this class concrete. That is, we can create objects for this class. If you override all the abstract methods obtained from the class base, then this class becomes concrete. Otherwise, even this class should be abstract. Assume that g of is not overridden. Then this class should be abstract. Now even for derived, we cannot create object. Now suppose there is a class derived 1 extends derived. Now it is sufficient for derived 1 to implement only g of, because f of is already defined in derived. Now what are allowed are, we can create a reference variable for base, we can create a reference variable for derived, and we can create a reference variable for derived 1 as well, but we cannot create object for base, and also we cannot create object for derived. We can only create objects for derived 1 because it is a concrete class. Now you can see that the actual object which is serving the method calls is derived 1, but LHS is a reference variable. We can call these three methods FGH through base because they are the members of base. Template method pattern is one of the best examples for abstract classes. Let's see that in action. Suppose we have a class called setChalgo. Now let's write a simple search method that searches the given array for the given element. Now let's traverse through the array and check if any element matches. If yes, let's return that index. If control comes out of the loop, that means no element matched, hence return -1. As you can see here, we have written a simple search method that looks up an array for the given element. If found, it returns that index, otherwise it returns -1. Now let's take a simple array. Say our search element is 20. In order to call the search method, we first need to create object for this class. Say algo equal to new search algo. Now that we have object, we can call the search method. Let's say int index equal to algo.search a comma element. Now if index is equal to -1, then we can say that the element is not found. Else element is found. Let's print that index. Say found at and followed by index. Now let's run the program. You can see it returned where the element is. Now we have written the program just for equality search. Then what if user needs a different type of search, say they are looking for inequality, etc. So as the first step, let's convert this equality check to a function call. Say we have a method called match with two parameters value 1 and value 2. Now inside the method, let's compare value 1 is equal to value 2 and return that result. Now let's change this to a function call. Say match of a of I comma ELE. Now what did we achieve with this? Yes. Now when someone is looking for inequality search, they can extend this class and override the match method. They can use the same search method. Say we have a class called inequality search algo, which extends search algo. Now it will be sufficient to override match method and customize the comparison. For this class, say return value 1 not equal to value 2. Now if someone uses inequality search algo, then it will look for unequal elements. Let's change this to inequality search algo. Now let's run the program. You can see it returned the first index position where the element is not equal. Now what if we want to define only the search algorithm and leave the match logic to the subclasses? If we remove the match method, you can see this code won't compile. So we need to keep it. But still, if we want to leave it to the subclasses to decide, we can make this method as an abstract one. Abstract method declaration here will help us refer to that method. Also, it makes this class as abstract. So we cannot create object for this class directly. You can see if we try to instantiate search_algo, we are not allowed. And subclasses will remain as abstract till the match method is defined. This way we are forcing the subclasses to define the method. Now this class is abstract because we have an abstract method match here. Now let's define a subclass equality search_algo that extends search_algo. As you can see, it is mandatory for equality search_algo to define the match method. Otherwise, it too remains abstract. This way we are forcing the subclasses to define the method. Now let's define. Let's say return value 1 is equal to value 2. If you see, if someone takes equality search_algo, then this is the match method used. If they take inequality search_algo, then this is the method used. If you look at the search method, it acts as a template method with algorithm steps, and few steps are left undefined, which should be filled by the subclasses as per their need. Because search_algo is abstract, we cannot create object for this class. We should pick either equality search_algo or inequality search_algo. Let's say equality search_algo. And also, if you make this search method final, then subclasses cannot override this method. This way, we can stop modifications to that method. You can see a template method normally defines the algorithm steps, and it is then left to the subclasses to complete the ones which are left out. Here you can see it is just a reference variable, and the object which is serving the call is equality search_algo. Now, within the search method, the match method from equality search class is used. Apart from this, just like normal classes, abstract classes can have initializers, constructors, instance members and class members, etc. Only difference is they cannot be instantiated directly. Let's see what is an interface. It is the most important concept in programming. Let's understand it with a simple example. Suppose we have an interface calc with methods like add and subtract. Say add of AA, BB and subtract of AA, BB. And now you can see that we are not providing definitions to the methods of an interface because interfaces are not supposed to have implementations. Hence, these methods are public and abstract by default. In real world, we can relate this interface to a menu in a restaurant, which just lists what is available and provides no information about how it is implemented. Now, a class will implement an interface. That is, it provides definitions to the methods of an interface. Say we have a class called myCalc that implements calc. Hence, you need to note that myCalc is not extending calc, it is implementing it. What if myCalc doesn't implement all the methods of an interface? Just guess. Yes, myCalc will become abstract because it is abstract method here and myCalc should define it to become concrete. Now let's define them. Let's say return a plus b here. Let's say return a minus b here.
You can see that interface is just listing the methods, whereas implementation class is providing the definitions. Let's add one more method to myCalc, say double sine of double degrees. First, let's convert this to radians, that is double radians equal to degrees multiplied by pi by 180. And now let's use math.sine to calculate the sine value and return it. As you can see, myCalc can have many other methods which are not there in the interface. And these methods are not static. Hence, they should be invoked through object. Hence, let's create object for myCalc. Now that we created object, we can now call add, subtract and sine. This is fine. Like abstract class, we can create reference variable for calc, but we cannot create object for it. Now what should be done? We can provide any instance of a class that implements calc interface. Let's say myCalc. Here C is a reference variable, and in RHS we have given an object which will answer to the calls made through C. Now let's call the methods through C. The object which is answering these calls is myCalc object. Because C is of type calc, we can only refer to the members of calc. We cannot call the sine method because sine is not a member of it. One more important point is we can add any data members to an interface, something like double pi equal to 3.14159. Now it is public static final by default, and because it is static, we can refer to it directly using the interface name, that is calc.py. And this option enables developers to use interfaces just for holding constants referred across the project. Why are interfaces important? You will see that in the coming lectures. Let's see few other technical things related to interfaces. Suppose we have an interface called audio player with play method. Now let's create one more interface audio recorder with record method. An interface can extend multiple interfaces. Say we have an interface called audio system that extends audio player and audio recorder. Here you need to note that interface will extend other interfaces. It won't implement. Say we have one more interface called FM player with method playFM. Important thing to note is a class cannot extend more than one class, but it can implement multiple interfaces. Say we have a class called bass music system that implements audio system and FM player. Here you need to note that a class can implement multiple interfaces and it is supposed to implement all the methods of those interfaces. Let's say we have implemented play method. And also record method. Now what about play FM method? Because we are implementing FM player here, we need to implement it as well. Suppose if it is not implemented, then this class becomes abstract. This class is abstract because it didn't implement play FM method. Now let's create a subclass called myMusicSystem that extends base music system. For this class to become concrete, we need to define playFM method, otherwise it too remains abstract. Also, let's suppose we have added a new method switch off to this class. Now this class is concrete. We can create objects for this class. So let's create object. Now with mSystem, we can call all the methods available through that class, such as play, record, playFM, and switch off. If we assigned mSystem to audio player reference variable, we can only call the play method because it is the only method in the interface audio player. If you see, we can't call record method because it's not a member of audio player interface. If assigned to audio recorder, we can only call record method. If assigned to FM player, we can call play FM. If we assign it to audio system, now we can call play method and record method. If you see in all these calls, the actual object is myMusicSystem object. Assigning the object to an interface reference variable will restrict us to call only the methods of that interface. It's like looking at the nature through camera, which restricts the viewport. One more point is, a class can extend only one class, but it can implement any number of interfaces. Say we have an interface called A and an interface called B. Now this class can also implement A and B. Class followed by class name, extends followed by base class, and implements followed by interface names. To summarize, an interface is a set of abstract method declarations. An interface can extend multiple interfaces. A class can implement multiple interfaces. A class becomes concrete only when all the methods of the interface are implemented. Objects could be accessed through interface, but can only refer to the members of it. Let's see how we can build loosely coupled code through interfaces. First of all, what is a tightly coupled code? Components are said to be tightly coupled if they are highly dependent. In OOPS programming, when client code is directly coupled with implementation, then we can say that it is tightly coupled because it makes it hard to change. Instead of that, if the client code is not directly coupled with implementation, say it is coupled only with interface, then we can easily switch between implementations without affecting the client. Such code is flexible for changes. Now let's see how to build such code. Let's keep it very simple. Let's define an interface video player with only one method, say play. Let's say we have a class called MP4 player that implements video player. Let's define the play method. Let's say play MP4 followed by file name. Suppose we have another player called AVI player, implements video player. Let's define the play method. Say play AVI file followed by file name. Now we have two video player implementations here. Let's say the file name is sample.mp4. For this, which player we should pick? Yes, we will pick MP4 player. Okay, let's create object and call the play method. That's good. Now let's run the program and check the output. Yes, MP4 player picked it. Now if I change the file extension to AVI, you need to change the following lines of code, isn't it? Now we need to pick AVI player. Now again if I want to play sample.mp4, then? So this code is not flexible enough for change. Now let's introduce a simple player factory and say it has a method called getVideoPlayer with file name as parameter. Now let's make the decision here. If it is MP4 file, then return MP4 player instance. If it is AVI file, then return AVI player instance. If not both, then return null. We didn't find a player for the file. Now let's create factory object here. Say factory equal to new player factory. Now let's pass on the file name to factory and obtain the player. Say video player, player equal to factory.getVideoPlayer of file name. Now before calling the method, we need to check if we obtained the player or not. Now call the play method only when player is not null. Otherwise it leads to null pointer exception. Now is this code flexible? Let's check. Run the program. You can see MP4 player output. Now let's change the file extension to AVI. Now you don't need to change anything here, just run it. Now you can see AVI player output. Is this code flexible now? Yes. If you see this part of the code is called the client code, and you will see this spread across the project several times. If you write the code like this, then the change could be introduced at one point. Otherwise, we need to go to each place where it is referred and change it, and it will be painful. Here the code is now dependent on interface and not tightly coupled with implementation. As you can see, we didn't choose any implementation here. We left it to the factory to select it. Hence, such code is called loosely coupled code because it is dependent on interface rather than implementation. Hence, implementation could be changed as per the necessity. Let's see how we can use interfaces for writing pluggable code. Earlier, we have written a search algorithm with an abstract method, and we forced the subclasses to extend this class and override the match method. Looks good, but we are forcing the classes to extend search algo, which means they cannot extend any other class because Java doesn't allow extending more than one class. And also through this approach, we are forcing them to inherit the functionality, no matter whether they need it or not. Now, don't you think that search algo involved too much into the implementation? Yes, there is another approach for this. Let's see that. Instead of asking them to inherit, we can prescribe an interface and ask them to implement. And hence we are just asking them to implement an interface and not forcing them to extend, which allows them to extend other class and also implement any other interfaces if they need. Because Java allows us to implement multiple interfaces, but doesn't allow us to extend more than one class. This way, we have also opened a portion of the algorithm for pluggability. We can hook a different implementation and still use the algorithm. So, how much did we involve in the implementation? Almost nothing. We are just ensuring that the match method is available with the implementation so that we can invoke it. And this is much better when compared with inheritance. Let's see that with the code. First, let's bring the search algo code here. Now define the matcher interface first with match method. Now we are good. We don't need to make this abstract class anymore. Now let's add a parameter of type matcher for accepting the external implementation. Now change this direct method call to matcher.match. Now let's remove this abstract method. Now we don't need to extend search algo, we just need to implement matcher. For now, let's say one implementation is enough. Note that we have defined an interface here. In order to use the search method, we asked the user to provide matcher implementation. We have a simple implementation here. Now for calling the search method, we need to supply the matcher instance. Now let's apply equality matcher instance here. And we are done. Let's run. You can see the result. As you can see here, we have prescribed a matcher interface and asked the user of this class to implement in order to use the search method. This way, users of this class can plug their own implementation. It is more flexible for them than asking them to inherit. Now let's see what is polymorphism. Poly means many and morph means changing forms. If an element changes forms, then the behavior is said to be polymorphic. The method print with integer parameter here. Again, print with parameter of type double. Here it is print with string parameter. If you can see, the name is print in all the cases. If you supply integer, then print with int parameter is selected. If you supply double, then this method is selected. If you supply string, then this method is selected. If you look at it, the behavior of print method is said to be polymorphic. Let's see what is static binding and dynamic binding. Binding actually stands for linking the call with the corresponding definition. Suppose you are making a method call, compiler should actually link it to the actual definition. And this is what we call binding. Static binding is also called as compile time binding. In this case, compiler itself determines which method should be invoked. Whereas, in case of dynamic binding, the actual definition could not be determined till runtime, and hence it is also called as runtime binding or runtime polymorphism. Here we need to identify which object is serving the call, and only then we can determine the actual method definition. Let's see what it is. In case of static method call, we can term this as static binding because overriding is not acceptable for static methods, and hence compiler can pick the exact method definition here. Now in case of gof method call, gof is a final method and it can't be overridden. Hence it is also a candidate for static binding. So when someone is calling the method gof from base instance, we are sure that it will be this one. Hence we can say this is static binding. When it comes to hof, it is neither static nor final, and hence the actual definition could not be determined unless we know the object. This is a candidate for dynamic binding. If the object is a base object, then this method call will invoke the definition in base. If the object here is a derived object, just to remind you, a base class reference variable can point to derived object. In that case, this method call will invoke the definition in derived, and this is because it is overridden. Hence, selecting the right definition is now based on object. Unless you determine the object, we cannot select the definition. If it is the base object, then this is the one. If it is a derived object, then this is the one. And object is determined only at runtime. Hence, this binding is called dynamic binding.
Now that you know what are classes and what are objects, let's slightly dig deep into what is a string. In Java, string could be considered as a primitive data type, but it is immutable. What do you mean by immutable? Immutable means once you create an object, you cannot modify that object anymore. Let's see that in action. We have a string object here and we assigned its reference to s. What happens in memory is Java creates an object for holding ABC and this object's reference is placed inside s. This is fine. Now the important point to note is this object cannot be modified. That means you cannot modify the content of this object. Now if we want to remove B, we need to create a different object with removed content and its reference should be assigned to s. Now you may ask a question. You feel like you are modifying s here. Now what actually you are modifying is the reference in s, not the content of s. Here we have an object with value xyz, and when you do the plus operation, it actually concatenates the content of both ABC and xyz and it creates a new object. And now this is the new object with concatenated content and we are modifying the reference of s to the new object. That means the link to this object is now moved to this one. So we cannot modify the content of the object, we can modify the reference. That is fine. Now what are the advantages that you get from this approach? Now because this is immutable, the space allocated for this object will be the one which is used by this object. In normal scenarios, when you are looking to modify the object, you need to allocate an additional space so that you don't need to reallocate the memory when you are extending it. But because the string object is immutable, you don't need to allocate this additional space, which is not required because you cannot modify the content. And another advantage that you get from this approach is you can share the object across multiple references. What Java normally does is, if the literal is same, it is going to create only one single object for that literal and assigns the references to all the required variables. Now that is, S and S1 will share the same memory content. You may ask a question, what happens if S tries to modify this? Because you cannot modify. If I say S equal to some X, now it creates a new object with content X, and yes, the reference inside S is now modified to this one. Now you are not modifying the object, you are actually creating a new object and changing the reference. And because of this reason, you can share the same object across multiple references safely. Let's take a look at some of the important string functions here. We have two strings, one is ABC, small abc, that is lowercase abc, and the other is uppercase abc. Now if you want to compare two strings, we can use equals method. If I say s1 dot equals of s2, s1 equal to s2, otherwise s1 not equal to s2. Now what will be printed? Now because s1 is lowercase abc and s2 is uppercase abc, they both are treated as not equal, and hence you will find this in the result. So you can say s1 not equal to s2. Now if you want to do a non-case sensitive comparison, what we can do is s1 equals ignore case of s2. Now if we say s1 equals ignore case of s2, it's going to do a non-case sensitive comparison. It's going to say that s1 is equal to s2. Yeah. So in the second case, you can see s1 is equal to s2. That's fine. If you are looking to arrange the strings, you need to perform, or you need to understand whether first string is less than the second one or greater than the second one, like that. Now if you want to do that, you need to use the method called compare2. s1 dot compare to s2, if it is greater than 0, the result compare2 is going to return us a positive result if first string is greater than second string. You can say s1 is greater than s2. Now if s1 dot compare to of s2 is less than 0, now you can say s1 is less than s2, or else if that is not greater than or that is not less than, you can say s1 is equal to s2. Now in this case, is s1 greater than s2 or s1 less than s2? It is actually s1 is greater than s2 because the ASCII code of A is 97, whereas the ASCII code of capital A is 65. Now when you run this result, s1 is greater than s2 because small lowercase characters are having higher ASCII codes than uppercase characters. For arranging strings, the handy method is compare2. For performing equality check, you should use equals method. If you want to perform equality check ignoring the case, you should use equals ignore case. What happens when I say if s1 is equal to s2? Now S1 is not equal to S2. This equality operator will compare references and not content. If you are looking to compare the content, you should use equals method. If you are looking to compare the references, that is pointers or addresses, then you can use equal to operator. Now in this case, because both objects are different, and hence you will say, you will get S1 is not equal to S2. Here is a small trick for you. If I say string x equal to some AB, string y equal to say AB, if x equal to y, I can say x equal to y, else I can say x is not equal to y. So tell me what is the result? Is x equal to y? Here x equal to y, because equal to is going to compare the references, and as you already know, because both the string literals are same, the same object reference is assigned to both x and y, and hence you will see x equal to y. Okay, that's fine. Now tell me this. If I say y equal to y plus b, so x equal to ab and y is assigned a, and then later concatenated with b. Now the content of both x and y is same, but their object references are different, because in case of x you have one object containing ab. In case of y, this a is a one single string object, b is another string object, and then when they both are concatenated, it creates a different string object with content ab, and its reference is they held in y. Now in this case you will see x is not equal to y. So you should know that equal to operator is going to perform reference comparison and not content comparison. Now in case of equals, it's going to perform the content comparison. So make sure that you use the right method when you are looking to compare the content. Now let's solve a very simple and interesting problem. Now here we have a main string and we have a search string. We need to search for all the occurrences of this pattern in the main string. And to achieve this, we have a handy function called indexOf. When we say main string dot indexOf search string, it is going to return us the index position, the first index position where this search string is found. Now in this case, let's see what it gives. Now you can see that it's going to give us 2. So that is 0, 1 and 2. So this is the index position where this pattern is found. That's fine. Now you have another variation of indexOf. When we say that I want to search from 5, now what it does is it starts searching from index position 5 and gives us the next occurrence. In this case, it's going to give us 5. So the next index occurrence, now where the search pattern is found, is 5. That's fine. Let's use this function to print all the occurrences of this search string. And to solve this, I would say, so main string dot index of search string is going to return us the first occurrence, and we are looking to repeat this process while the position is not equal to -1. Now indexOf returns -1 when the string is not found anymore. Now let's print the position found at and this position. And the first time it prints the first occurrence of this particular search string, and the second occurrence. How can we find the second occurrence of this search string? What we can do is we can actually say position equal to main string dot index of search string, and we should start searching from where it was found previously, +1. So the next character, if we start searching from +1, so the first time it returns 2, and when we should again start searching for this pattern starting from 3. Now if that returns -1, this loop is going to stop, otherwise again it starts searching from the previous occurrence +1. Now this loop is going to repeat till the search string is not found in the main string. Let's see this. You can see we got found at 2, 5, 79, 20. This looks a very simple problem, but still it has very good use case. This editor itself is an example for that. If I say I'm looking to find main, this is going to give me the first occurrence, and again if I find, it's going to give me the second occurrence. That itself is a very good use case for this search operation. Strings are ideal for scenarios where the content of the object is not modified. That's fine. Now what about the scenarios where the content could be modified? Take for example, when you are building a text editor, user can continuously type the text which modifies the content. For such scenarios, you need to use either string builder or string buffer. String buffer is slightly thread safe option. Now the better option for this scenario, when you are developing an application which is single threaded, string builder is the better choice. They maintain an additional buffer along with the content what you store, and that buffer will be continuously increased whenever you are appending the content to the string builder. Let's see that in action. Now in this case, we created a string builder object with content ABC. SP is a reference variable that holds a reference to an object of type string builder. Now this is fine. Now when we say sp.append of xyz, now this particular text is appended to the content of string builder. That means the string xyz is added to this string. Whereas previously what we have seen is, in case of string, we are not modifying the content. But in case of string builder, this content could be modified. So that's the major difference between string and string builder. Now let's see that with an example. Let's say string builder sb equal to new string builder of some text, let's say ABC. We can continuously modify the content of string builder using append method. sb dot append of pqr. Now when we print this string builder, you can see that the content of string builder is modified. This is fine. So there is one more important point to understand, and that is when we create a string builder, s1 equal to new string builder of some AB, and we say string builder s2 equal to new string builder of AB. If we say s1 dot equals of s2, s1 equal to s2, else let's say s1 is not equal to s2. You have already seen that equals method compares the content, but now when you see the result, you can see that s1 is not equal to s2, and this is because equals method is actually part of the class object. In case of string, equals was overridden by the string class and it compares the content, but whereas in case of string builder, equals method is not overridden as part of string builder. So if at all you want to compare the equality of two string builder contents, you need to convert them to string and then you need to compare using the equals method. That is s1 dot to string, s2 dot to string. Now we are converting the string builder content to string and s2 content to string, and then we are comparing to strings, which is possible. Now in this case you can see that s1 is equal to s2. So string builder is ideal for scenarios where the content of the object is modified, whereas string is ideal for scenarios where content is not modified. Let's understand what are packages. Package is a fundamental concept in Java. So whenever you create a new project, you will first create a package and you will put your classes inside those packages. That is fine. I mean, why I delayed this topic till now? That is because you need to understand classes, inheritance and few other topics in order to gain good familiarity with packages. Now, before understanding the topic, what is a package? Package is just nothing but grouping of things with a specific namespace. This is you normally do in your laptop or maybe at home when you are arranging the books. You arrange the books in a way that subject wise, author wise and few other classifications that you do, and you arrange the books accordingly. And similarly, when you look at your content management inside your laptop, you normally arrange the things like okay, these are my songs, these are my English songs, these are my some other favorite songs and so on. You are managing the things this way in your laptop. Similarly, you can also group the classes, say that okay, these are my service classes, these are my utilities and these are my modal classes, view related classes and etc. etc. So you can group the classes as per your need, and that is what is the fundamental concept behind packaging. Let's see that in action. Let's start with a new Java project. Let's say new Java project package ex1. Now, as usual, let's create a main class. Let's say main. So you can see you have an option here to mention what package it belongs to. Because we didn't select any package, by default it is considered as default package. What is a default package? Default package is just nothing but the root folder, so where there is no package at all. Now what if I want to create a separate package and put the classes inside it? What we can do is just create a new package, new and package. The name of the package normally begins with the organization's reverse domain name. Say for example, com.example, if we are working for example.com. So normally it will be a reverse domain name, com.example or something like that. And there will be some other sections of the package name. Normally it includes the project, if there is any name associated with the project, and again it's further divided with module and so on. Now let's not consider all these things now. Let's say we are actually trying to put some vehicle package. When we create a package and say new class and say car. Now here if you see, we are selecting the package com.example.vehicle for car. It's fine. Now when we create the class, you can see that the first statement of the Java file include the package specification. Here it indicates that this particular class belongs to this package. Normally in Java, what happens is it creates a folder structure with this hierarchy. So that is, initial folder will be com and followed by example folder and followed by vehicle folder, and inside that we will keep the car.class file. Now you can clearly see that even in Eclipse as well. Now let's say window, show view and see the navigator view. Here you can see the folder structure. As you can see, Eclipse has created it for you. there is a com folder and followed by examples folder and followed by vehicle folder and then car.java file. Similarly, the compiled class file will be kept under bin directory. Inside bin you can see com folder and followed by example, vehicle and then the class file. So normally packages are kept under a directory structure. So it will be a clean approach where you specify where you store classes in the respective folders. That's fine. Now let's add a simple method, say drive. I'll say driving a car. And let's also create one more class, say bike. And again, the package, you can choose a different package if you feel that this class should be part of a different folder structure. Now, let's say vehicle as well. Now, this package specification says that all the classes which are part of this Java file will come under this package. That's fine. And we'll put ride a bike. Now let's go back to the main class, and we'd like to create a object for this class, and we would like to call the methods. How we can do that? Car C1 equal to new car. But what happens is this class car doesn't belong to the same package. So it is part of some other external package. And in order to use a class which is part of some other external package, we need to have an import statement. What if I don't have an import statement? Normally what we should do is, this name reference should be a qualified name. Just like this car belong to com.example.vehicle.car. And similarly, wherever we reference a car, we need to prefix that with fully qualified name. That is something like this. And it will not be so easy. I mean, if we say c1.drive, similarly for com.example.vehicle.bike, b1 equal to com.example.vehicle.bike, b1.drive or write. That's fine. Now, wherever we are referring to a class which belongs to a package, if we have to prefix this name for each and every class, it slightly becomes tedious for the developer to write all those things inside the code. Instead of referring a class with a fully qualified name, what we can do is, we can say import com.example.vehicle.car. So what this indicates is, I am going to use the class car which is part of this package, com.example.vehicle. This is good. Then what about bike? In order to use the bike, again let's assume that we are going to delete this package reference. Again, what about bike? We again need to import bike as well. So this is the preferred approach. What you indicate to the compiler is, I am going to use the car from the package com.example.vehicle. So all the validations should be done against the class definition which is part of this package. Now for all the classes you are referring to this package, you need to have an import statement, and this is the preferred approach. Now if I say that I want to do it with one single import, what can I do is, I can use the wildcard character asterisk, which indicates that I am going to use the classes from this package. Now this looks good and simple, but it is not ideal for development scenarios because we don't know exactly which class is coming from which package. It's always better if you indicate the specific class name, something like this. Now if I import car, then again I need to import bike. If you don't want to do all these things, what we can do is from the source organize imports, Eclipse will do it for you automatically. To a quick recap, so whenever we are creating a package, we can normally specify the reverse domain name of the organization and followed by project, followed by module and categorization of the class and so on. And once that is done, you put the classes inside those packages, and the first statement of the Java program file is the package statement, which indicates that these are all classes belong to this package. And finally, when you are using that package, you need to put an import statement that indicates that I'm going to use this class from this package, so that compiler can do the validations against the class definition, which is part of that package. Now let's finally see the output as well. You can see, that's it. So we have another variation of import, that is static import. Let's see what is static import. Assume we have another package here. Let's say create new package com.example.someutils, where we are going to place some utilities, and let's say we have a class which is a date util. Now what this date util is going to do is, it's going to expose a method which is a static method that returns the formatted date. Let's say give me the date object and we will return a formatted date. As you can see, it is indicating that the date class is not known, and you can see that this date class is part of two different utilities. One is java.sql and the other is java.util. And that is the effectiveness of import. Import indicates that I am going to use a class from this package. So we are going to use the date class from the util package. So in general, a class could be part of different packages that may have a different meaning in different packages. Through import or through qualified name, we can explicitly state that I am going to use the class from this package. That is fine. And we just need to format the given date according to a specific pattern and return it. And for that, we have simple date format. Let's say SDF, which is new simple date format. And for this class, you need to specify what is the pattern to which you want to convert. Let's say DDMMYY. Now again, you need to import this class because that class is also not part of the same package. So import, so we are bringing this simple date format from the package java.text and return sdf.format the given date. So this method is going to format the given date according to the specified pattern, and it is going to return the string format of the given date, which we are returning from this function. Now we have the utility in place. Now we need to test this utility or call it with some value. For that, what we need to do is go to the main. Let's say, because it is a static method, we don't need an object for that. Formatted date equal to date util dot get formatted date for the current date. Now again, we need to import this date object. Now get formatted date. So where this date util is coming from? So this date util is coming from example.utils, and whatever the formatted date is there, you can print the formatted date. Now this is fine. When you run it, you can see we got the formatted date. This is good. For static methods, what we can do is we need to actually qualify the method with the class name. and class name dot and static method. Instead of repeating this class name again and again, what we can do is we can say import static and dateutil dot get formatted date. Now we are making a static import. So get formatted date of this dateutil is directly used inside this class. Now you don't need to qualify that with the class name now. You can call it as if it's a normal method, but the above import statement indicates that this is coming from this class. It just reduces the necessity to qualify a static method with the class name. Java allows 4 access modifiers before the members of a class. This is slightly tricky for beginners to understand. So I would like to keep it simple and explain you the core concept and leave the example to you. So Java allows 4 access modifiers, that is private, default, protected and public. When you don't mention anything, that it comes under default. So even the same case with the access modifier before the class. Now when you put it as public, it indicates that this class is accessible by public. When you don't mention the access modifier before the class, by default it is default. And default means it is accessible from within the same package and not accessible outside the package. And the same is the case with default members as well. These members are accessible from only within the package and not outside the package. So let's come back to the modifiers in detail. So private, as you know, it is purely personal to the class. So any private member could not be accessed outside the class. This is straightforward. When it comes to default, default is accessible from within the package and not outside the package. Package means com.example.vehicle, and this is all the members of this package can access it, not even the sub packages. Say vehicle dot something else is there, so those packages are not included. Only the classes that belong to this package can access the default members. Protected members could be accessible from within that class and within that package as usual. From outside the package, only subclasses can access them. And subclasses from outside the package can have access to both protected and public. And for others, only one member is allowed, and that is public. So overall, if you can think about it, subclasses have access to both protected and public members, whereas others have access to only public members. But from within the members of the same package, they can access default, protected and public. Let's take a look at what are exceptions and how to handle exceptions in Java. Now, to start off with, let me put an example here. Arithmetic utils. I'm going to define, because it's a utility, I don't want to create an object for this class, and hence let me put that as static, and let's give 2 values and return the division result. This is fine. You can keep this class outside and then put that into a separate package, but to make it clear and simple, I kept it here. Now, suppose we have 2 variables here, one is x is 10, y is 0 and z equal to utils dot div of x comma y. And let's print the result. Result is see. This is fine, but you know that this is going to result in some failure because the denominator is given as 0. But let's see what Java returns here. Java has actually thrown an exception called arithmetic exception, and the reason behind the exception is slash by 0, and this is what we call the stack trace. Stack trace actually informs you about all the function calls which happened till the origin of the exception. Now you can see that this actual exception occurred in main.java and inside this function div at line number 4. So this is where it happened, and we went to div method from the main method at line number 13. So this helps you identify the exception and where it has occurred, and you can directly go to the root of the exception and see why the exception occurred, and you can fix that problem. Now, if you want to handle this exception, this is not technically we should not handle these kind of exceptions, but still, in order to handle this exception, we need to use the try catch block. Try for the exceptions. So when we say try, you are indicating that this block might throw an exception, and it is followed by a catch block. Catch what kind of exception that occurred? That is arithmetic exception. So we can say arithmetic exception. Now this means that you are anticipating arithmetic exception from within this block. You are not supposed to handle this, but from the example's sake, let's keep it like that. Now you know that there is some failure occurred, and that control comes to the catch block instead of executing the rest of the statements. Now within this catch block, you can provide a handler for this exception. Let's say I want to handle this exception. I don't want to print any result. Just want to say caught arithmetic exception. That's fine. Now let's see what happens here. Now you can see that the result is caught arithmetic exception. Now this is what we call exception handling. An exception is a special kind of error. It might occur because of some coding issue, or for other reasons it may indicate a failure to perform certain operation. Say for example, you are trying to write some content into the file where you don't have the right permissions to that file, or you are interacting with an external system but the connectivity is lost due to some network failure, and the interaction will fail and it will lead to some sort of IO exception. And these are the kind of exceptions which might occur in the program, and you can provide a handler for that if you know that some exception is going to occur and what is the solution for that. Let's modify the previous code slightly. And here I don't want Java to throw an exception. I want to throw my own exception in case of failure. Let's say I'm going to define my own exception class, say my exception. And to make it an exception, you need to extend the class exception. Now this becomes your own exception or custom exception. Now inside the div method, if b is equal to 0, we are going to throw my own exception. Let's say throw. The throw statement will help us to throw an exception. Here we need to create an object for your own exception and you need to throw that object. Now to create an object, say new my exception. This is fine. We are throwing an exception if b is equal to 0, but why still it is showing an error? And this is because this exception should be handled. And what do you mean by handling an exception? We should use either try catch block here within this function to handle that exception, or we need to declare that inside the throws declaration. Now what happens is, because we don't want to handle it here, we need to say that this function throws my exception. Now if you carefully study this method signature, what this means is this div method is accepting two integers as arguments, and this is going to return an integer in case of successful scenario. But what if this div method fails? This method throws my exception. Now here if you can see, this call is throwing, it's showing an error because we are not handling my exception. Instead, we are handling arithmetic exception here. Now we need to change it to my exception. Let's say I'm going to say convert this to my exception. Now what we did is, we are making a call to div method and we are anticipating my exception from within that method, and if that occurs, we are saying that we caught my exception. This is just for an example sake. You clearly know that this is going to throw an exception, but in order to understand the syntax, we banged on this example. Now, to have an overview of what has just happened, we created our own exception, and inside the div method, if denominator is 0, we are throwing our own exception. When you throw an exception, you need to catch it, or you should declare that in the throws section so that the calling function will take care of it. This main method is what we call the calling function because it's making a call to div method. Now, as per this div method signature, we need to be ready for my exception as well. So, in case of my exception, we are making this, we are defining this code. Now, if there is no exception at all, it will continue to execute and comes out of try catch block. But if there is an exception, it comes to the corresponding catch block and provides this output. Now, let's run this program and see what is the output. You can see we caught my exception. What if I am going to send the right value to it? Now, because inside the div method, only if b equal to 0, we are throwing an exception, otherwise we are just simply returning the value. So, you can see that result and followed by 5. Now, let's run this and see. You can see that the result is 5. So, when there is no exception, control does not come inside the catch block. Only when there is an exception, it will come to the corresponding catch block. Let's see what are checked and unchecked exceptions. Now, if we remove this throws clause, it immediately leads to a compilation error. Java indicates that this exception should be handled, and we should either use try catch block to catch this exception, or we should declare this exception in the throws clause. Now, what happens when I extend runtime exception? You can see that this error is gone, this compilation error is gone, and this is because runtime exceptions are exempted from handling. Examples such as null pointer exception, array index out of bounds exception, and arithmetic exception and so on, they are runtime exceptions. That means they are the subtypes of class runtime exception, and they are exempted from handling because normally they indicate some critical error in the program, and we are not supposed to handle those exceptions. And because this is runtime exception, we don't need to handle that, or we don't need to declare that in the throws class. And similarly, there is another subclass called error. Even errors are exempted from handling. Errors such as no class definition found error, virtual machine error, and so on. And even they are not supposed to be handled. But whereas in all the other cases, when I say exception, now immediately Java compiler throws an error here because this is an exception and we should always handle this one. That means we should either write the try catch block or we should declare that in the throws class. Hence, runtime exceptions and errors are what we call unchecked exceptions because Java compiler doesn't check for any error handler. But whereas all the others are called checked exceptions because whenever you throw an exception, you immediately need a handler for that. Either it should be a try catch block or we should indicate that in the throws class. Now, if div is throwing an exception, and what if main doesn't handle that? Now, immediately as you can see, the compiler indicated that you need to handle my exception. What if I don't want to handle that here? Now, we can also declare that under the throws section. What this means is that even if main is throwing an exception, now the corresponding calling method which calls the main method, that need to handle, and technically speaking, this complete flow will be terminated by the Java virtual machine because of this exception. And because in this example there is the x value is 10 and y value is 2, you don't see any exception for this one. But what if this is 0? Now, when y value is 0, we have thrown my exception. Now, this exception object comes from here to here, and because it is not handled here, it again throws my exception. That means this is handled by the Java virtual machine, and it is going to stop or terminate this flow. And I can see that the exception terminates the main thread, and this is because it resulted in my exception and at line number 8 of the div method, and which is invoked through line number 20 of the main method. So let's look at some exception handling through slightly better example. I'm going to create a package here, say com.example.store, and within that package I'm going to create a class called product store. Now assume product store is the one which is responsible for giving you the quantity information and other details about the product. And let's say we have one more exception class, say product exception, and it is always better to make it an exception. We need to extend exception class. If you don't want a handler for this, then we can extend runtime exception, but we seldom do that. So it's always extends exception or any subcategory of exception. If you want a meaningful reason to put behind this exception, then we need to accept the reason and pass it on to the exception class so that it can print the reason. Now we have this exception now. Inside the product store, let's add a service, say get available quantity of the given product. Now for example's sake, let's say if product dot equals a, then let's return the quantity, say 2. Else if product dot equals b, now return the quantity 0. And if that is not the case, if the given product is not in this list, what we can do is, in other case, we can throw new product exception saying invalid product. Now because we are saying that we are throwing an exception in one scenario, we need to either catch this exception or we need to declare that in the throws clause. Because we don't normally handle immediately within the same method, let's say throws product exception. So the responsibility of this product store class is to take the product information and return the corresponding available quantity. And if it, in case of invalid product, it throws product exception. Now normally it's a good programming practice to write this a outside and then put the variable inside, because what if the given product variable is null? Now that leads to null dot, see in this scenario, let's say what if the product is null? Now you can see that null dot equals, it leads to null pointer exception, and to avoid null pointer exceptions we normally put the static literals outside and put the variable inside. Now in that case, if it is null, it will be not equal. Now this is just for sample scenario. So if it is A, you get 2, if it is B, you get 0, if otherwise you will see product exception. And assume, let's create a new package, say service. Now within this service, we are going to define a class called order service, and we are going to add a method place order for the given product and quantity. And in order to place the order, we need to check if the quantity is available or not. If that is not, then we will throw an exception. And for this scenario, so let's actually interact with the product store. So I would say private product store equal to new product store. Order service is going to interact with product store to check the product details, and then based on that it will accept the order. Now because it's showing an error because they both are not part of the same package, we need to perform an import. So now available quantity equal to store dot get available quantity for the given product. Now you can see that this store, product store, is going to throw an exception, product exception, in case of failure. Now you can handle this here and throw your own exception, or you can declare that in the throws clause. It is fine. If available quantity is equal to 0, now you know that you cannot accept this order, hence we will throw our own exception, say new order exception, insufficient quantity. But what is order exception? We need to create a class called order exception, whose superclass is exception. Now it is always better you put proper reason code. Write a constructor order exception that accepts reason and pass this reason to exception class. That is, we are calling the argument constructor of the exception class to accept the reason. Now that will be used to print the stack trace. Now let's come back. Now you can see that if the available quantity is 0, we are going to throw order exception. It says that it is insufficient, we have insufficient quantity. Now again, we need to throw this, because we are throwing the exception, we need to either catch it here or we declare that in the throws class. We can say, okay, I'm also going to throw order exception. Now otherwise, order accepted. Now here we also need to add another condition, say available quantity equal to 0 or requested quantity is less than or equal to available quantity. Now if that is not the case, that means greater than. If the requested quantity is greater than available quantity, we can say insufficient quantity, otherwise we accept this order. Now let's see that through an example. Let's take order service, new order service, and service dot place order for product A and quantity 2. But because when you are making a call to the place order, you need to handle two exceptions. So one is product exception and the other is order exception. So you can write a single handler like this, or the other workaround is, instead of writing a single handler, you can say handled product exception or e dot print stack trace, that prints the full stack trace. This is also normally, it is also not done because we will be using loggers to print the stack trace, but for now we can keep it like this. And there is one more exception to be handled, that is order exception, and here handled order exception, and use the print stack trace to print it. Let's see what happens here. Your order is accepted. Let's say I want B. Now this leads to order exception with insufficient quantity. I can see that we got an order exception with insufficient quantity. It occurred inside place order method at line number 13. Now, let's see what happens here in product C. Now, this leads to product exception, invalid product, and it happened at get available quantity method at product store and line number 11, which is called from order service from line number 11 and which is called from the main method line number 10. So, instead of writing multiple catch blocks, we can combine that into a single catch block if needed. So, this is a multi-catch. So, handle both order or product exception. So, you can use this way, or the other workaround is, say I am going to catch all the exceptions. Because exception is the base class for all the exceptions, it can catch any exception. This is called generic handler, which is normally written at the end of all the catch blocks, because once you know that these are the exceptions which I can handle, and you can place a single generic handler for the rest of all exceptions. Now, let's take a look at what is finally block. Finally block is written at the end of the try catch block. Normally, it is used for scenarios where there is a piece of code which should be executed irrespective of exceptions. Say for example, you are looking to close a resource. When you are looking to close a resource, irrespective of failure, the resource should be closed. Otherwise, it leads to resource leaks. So, such scenarios are better handled through finally. Now, control enters this block and it prints this before try block, and then once it enters into the try block, now at this point it prints what is inside try, and if a equal to 1 because it is true, it need to execute the return statement. Once you execute the return statement, you need to return from this function. That means you should go out of this function. But the point here is, because control enters the try block, it goes out only after executing the finally block. Let's see that. Now you can see it printed before try block, then inside try this statement, and it need to execute the return statement, but still it came into finally, printed that, and then it returned from the function. That is fine. Now let's say instead of return, what if we put throw new runtime exception. Now this throw statement takes you to the corresponding catch block. Once the catch block is done, now it need to enter the finally block before it leaves this try block, and hence once the try block is done, it comes out and executes the rest of the program. Let's see what happens in this case. Now before try, inside try, so the statement gets executed. Inside catch, because a equal to 1, we have thrown runtime exception, so it needs to go to the catch block. Now it comes here, executes inside catch. Once done, it executes finally before it can come out of this try block. Similarly, in majority of the scenarios, whenever a control enters the try block, it always executes the finally block, and hence this is the best candidate where you can put all the resource close operations. We will see that in action in future examples. So from here on, we will be understanding what is java.io package and see what are the utilities available so that we can perform some input-output operations over the files. And the first class that you need to look at it is file. File is a class that allows you to get the meta information about the file. Let's say new file, and there is some folder where I have kept some sample.txt. Now because this shows an error because this class is part of IO package, you need to import the file from IO package. Now this is fine. So what is the advantage that you get from the file? Now, with the help of the file object, we can extract the meta information about this file. Let's say I want to see the length of this file. F dot get length. Now, if I want to see the length of this file, I can say f dot length. Length is going to give me the length of the file. Let's say if I want to check if this file exists or not, I can use f dot exists to check if the file exists or not. I can say that once it returns true, I can say that file exists. It may be file or directory. Now, if I want to ensure that that is a file, what I can do is I can make it and f dot is file. Is file returns true if it is a file. Now, similarly, you can get the last modified date of the file. Let's say f dot last modified. We can get the last modified date of the file. And there are few other operations which you yourself can take a look at. So, file class allows you to extract the meta information about the given file. If I run this program and see, you can get some, if the file exists and the length of the file is 53, and this is the long value of the current date. Now, if you are looking for an exact date format, I would say create an object, date object with this value. Now, I can see that this is formatted date. So, and there is one other handy operation. If you are looking to create a folder or if you are looking to create a file, you can use the file object to create a file. If I say mkdir, if the given path is a directory, you can use mkdir to create the directory. You can use mkdirs if you feel that there are some of the path, some entries of the path doesn't exist, then mkdirs will create those entries for you. And there is a method called create new file which allows you to create a file. So overall, use the file class to extract the meta information about the file and to check the existence of a file and to create directories in the specific folder and to create the directories. Now let's see how we can perform the read and write operations over the file. And for that we have classes called file input stream and file output stream. Let's say file output stream. Let's name it fout. So new file output stream of some a.dat, some data file. Now this file output stream class is part of java.io package again. We need to import that class. And now because the write operation may fail, this file output stream class will throw IO exception, and in order to handle those exceptions, we can declare that in the throws or we can use the try catch block. Let's declare that in throws for now. So we can pick the IO exception which is base class for all the IO exceptions. That's fine. So if I want to write some content, let's say fout.write. So whatever you write, it will be in the form of a byte. Let's say 10, I want to write 10, so which is a byte value. And similarly, fout.write, so 20. So you have written 2 bytes into the file. Now let's say I want to close this file. Now in order to read the data, we need to use the class called file input stream. Let's say fin new file input stream of a.dat. Now again we need to import the file input stream class. Now when I say x equal to fin.read, read is the method which allows you to read 1 byte of value at a time. Similarly, y equal to fin.read, and let's print what we got, x and y. Let's close the file. Here you may get a question like you are saying you are reading a byte, then why did you assign it to an integer? So Java is going to return you only 1 byte value, and which is kept as part of the last byte of the returned integer. So you'll only get 1 byte at a time. Now similarly, the write operation also writes the last byte of the given integer. So the basic file I/O operations perform read and write operations over bytes. That is the basic unit of data. So when I execute this program, we created file output stream where you want to write some content into the file. That is, say here, for example, the file name is a.dat. We have written 2 bytes into the file, and we closed that file, and later we reopened the file for read operation where we have the read method to read the content of the file. Let's run and see. We got the values which we have written. So this is the basic file I/O. So let's further expand on what we have learnt in our previous example. Now in this example, let's copy the content of one file into another. Now let's create the file first. Say I want to create a file, say for example input.txt, and let's put some content inside. This is some input file, line 2, line 3 and so on, line 4. Save this. Now I want to copy the content of this file input.txt into output.txt. Now before getting started with this example, I would like to create a package. Let's say new package com.example.utils. Now let's define a new class IOUtils. Now here we are going to write a method that copies the content of one file to another. Let's say make it a static method. Let's say copy. So in order to copy the content, we need 2 streams, one for writing the content and the other for reading the source. So I would say file input stream src source and file output stream, which is destination. Now both the file classes should be imported, file input stream and file output stream. Now we have 2 streams here, input stream and output stream. Input stream helps us to read the content and output stream helps us to write the content. So we are not supposed to open or close these streams because the way that we have written, it is up to the caller to actually create a stream and then pass it on to us. Now in order to read the content, I would say some value and value equal to src.read. This is good, but it reads only 1 byte. We need to read it continuously till the end of the stream. So what we can do is we can put this inside a while loop and say value equal to src.read till it is not equal to -1. So this loop will repeat as long as there is a byte inside this source stream. Now it returns that byte. If the value is equal to -1, that means that it is the end of the stream. So till it is the end of the stream, this loop repeats and value gets 1 byte at a time. Now we can use this value to write the content to the destination. Destination.write and this value. Now We read the source stream continuously till the end of the stream, and we have written the obtained byte to the destination. These two operations might throw IO exception, and that is because we may or may not be able to read the source stream, or we may or may not have the permissions to write to the destination stream. And for that reason, they throw IO exceptions, which we need to handle. So instead of handling it here using the try catch block, we can use the throw statement to throw the IO exception to the caller. This is good. Now we have written a small IO utility which copies the content of source stream to the destination stream. Now let's test it. Source equal to, I would say, input.txt and destination file output.txt. Now we need to, for reading the source, we need to open the stream using file input stream, new file input stream of source. Now in order to write the content, we need to use file output stream, new file output stream of destination. Now we open both the streams. Now because it may throw an exception, I am also going to throw this from the main method. Now I will use the IO utils to copy the content from source stream to destination stream. Once done, I can close these resources. Although this is inefficient slightly, I have just kept it as an example because we are supposed to close the streams irrespective of exceptions. We should be using try catch block for this, but in this example our focus is mainly on how to copy the content from source to destination. Now let's see the output of this, say run as Java. So it is done. The actual file is kept inside the project itself. So refresh this. I can see the output.txt where the content of input.txt is copied to the file output.txt. So let's further expand our previous example. Let's go to this copy method. Now if you can see this, we have written the code for file input stream and file output stream. But there are so many input output stream classes for which the same copy could be utilized. So instead of writing this code for file input stream and file output stream, we can write this code for base classes input stream and output stream. Now what happens here is, we are writing the code for input output streams. These two streams are abstract base classes. We don't need these two imports. So these two streams are abstract base classes where the read method is actually kept as abstract. Now if you look at this carefully, the read method is abstract because input stream is a class where it doesn't know where to read from. Now it is up to the file input stream to perform the read operation from file. And similarly, there is a byte array input stream that reads from byte array. And there is a socket input stream that reads from socket, and so on. So that is how the abstract class works. You have an abstract class with an abstract method, and all the subclasses will actually define what the method should do. And the rest of the functionality will be inherited by those subclasses. If you can look at it, there is still some code which is available from input stream. So the input and output streams, but they can still be a variables where they are expecting some input stream object here. So this copy method is now applicable for all input output streams if you can look at it. So and hence while writing the utilities, you always prefer the base classes rather than subclasses. Now this code is now slightly efficient because you are now copying the content from one input stream to the output stream, and you are not defining or restricting the user to have specific stream. That's the advantage of it. And the other point is, here in this code you are reading 1 byte at a time. Suppose you are capable of reading a buffer So some 100 bytes or 1000 bytes at a time. Instead of reading something like this, what we can do is we can create a buffer. Let's say n stands for some count. Let's say byte array some buffer, and let's keep the buffer size as 1024, so that is 1 KB. Now instead of reading into 1 byte, we can use the second variation of read, which allows us to read into the buffer. Now this read reads the bytes into this buffer. So the capacity of the buffer is 1024. But you should always remember that read might not read the entire 1024 bytes. Say for example, the file has only 500 bytes. Now in that case, buffer only if the first 500 bytes of the buffer will be filled. How will I know that? So the return value n indicates the number of bytes read. So if the number of bytes read is positive, instead of -1, we should be writing this as greater than 0. If the number of bytes is positive, that means there is at least 1 byte read. We can write the bytes from the buffer. But we cannot write the entire buffer because we are not sure that the entire buffer is read from the file. So that case, you have a second variation of write operation where it takes the starting index and the number of bytes, and the number of bytes are n. Now what we did here is we created a buffer of size 1024 and we started reading into the buffer. As long as the read operation reads the bytes, we are performing the write operation from the buffer and not the entire buffer, starting from 0 to the number of bytes read. Now this way we are doing a bulk copy instead of a byte by byte copy. And also we have adjusted the code to take the input output streams, and hence the same code is applicable for all input output streams. And let's also adjust our code slightly here, and instead of opening and closing this file, let's handle the exception and say file input stream, make it null, and file output stream, let's make it null as well. Now try, let's catch the exceptions. New file input stream of source and new file output stream of destination. Now perform the copy once the streams are open. Now we did the copy. You can say done. Now instead of, if you are looking to catch the exception, IO exception, that's fine. Failed during copy. You can print the entire stack trace, or you can only print the first line of the exception message. And finally, let's not close this like this. Finally, if file input stream is not equal to null, let's try to close the file input stream. And similarly, if file output stream is not equal to null, that means it was opened, we then close the file output stream. But still there is some technical glitch here. So this stream, we should handle this IO exception here. So what we can do is we can surround this with again another try clutch block. Sorry. We should again surround this with try catch block, and similarly we should surround this with try catch block. So this is how we should write it. Now open the input stream, open the file output stream, copy the content, and then in case of exception, do whatever the handling that you need to do. And inside the finally block, if it is not equal to null, then the stream was opened, then close it. And similarly for a file output stream, if it is not equal to null, then you should close it. And this is how we use finally to actually perform the close operation on the resource which was opened within the try block. Let's clear the output file and see if it performs correctly or not. Run as Java application. You are done. Now let's see what is the content of the output file. You can see that is the same as the input file. Now let's see how we can attach the streams together. What we have already seen is file output stream. When we create file output stream object and supply some file name. Now this stream is capable of performing byte based IO operations. This is good. Now because this throws an exception, you need to declare that in the throws class, say IO exception. Now good. We created an object for file output stream and we have written few bytes to the file output stream, and then we closed the stream. It is very simple, but this IO operation is what we call unbuffered IO. So the content is directly written into the file. If you carefully look at it, file IO operations are capable of writing more than just one byte. That means they perform a block IO at a time. Now directly writing one byte at a time into the file may not be an efficient way of doing the things. Now if you are looking to have a buffered IO kind of thing, that means you want to maintain a buffer in between, and then once the buffer is full or once the flush operation is invoked or close operation is invoked, then the buffer should be sent to the actual file. In order to get that functionality, Java has given you multiple options. Now in this scenario, what we can do is we can create an object for buffered output stream and give it or supply it the file output stream object, and just change the IO operations from buffered file IO to buffered IO. Now what you are doing is you are writing that to the buffered IO, and this buffered output stream maintains the in-memory buffer, and it will send the buffer to the file output stream once you close the buffer or you manually invoke the flush operation or when the buffer is full. And this is how you can connect two streams and perform the operations at your wish. Carefully understand what I am going to do with this example. Let's say I am writing a class called sample with some private field, integer and value. And now I will be writing a setter and getter. I don't need to write, I can generate it, select the value and generate the setter and getter. It's fine. Now how to use that class? You create an object for sample and then you can set the value, set value of 10 and you can say, or instead of this, let's say obj.get value. Now this is good. Now when you print it, you will also see the value. That is fine. Now this class is applicable only for integer. What if I want to set it to double? Let's say I want to use it for double. Now this doesn't permit because the set value requires an object of type integer, and hence it is not applicable for double. Now if I change this class for double, what if I want to use it for float? It is not going to work. So To make it applicable for all types of values, I might have to make it object. If I say object, so now it works. The only adjustment that you need to make is you need to, because the return value for get value is of type object, so we need to typecast it to integer to make this assignment work. Now this is good. Now again you got it, and now what if I set this value to a double? It didn't complain. See, the value that you are passing here is an object of type double. Now what is expected is an object, what you are supplying is a double. Java does autoboxing for you. So when you say 10.2, it's going to create a double object with value 10.2, and then this object is passed as an argument. Now in that case, because you are passing double and what is expected is object, this works. But the other side of it, see, when you are trying to get the value, compiler did not complain because the return type is object and object could be an integer as well. But at runtime, this cast will throw an exception. Now when you see that, it resulted in class cast exception because the value java.lang.double cannot be cast to integer. So this is the kind of problem that we will face if we are actually writing the code for object. Instead of writing the code for object, what we can do is we can write the code for some template type. Let's say T. Now here the type for value is T and the return type is T. What is accepted is a value of type T. Now see how this code is transformed. Now when you want to use this sample for integer, you just say that I want to use T is of type integer. When you say T is of type integer, it won't accept the double value anymore because here in this within this instance, the T is of type integer, hence the code is written for integer. Now it is not going to accept this value of type double. That is fine. Now the same code, if I want to use it for double, I can still do that. I can say I'm going to create an object for double, which is object 1, and I'll say it is of type double. Now when I am trying to set the value, I can set a double value, and when I am expecting a value, I know that it is of type double. I don't need to even typecast it because this works for double, because the return type for get value is T itself. Now in this case, you don't even need to typecast because the return type for get value is T, which is nothing but integer in this case. Now in this case, the return type for get value is double, so hence you don't need to typecast. Now when I say T is string, this class is now transformed for a string. This way we can write a class which is generic enough to accept any value of type T. It may not be T, just as a literal we took it. We can use a different naming convention as well. You can say type and you can use type inside it. There is another interesting concept called template methods. Now let us see what it is. Now if we have an integer array, some values, let's say 10, 20, 30. Now we are saying we are going to write a display method for this array. Now let us say that we are going to add a method void display which takes an integer array and prints it. For each integer value in ARR, it just prints that value. Now this is fine. When you print it, you can see we got the result as well. Now let's say that we have a double array as well, ARR1, which is of type double, some 30.4. Now can we use the same display for double array? No. Now in this case, we need to either override this method to accept the double value, or we need to convert this to object. So there is another workaround for this. Instead of changing it to object, what we can do is we can say T, or you can say type, whatever it is. Now say that the display is going to accept an array of values of type T. Now instead of integer, you write for T. Now this code is now applicable for all arrays of type T, whatever is the type. Now where T is determined based on the argument passed to the function. Now in this case it is an integer array, hence T is going to be an integer. Now in this case it is a double array, hence T is going to be a double. So let's see what happens. I can see we displayed integer array and we displayed double array. So this is what we call function templates or generic functions, where the type is generic and it is determined based on the argument passed to the function. Now let us look at the most important topic of the lot, that is collections. Now collection, as the name indicates, is a collection of objects. And there are two types of collections. One is the list types and the other is the set types. List types allow duplicates, whereas set types doesn't allow duplicate. Now in this example, the LHS of this assignment is an interface. A list is an interface, and for which the collection is the base interface. And now on the RHS, what we have given is an object, which is an implementation of this interface. Now here we created an object of type linked list and we added few values to the linked list. As you can see, there is a value which is repeated, but still this gets added into the list because list allows duplicate values. On the other hand, if you look at it, set is the interface, which is again a sub interface for collection. And then on the RHS side, what we have given is a hash set, which is an implementation of the set interface. Now here again we are giving the same set of values, but when you run this application, you will see that the last value 10 is not added. Now let us see what is the output. Now in case of the list, you can see that there are duplicates in the list because the 10 got added twice. But whereas in case of set, now 10 is now added only once. Now that is fine. Carefully observe one more point here. The values that you see here are not in the insertion order. Now you inserted the values in this order 10, 20 and 2, and what you are looking here is 2, 20 and 10, and this is because of the hash functionality. Hash functionality uses the hash code to store the elements, and its storage is dependent on the hash code, and that may not be the insertion order. Now if you are looking to preserve the insertion order, you need to use the collection called linked hash set. Now when you say linked hash set, the insertion order will be preserved. Now let us see what happens. You can see that the value 10, 20 and 2, you got the output in the insertion order of the elements. Now when you are looking to preserve the insertion order, use the collection called linked hash set. Now when you are not concerned about the insertion order, you can use hash set. And also there is one more variation. Now, if you use tree set, which is nothing but a sorted set, which is a sorted set is again a subinterface for set. Now, as the name indicates, the values inserted will be sorted automatically. Now, here you can see that the output is in sorted order. And also if you notice, you can see that there are so many warnings here, and this is because these collections, if you look at it, if you look at it, these are of generic types, and because we didn't mention any type here, by default it is object. Now, we are not supposed to use the collections this way. We need to mention what is the type of element that you are looking to insert. So, let us say list of type integer, and the object is also a list of type integer. You need not mention the integer here because it is automatically applicable based on the left hand side of the assignment. The same thing here, you can say set of type integer, for which the object given is also a tree set of type integer. You can see the warnings are gone. Always you should use the collections by specifying the generic type. Let us see how we can use them to solve the problem. Here is an array of integers. Now, I want you to remove the duplicates from this array and also print how many times a duplicate occurred. Now, that is fine. You may be looking at solving this problem through for each loop and make sure that whenever you find a duplicate, you actually increment the counter and so on and so forth. Now, let us see how we can solve this problem pretty easily using collections. Let's say duplicate count, let's say duplicate count is equal to 0. What I would do is, I'll create a set of integers, and let's say I'm going to take hash set. And for each integer value in the array, I will add this value to the set. Now, if it is a duplicate, as you know that it won't get added. Now, unique values are, and you can print the set. This is fine. This is pretty good and very simple. We need to also display the count of number of duplicates that are ignored. And for this, we can use the return value obtained from the add method. Add returns true when the collection is modified, otherwise false. Now, what we can do is, if added, that means if this add returns true, then it is added. If not added, so if not added means it's a duplicate, so we can say that we can increment the duplicate count. You can say number of duplicates ignored. That's it. Let us see what happens. Now, you can see that these are unique values, and also there are 3 duplicates which are ignored. That means 20 occurred 1, 2 and 3. As you can see now how easily we can solve this complex problem. Now, if you are looking to get a sorted set, you can simply say tree set. Now, that's it. I can see that the values are obtained in the sorted order. Now, you may be asking a question, what you are doing here? Actually, when you are trying to print a set, the output of the toString method is actually printed. Now, instead of printing this directly like this, we can also iterate through the set and print the values one at a time. Now let's say iterator of type integer, and we can ask for iterator. Now this iterator interface is implemented by the set. Not only set, each and every individual collection will have an iterator implementation. Now using this iterator, you can write the loop and get individual values from the iterator. Now if I dot has next, so if there is a next object, we can take the next value, I dot next, and then print the value. Unique values are, and we obtained an iterator from the set, and for each object in the set we are actually printing the value. Now I dot has next returns true as long as there is a next object, and I dot next gives you the next object. So this is one way of iterating through the values in the collection, and this iterator is available in almost all the collections. And you don't even need to do these kind of things. It is even further simplified. Let us say instead of doing all these things, we can write it as for each integer value in the collection. That's it. This is even better because we don't even need to manually get the iterator, do has next and next. We can simply iterate through the values in the collection. So using the for each loop. So for each integer value in the collection, print that value. Let us see what is the output. I can see that this is using the first for loop, using the iterator, and these values are printed using the second for loop. They both are same, and this is your preferred approach now. There is one other type of utility class called map. A map is a key and value pair, where a key is an object and also a value is an object associated with that key. Now here, as you can see, the LHS side of it is an interface and RHS is an implementation. So RHS is again a hash map, which is an implementation for the map interface. Now in order to put a value into the map, you need to use the put method, where first argument for the put is the key and the second argument for the put is the value. And in order to extract or get the value from the map, you just need to use the get method, supply the key and you get the value. This is pretty simple. You can clearly observe that the compiler is throwing some warning messages, and this is because again this is a generic type which we didn't use it properly. So what is the type of key, which is a string, and what is the type of value, which is also a string. Now again, so that is of same type. So now the warnings are gone. Now let's run and see. We got the values. Now that's fine. Now let's solve some sort of complicated problem in around this. Now I would say I would create a new class, say main1, and I'll give you a simple string. It says this is sample string and this is sample string, this is sample string. And now I am asking you to identify or print each word along with its frequency. This may be a complex problem earlier, but now using collections this is quite simple. And how it is? Now let us solve it. I'll say first I'll divide this into words. Maybe I'm not using the punctuations here. Split based on space. str.split is going to split the given string and it will split that into individual tokens based on the given regular expression, but here we mentioned space, so it splits the sentence based on the space. Now we are getting the list of words, and what we can do is for each word in the list of words. Now I would like to maintain a table which indicates where the key is actually the word and the value is the frequency. Now for that we can take a simple collection, say map, where the key is of type string and value is of type integer. Let's say word map and hash map of the same type. So now for each word in the list of words, what we can do is let us get what is the value in the word map for this word. First time the word doesn't exist in the map and hence it returns the value null. Now if value equal to null, I will set the value now, else I can say value equal to value plus 1, and again I will put that into the word map, word and the value. Now we are done. Let's see what is that we got. You got string and the frequency is 3, this frequency is 2, and this is because these two are different because the first letter is capital here. So this occurred once and is occurred thrice, sample occurred thrice. As you can see now how complicated problem is solved very easily through collections. Now you may ask a question, how can I go through individual elements of the map instead of directly printing it like this? And it is also easy. What we can do is we can request for key set word map dot key set, and key will be set because there will be no duplicates, and for each key in the key set, as you know, you can iterate through for each loop in the set. Now you can get the frequency using the key, and now print it. Word is nothing but the key and the frequency is the frequency. Now see what happens here. The word is string, frequency is 3. So what you did is we requested the word map for the key set. So we got a set of all keys, and using this key set we are actually iterating through each and every key, and we are trying to fetch what is the value associated with that key, and we printed it. Now we can also do it in a different way. We can ask for entry set. This may look slightly complicated for you, but still don't worry. So the set of all entries. So entry set is nothing but map dot entry, which is of type string, and value is the frequency, which is an integer. Now you get the set of all entries using the word map dot entry set. An entry is actually a key and value pair, which is nothing but one single row in the map, and for each entry map.entry of type string and integer in the entry set, you can now print entry key. Now you can use the entry set to get the key and value entry dot get value. So here what we did is we actually extracted the entry set. So entry set will give you the list of all entries where each entry is again a key and value pair. Using each entry we can extract what is the key and what is the value. Now this is also useful at times, but we rarely use it. We can easily go through the key set and iterate through individual elements of the set and get the values against it. Now this is slightly simpler approach. And see, we got the same result. Now let us recap what we have studied as part of the set. Now you know that a set doesn't allow duplicates. Here we have our own component called fruit. Now what I am doing here is I am actually adding new fruit objects. Now you can see this set, I have added 2 fruits of same name. Now guess, will the third one gets added into the set or not? Now let us see what happens. Now as you can see, the third one also added into the set. Here what the collection framework does is, in case of hashing, so it tries to extract the hash code from this object. And because you didn't override the hash code, what it does is it takes it from the object class, which is almost always unique. And when the hash code is unique, that means that the object doesn't exist and it gets added. Now let us override the hash code method and see what happens. I will say here hash code and we'll be returning the hash code for the name and not the hash code which is available as part of the object class, and see if this solves the problem. It didn't solve because even if we had overridden the hash code method, but still the Apple object got added. Now this is because you didn't override the equals method. I assume that this is a bucket and these are the hash codes. Now let us say that when an object needs to be added into the collection, it first generates the hash code, and based on that hash code it identifies to which bucket it goes, and let's say that this comes under 2. Now in that case this object gets added into this bucket. Next time when a new object needs to be added, it first again it generates the hash code, and if it says that this value is 4 and it is unique and hence it is added into this collection. Now let us say we are again trying to add this object. Let's say that hash code of this new object is again 2. Now this might be because of some mathematical formula, so hash code might match. Now in that case what it does is it actually tries to compare these two objects with equality. If they are equal, then this object is not added. If they are not equal, then the object gets added into that collection. That means the first step for you would be to override the hash code method, and then the next step would be to override the equals method. Now instead of you yourself writing these two methods, you can still generate this. Right click source and generate hash code and equals. Now, and what are the fields need to be considered? You can select those fields and you can see that the hash code and equals methods got generated for you. Now see what happens. Now you see that the duplicate apple is not added. So overall, when you are using a hashed collection and when you don't want to add duplicates in the hash set, what you need to do is you need to first override hash code and equals. Overriding only hash code may not be sufficient because there may be cases where the hash code might be same. In such scenarios, collection framework banks on equals method to check if the object is equal or not. If it is equal, then it's not added, otherwise it gets added into the collection. Now let us convert this hash set into a tree set and see what happens. And the problem here is it led to class cast exception because fruit cannot be casted to comparable. And this is because now this tree set is not looking for hash code and equals, because what tree set needs is to compare two objects, and for that scenario it is actually looking for whether the class is comparable or not. Now if the class is comparable, you can add objects into the tree set, but if it is not, then we might have to write our own comparator. Now let's remove this for now to make it simple. Now what we need to do is we need to implement comparable interface. Now what is comparable? When we say implements comparable, we need to provide a method called compare2. So override this method and define how you want to compare two fruits. Now let's say this object is of type fruit. The other fruit, the object is of type, let us typecast, and now see name dot compare to of other dot name. Now here you are trying to return the same value what is returned by the compare2 method of the string class. Now when you make it comparable, now you can add these objects into the tree set, and because they are comparable, they are sorted based on the result obtained from the compare2 method. Now if compare2 method returns a positive result, then that means that the object 1 is greater than object 2. If compare2 returns a negative result, object 1 is less than object 2, and if it returns 0, they both are equal. Now let us see what happens here. Now you can see that these two objects are arranged and also duplicates are not added into the collection. That is fine. Now what if this is not comparable? What if we didn't implement comparable? Maybe this is a class which is a legacy class or obtained from some other third party. So we want to still use it inside a collection. Then what we can do is we can define our own comparator. Let's say fruit comparator implements comparator of type fruit. And then you define the method compare fruit 1 with fruit 2. Now in this case we cannot say o1.name because that's a private field. So o1.getName dot compare 2 of o2.getName. Now this is our own comparator. Now we can have multiple different comparators for fruit, and we can still use it with collections as per our need. Because this fruit is not comparable, so while creating a tree set object, we need to supply what is the comparator to use. We are saying you please use fruit comparator. Now this way we can also add the comparison logic for an existing class. And this is always a better choice because it gives you more flexibility to choose different comparators based on the requirement. Now let us see. Yep, we solved the problem again. So in case of hash set, you need to override equals and hash code. But whereas in case of tree set, you need to define your own comparator, or the class itself should be comparable. So in this section, we are going to understand what are nested classes and how to define lambda expressions. Now when you write a class inside another class, this is called as a nested class. Nested classes are normally categorized into two. One is the static nested class. So when you add static modifier before the nested class, this is called as static nested class. And a normal class. So non-static nested classes are also called as inner classes. I'll say that this is inner class. So what is the advantage of writing an inner class? Certainly there are few advantages. It actually increases the encapsulation, and it also makes the code more readable and maintainable. Now let us not worry too much about static nested class. So like static member, this also can access the static members of the outer class. Now let's not worry too much about it. Now let us see what inner class does. Now if a member is available in outer class, I will declare it as private. Like a normal member function, this also can access the members of the outer class directly. Now I will say setx or demo, and here in the inner class I will write the print method, and I will print the value of x. So now inside the demo method I will create an object for this inner class, new inner class object, and I will say obj.print. Now if you carefully observe, inside the inner class we did not declare x, but x is still accessible. X is a member of the outer class and it is still accessible from within the inner class, and that is the main advantage that you get from writing inner classes. Now let us see what is the outcome of this one. We will create an object for outer class and obj.demo. Now let us not worry about what is happening here. The only point that we want to observe is the variable x inside the inner class, though it is the member of the outer class, it is accessible. Now you can see that the value of x is 0. I will give 10. Now you can see that the value of x is 10. So the variable here is this one. Now we will see what is the real usage of this one. So we have seen that an inner class can access the members of the outer class directly, and this is normally used in scenarios where the classes are grouped together and the subcomponents of it are also encapsulated as part of the class definition itself. We will see that with some main example here. Now here I am going to design a separate class called myArray, and I will implement a simple array functionality. Let us say it has the array variable reference variable declaration. I am not going to initialize unless we create the object for this class. So I will use the constructor, and during the construction process you need to specify the size of the array, and based on that I will allocate the memory for that array. This is simple, and also I will give you an add method with index and the value. I will just simply put this under this index. That's fine. And and I will print the values for each int value in the array value. So the usage of my array is pretty straightforward. I'll create an array, my array of size 3, and I will add the value 10 at 0, and I will add the value 20 at 1 and 30 at 2, and I have the print functionality. Now let us see what is the outcome. Now you can see that we got the values. This is fine. Now I want to make this my array iterable. So that is implements iterable of type integer. Now what does this mean? So you can put the my array object inside the for each loop. So here we need to design an iterator and we need to return that object which is capable of iterating through the array. If you are making this class iterable, we need to provide a custom implementation for iterator, because we are as a designer, we know how the data is organized inside this class. Now here this is an array, but it could be a tree, it could be a map, or it could be some other data structure as well. Now designing the iterator, we can take two approaches. One, you define an external class, say my array iterator implements iterator of type integer, and then provide the methods. So has next and next. Now if you design this class outside this our my array class, the problem is we need to supply or we need to give access to this data structure as well. Instead of giving the access to the array to some external class, I can make this class as part of this class definition itself. So this makes it an inner class. And because it is an inner class, it can now directly access the members of the outer class directly. So here I will declare a variable called current index, declare it as int, which is, that is 0, and if current index is less than a dot length, then I can say that there is an element. When somebody calls next, a of current index, I will return the integer associated with the current index. I am not too worried about the exceptions here. Now this my iterator, my array iterator can also be made private so that no outsider can directly use it. Now when somebody calls for iterator, you can simply return an instance of my array iterator. So that's it. Now you can see that the entire data structure definition has two parts to it. One is the actual my array implementation, and the other is the iteration part of it, which is designed as a separate class. And this is how we have created two different classes, but still we extended the visibility of variables to the inner classes. Because the inner class can access the members of the outer class directly, we can now directly access the array. We don't need to supply or create a separate getter methods to access the variables. And we designed the entire structure into two different classes. This way we have also achieved a bit of modularity, and also we enhanced the encapsulation. So now let us see how it works. I will call it as iterator of integer. Let us ask for iterator. Now while I dot has next, I dot next. Values of the array are. Now internally this iterator function call actually returns an instance of myArrayIterator. We cannot directly use this class outside this class definition because it is private. And being an inner class, now it can extend its own class or it can implement its own interface, but still it has the provision to access the members of the outer class directly. So we achieved the modularity and also we enhanced the encapsulation. Now let us see how it works. I'm sorry. This is current index plus plus. I am incrementing the current index once I access the element. Now you can see the values of array are 10, 20, 30. And also because it is iterable, we can also use this inside the for each loop, that is using for each. For each integer value in ARR. Although ARR is an object of type myArray, because myArray is iterable, so it can be directly used inside this for each loop. Now this also works. Let's print and see. Okay. Now let's print and see. I can see the values of array are first structure and the values of array using for each loop. So we used the inner class concept to extend the functionality of a class using a separate class and implementing its own interface and giving access to the members of the outer class directly. So there are several benefits of using inner classes, and it is very good when you use it properly, and it also gives you some extra bit of flexibility because as an inner class it can extend its own interfaces, it can extend the separate classes, and also it can access the members of the outer class directly. There is no need to panic, just think that it is a simple function, just like a function, because it is also a member, it can access even the private members of the outer class directly. And there are two variations of these nested classes, one is static and non-static, and the one we call it as inner class is a non-static inner class. Now when it comes to static, just the same rules apply as if it is a static member, it can only access the static members of the outer class. We have two more variants of nested classes, that is local classes and anonymous classes, and you need to understand them before you can get into lambdas. Now to help you understand it easily, let me take a simple interface here. I will say greet and I will declare a method called say hello. And here I will take a variable called name ABC. Now any class which is written within a block is called as local class. So I can also define a class here, say class local. So this class is called as local class. Just for your understanding purpose, I named it local. It can be anything. Now let's assume that it implements the greet interface. Greet. and say hello. Now this local class can access the members of that block as well, provided that they are final or assumed to be final. Now here I will say hello and name. So this is absolutely valid. In the older versions of Java, this is supposed to be declared as final. Starting from JDK 1.8, it need not be, provided that this name is not modified elsewhere. Say for example, if I say name equal to XYZ, then you cannot access this variable here because it is not final anymore. So this got modified. So if it is not modified, this variable is assumed to be final and we can access it within the local classes. Now otherwise it is a safer practice for you to declare it as final. And again, local class gives you extra flexibility to write your own class, implement your own interface and supply the functionality which can be used within that block. Now in order to use it, we need to create an object for this class and object dot say hello. Now let's run and check. I can see hello ABC. So this is called as a local class. Now there is one more variant of inner class. Let's say that I'm going to create a variable for greet. Now can I say new greet? Is it valid? No, because greet is an interface and we cannot create object for this interface. That's correct. Now what happens when I start a block? Now this is what we call an anonymous class. It is an anonymous implementation of greet. Now if I define say hello and I do the same thing, from anonymous. Now here what we just did is we created an implementation class which is anonymous because we did not name that class, just like this one is class local. So here the name of this class is local, but here the class which got created is not given any name and hence the name anonymous. And we implemented that interface greet, that is a greet interface, and if this is the class name, this could be considered as a derived class. This is the interface name, then it is an implementation. Now define whatever the methods that are supposed to be implemented and then we can continue with the usage. This is actually very useful and you will see the real usage of it in the coming lectures. So let's run and check the outcome. I can see hello ABC from anonymous. According to me, this is the most important one and this is called as an anonymous local class. Now let us understand what is lambda expression, but before that I will get started with a very simple example. And again, as you have seen that previously, I will create a simple interface greet and with method say hello. But here this time I will just take the name. This is pretty simple. Now think about the different ways that you can implement the greet. I will say class my greet implements greet and override the method say hello with string name. Just print hello name from my greet. Now I'll just create a variable g1, and the implementation object is of type migrate. That is absolutely fine. Expected this interface, and we have given the implementation. Say g1 dot say hello abc. So this is approach 1, which should be pretty straightforward. Now let's run and check the outcome. Hello abc from migrate. Fine. What other approaches are available? I will say G2. Instead of creating a separate class like this, I can say a new greet and create an anonymous implementation of greet. So here we are creating an object of an anonymous class, which is an implementation of this interface greet, and instantaneously just define the say hello method, say hello from anonymous. This is another way of providing the implementation, say hello abc. So this is approach 1 and this is approach 2. Now let's run and check the outcome. We can say this. That's fine. So anonymous implementations are used whenever you want to instantaneously modify the existing behavior of a class and then give it on the spot. Then there is one other simpler approach called lambda. So first approach is a separate class. Here we took anonymous approach, and 3, we don't need to write all these things. With lambda it is made much easier. Now what we can say, take parenthesis, the first argument is name, whatever the variable name you want to give, and we are giving the definition, and the definition is hello name from lambda. And then g3 dot say hello abc. That's all. So what is all this? So if you look at this one, there is a lot of syntax in and around. Lambda is normally not applicable for all cases where anonymous is applied, but it is actually supported for functional interfaces. What are functional interfaces? We will talk about them later. So what is a functional interface? An interface with only one method. So one abstract method. So that is called as a functional interface. So here we are providing a definition for the say hello method itself. The parameter name is taken as the parameter here, and this arrow operator, this represents that this is the definition, and we can actually even start a block and we can write it within that block as well. But if you want, if it is a multi-line statement, we can take this approach. If it is a single line statement, we can simply remove this, it is not required. Now here for the given name, this is the definition to be executed. So here hello name from lambda. Now let us run and check the outcome. Now here this is approach 3. You will see this through a different example as well in the coming lecture. You can see hello abc from lambda. So initially we created a separate class, this is approach 1, and instead of creating a separate class, we can also provide an instantaneous definition using anonymous local classes. Now this way you can also provide a definition for the interface. And the third approach is the lambda, which is applicable for functional interfaces. So that is nothing but the interface with one single abstract method, and this is nothing but the definition for that abstract method. So this part is nothing but the function arguments and followed by the function body. So where you will actually define what is that need to be done. This is nothing but the lambda expression, and the rest of the things remain the same. You will see that in much more detail in the coming example. So let us see one more very simple example for lambda. I will say I'll create an interface called myMath with one single method, and I'll call it add of integer a and integer b. That's all. Now when you declare a variable myMath, it is expecting an object of type myMath. But this could be called as a functional interface. And functional interface just ensures that it has only one single abstract method. If this interface is having more than one abstract method, then that is not a functional interface. And only for functional interfaces, the lambda can be applied. So here I will say parenthesis, so which is the definition for this add method, and the first argument is a, the second argument is b. So you can name according to your requirement. It need not be just a and b. I can say x and y, and the actual definition is x plus y. That's all. So this is the lambda expression. So x and y are nothing but the two parameters here, which are of type integer because this could be inferred, and the result is x plus y. There is no need for return statement. Return statement is implied. Now when I say result equal to m dot add of 100 and 200. Now you can see that the add method which is invoked here is nothing but the lambda. Now let us print the result. So writing the lambda expressions is quite easy. You just need to ensure that you are writing the lambda for functional interface with only one abstract method. And the definition you are providing here is nothing but the definition for the abstract method. And the arguments are nothing but the arguments passed to this function. So, and then followed by the function body, which can return the value or which need not. It depends on the return type. So if this is an expression which is expecting a return value, there is no need to give the return statement here. So let us now take a look at how lambda simplifies the programming. So here I have a list which I named it as seed, and I created an object for array list and I added 3 elements to it. So nothing complicated here. Now I'll create another list, list 1, which is an array list of integer, and I will copy all the values from seed. So add all of seed. This is a set operation which copies all the values from this collection to this one. That is fine. Now I want to sort the list. So this doesn't come with the direct sort logic. There is an utility called collections. Collections.sort. It gives the list and it will arrange the elements for us. So this step is going to sort the elements in the list. So in which order? So because the objects are of type integer, so we need not worry about providing a comparator. Otherwise we normally need to provide a comparator. So This sorts the elements in the ascending order, which is the natural order of the given integers. Now when I print list 1, I will just print list 1, and you will see that the elements will be arranged in natural order, that is the ascending order. Now this is fine. Now what if I want to arrange them in descending order? I will take a copy of it. I create list 2. So let us change it to list 2. Now in the list 2, I just copied the seed data. Because collections.sort is going to modify the collection, I don't want to modify the seed data. So I took a separate copy of seed data and I started adding all those values to the collection. Now list2 dot add all of seed. So I copied the seed data. Now collections.sort list2, and the value of the list2 is this one. Now I want to sort these elements in descending order, and for that I need to provide the comparator. So let us say class my comparator implements comparator of type integer, because individual elements are of type integer. Now let us provide the implementation. And for the given two integer values, we need to return a negative result if first value is less than second, and we need to return positive result if first value is greater than second and equal to 0 if both are equal. And for that I will say O2 minus O1. So this gives me the descending order of elements. Now I just need to use this comparator while sorting. So collections.sort list2 and use the comparator my comparator. Now this particular sort logic now uses my comparator to compare the elements, and this is going to give me the descending order of the elements. Now let's run and check. Now you can see the list 2 came with the descending order of the elements. This is fine. So instead of creating a separate class, we can also use the anonymous implementation of the comparator. So let us do that as the third approach. I call it list 3 and I copy the seed data and then I display. So instead of using a separate class, I can say new comparator of type integer, and here we can simply start a block. Now this is the anonymous implementation of comparator. So the interface, and then we started a block. This is nothing but a class, and because we did not name, it is called as anonymous class. Now here we just need to define the compare to method. Rest of the logic remains the same, O2 minus O1. Now if you carefully look at it, I will just remove this from here to avoid the confusion. I am expecting a comparator where element type is integer. I will say C1, and this is the anonymous implementation, and now its reference is there in C1. I want to use the C1 for comparison. Anonymous. This is fine. Now let us see the outcome. So it did not sort. O2 minus O2, we did it wrong. O2 minus O1. Now you can see the elements are sorted in descending order. Now if you look at it, you can really feel the complexity of adding these signatures and then opening the block, closing the block and so on. Why don't we do it through Lambda? I will show you with the fourth approach, that is Lambda. I will take the fourth list, add the seed data, and for comparison logic we can say O1 comma O2. These are the two parameters for the comparator method, and the result is O2 minus O1. That's all. This is nothing but this is the implementation for this method. O1 and O2 are the two parameters, and the result is O2 minus O1. That's all. Now let us print list 4. Now check the outcome. You can see this is the power of lambda. If I say O1 minus O2, you normally get the ascending order. Now let us print. You can see that you got that in the ascending order. Now if you look at the lambda, if you look at the anonymous implementation, you can clearly now see the difference between the lambda and the anonymous implementation. And that is the overhead which the language is trying to reduce. And this makes the things much easier. Now if you understand this, you are almost there as far as lambda is concerned. In this lecture, we will see how to use method references inside lambda. Sometimes lambda expressions simply make a call to the method, and in those cases can be replaced with method references. Let us see that with an example. Here I have an array and I want to sort the elements of this array, and for that we can use arrays.sort. Let's say arr1, and let us see the outcome of this as well. arr1 and arrays.toString of arr1. Now because this is a simple plain array, we are using the arrays utility, and also if we print this arr1 directly, so it prints a reference to the array reference object. So we need to use the arrays.toString to stringify the entire array and display it. Now this is fine. Now let us run and check the outcome. Now you can see that this is a case sensitive sort. Capital letters comes first and small letters come later, and this is because the ASCII code of capital A is 65 and the ASCII code of small a is 97. So and that is how it is ordered. So now if I want to use a non-case sensitive sort, I can supply the comparator here. So that is new comparator of string, and inside the compare to method we can use O1 dot compare to ignore case of O2. Now this way we can actually do a non-case sensitive comparison. Now let us see how it works. Now you can see capital ABC and small abc are treated equally. Now this is good. Now instead of writing the entire anonymous class, we can simply replace this with a lambda expression. So the given O1 comma O2, the result is O1 dot compare to ignore case of O2. So this array is sorted according to this comparison logic, and comparison logic simply makes a call to the compare to ignore case method. So first object dot compare to ignore case of second object. Now this helps us arrange the elements in a non-case sensitive order. Now this is good. Now here the lambda expression is simply making a call to compare to ignore case. So there is nothing much in it. Now this can be replaced with a simple method reference, and let us see how it is. I will create a simple array 2, and instead of this entire stuff we can simply say string colon colon compare to ignore case. That's it. And this is called as a method reference. We are simply replacing the entire lambda with a simple method reference because the lambda is doing nothing more than making a call to this method. Now the class name and the method name. Now let us see how this works. I can see that the functionality is same. Internally it is translated into this call. So method references simplify the lambdas further. With a simple method reference we can even replace the lambda, provided the lambda just makes a call to the method. Before starting this lecture, I suggest you to continue even if you don't understand the topic clearly. Once you go through the examples, this becomes easy. And according to me, this topic is easier than what you learned till now in this course. JDBC stands for Java Database Connectivity, and JDBC API enables us to interact with the database, mostly the relational database. You can consider JDBC as an interface, but the actual implementation is vendor specific. As you know that there are different SQL products in the market. If you wanted to interact with Oracle, you need to use Oracle specific jar file. Similarly, if you want to interact with MySQL, then you need to use MySQL specific driver. You need to download and use the right jar file based on the product you are interacting with, and need to add that to the class path so that you can use the components of it. For those who are confused about what is jar, its a full form is Java Archive. It is a kind of a zip file, that is a compressed file that contains several Java components. This zip file could be added to the class path so that you can start using the components of that file within your application. Think about JDBC interaction as a 4-step process. First, you need to register the driver with the driver manager. Driver will take care of establishing the connection and other things. Once you register the driver, you can establish the connection by specifying where the database is running and what is the username and password. Once you establish the connection, you can start sending the commands using the statement object. And then the command is executed in the database and you will obtain the results. This is a general interaction summary. You will see that in detail in the coming example. Before getting started with the example, you need to set up the database first. Here I am using MySQL database and it is installed in my local machine. You should be able to install it as well. Should be straightforward. But anyway, if you are not familiar with MySQL, please follow the installation guide under the resources section. MySQL Workbench is the client interface for MySQL DB, which you can use to execute the SQL commands. And this is the sample script to set up a local schema and associate it with user. This command will create the schema named DemoDB, and this command will create a user named DemoUser with password DemoPWD. User creation is not enough to interact with the database. You should grant required privileges for the user in order to access the database. This command will grant all the required privileges on DemoDB to the demo user. And here is the sample table account with fields ID, name and balance, and along with 3 sample records. Let's execute the query and check the data. You can see there are few records here. I did the setup in my local. You can also do this in your machine. Let us now start with an example. Now in this case, I placed the jar file which is required for connecting with MySQL database under the lib folder. And also you will find the database initial setup script in the script folder. This is the same script that you need to use to set up the database schema. And now let us begin with the example. And before getting started with the example, you need to add this jar file to the build path. And for that, open the project properties. And you need to add a jar file here. And this is the jar file can be found under lib folder. You just add it to the build path so that we can start using the libraries from within that jar. New class file. Let us say the name of the class is main and also select the main method. Now it creates a class file. In the previous lecture, you have seen that JDBC interaction is a 4-step process. The first step would be to register the driver. So before that, I don't want to handle any exceptions in this example, so I will say throws exception so that all the exceptions are handled automatically. Now the first step in the JDBC is to register the driver, and for that we can use class.forName. And here the driver class is com.mysql.some cj.jdbc.driver. In reality, class.forName actually loads this class into memory. And when you load a class, its corresponding static initializer gets executed. Now, if you look at this code here, let us declare a variable and go to the source code. If you look at this source code, you can see that there is a static initializer, and inside the static initializer, you see that there is a driver manager and there is a method called register driver. So this gets invoked automatically when this class is loaded into memory. And class.forName loads this class to memory, and if it is not already present. In that case, if it is newly loaded, then the corresponding static initializer gets executed and it will register the driver. Overall, you don't need to remember all those things. Just think that we are registering the driver here. And once you register the driver, you can establish the connection using the driver manager.get connection. Let us see that. Now, connection cyn equal to driver manager.get connection. And here you need to give the URL. So the URL that enables us to access the database. And the URL is something like this. JDBC is your protocol. MySQL is the internal protocol that you are using. And with JDBC and MySQL, it will pick this driver. And where it is running. So for that, you need to give localhost. This is my local machine. And the port number 3306. This is the default port number for MySQL. And then it is followed by the schema name, and the schema which we have given is DemoDB. And after this URL, we need to give the username and password for connecting to the database. And the username is demo user and password is demo pwd. Now we need to import this class, and once done, once this line is executed, you will acquire a connection to the database. Now to recap, this is your main protocol, this is your sub protocol, and followed by the URL. And this URL states that the MySQL instance is running in my local under the port 3306. and this is the name of the schema and followed by username and password. Now once you connect it to the database, now we can execute the commands using the statement object, and this is how it can be done. Statement, create an object using the connection dot create statement, and then using the statement you can execute the query as well. So result set rs equal to statement dot execute query, select all columns from account. The statement is a query, we can use the execute query method within the statement object, and the execute query returns the result set. Result set is nothing but the set of all records. It's a kind of a cursor which allows us to access the records obtained. Now, how to access the contents of the result set? It is pretty straightforward. You can think that it is a kind of iterator. Now, while rs.next, as long as there is next record. Initially, result set first points to the beginning of file. So the first call to next will take you to the first record. And again, when you come back, again the next operation call will take you to the second record and the third record till the end of the file. And once it is end of the file, it returns false, while false means that is the end of the loop. Now, first time when you execute the next, it now points to the first record. Now you can use the get methods within the result set to access the data. And let us say that I want to get the account number, rs dot get int of 1. The column index begins with 1. First column is account number, and if you want to recollect that, let's see that the first column is the ID or the account number, second column is the name, third column is balance. Now here I will say ID, and the second column is the name, and it is a string, so rs dot get string of second column. Now the third column is balance, which is a double field, rs dot get double of 3. So we do have the get methods to access the data. Column number begins with 1, so you can access the corresponding column using the column number. And when you go back, rs.next will take you to the second record, and now these values represent the second record specific columns. Here I will just print them, printf number, and here it's a %d, call it id, followed by name, which is %s, followed by balance, which is %f, and id, common name and balance. And once that is done, we can close the connection using connection.close. So here is a simple example. Let us execute and see the results. Now all the records are printed in the same row, so I will apply the new line using %n. Now let's run that. I can see that we got 3 records. Instead of manually creating a Java project and keeping the jar inside the class path and other things, we can also choose or create a different kind of project, that is a Maven project, so that we can directly place the dependency within the application. For that, let us create a new project of kind Maven project, and for the archetype select the quick start one here. For a Maven project, you need to select the group ID and the artifact ID. The group ID, think about it as something like you want to keep this project under this group, and similarly the artifact ID is the actual ID given to the project. Now you want to put all your Java modules or Java projects under some Java group, or you want to put some SQL projects under SQL group or something like that. Similarly, you can choose whatever the group ID that you want. Now here I would say com.TekCreek.java. So this is my group ID. And then the artifact ID is JDBC example 2. And then for the package name, it's a good practice to choose the package name. I will choose com.TekCreek.java.jdbc.sample. And let us create the project. And if you look at the project structure, the main component for a Maven project is pom.xml. And this is the file where you will specify all the dependencies for that project. Now group ID is the one which you have given, artifact ID is the ID for this project, and version, it can be anything as per your requirement. And when you are looking to distribute this module, you will be distributing it as a jar file. And these are the dependencies. Here by default you got the JUnit dependency. Now here we need to add the MySQL jar dependency. And for that, you can actually go to the browser window and search for MySQL connector Java Maven, and you will find the list of all search results. And in the search results, you just look at Maven repository, something like this, and go inside the repository. You can choose different, there are different versions of the dependencies here. You can choose the right dependency as per your need. Here I am choosing 8013, and this is the dependency snippet that you need to bring in and paste it in your project. Now let us go back to our project and add that as a dependency. That's it. Now we have the MySQL connector Java dependency. So you can start using the driver and you can start interacting with the database. Now you don't need to manually download and bring that into the class path. And from the example perspective, because we created Maven project using a wizard, it automatically created a project structure for us along with the class file. Now let us write the JDBC code here. I'll bring the code from the previous example. This is the same example, and let us not handle the exceptions here. Throws exception. We will come back to the exception handling later. Now let's execute this program and see if we are getting the right results or not. And here we got the data, but while closing the connection we received an exception, and this is something like it might come when we are using the connection over a non-SSL connection. And this might be something, this is the exception that you are getting most recently with the latest versions of MySQL. And to avoid this, you can say question mark use SSL equal to false. That's all. Now let's run this program again. I can see that we got the results. And this is how we can actually set up a Maven project with the dependency, and then we can start using that project using the jar file directly, instead of manually downloading the jar and keeping that in the class path. In this example, we will see what are the different execute methods available. But before that, to help you understand Maven, I will recreate the project one more time. First thing is new, and the type of project is a Maven project. And the category, you can select quick start as the archetype. And first thing is you need to select the group ID and then the artifact ID. So we need to give a different project artifact, let's say JDBC example 3. And for the package name, you can say com.tekcreek.java.jdbc.sample. Now it creates a project structure, Maven project structure for us. Open the pom.xml. So here you can see what are the dependencies available for the project, and we need to add the MySQL dependency, so which you can bring it from here and paste it here. Done. Now we got the MySQL connector jar file, which is a kind of a driver and JDBC implementation. Now we can start using that inside our project. And inside the app, let me replace that with the previous examples app. That's it. So here, as part of the first step, we registered the driver, and then we established the connection using the driver manager. And the main and for that, for establishing the connection, we need to specify the main protocol, sub protocol, and this will vary with database. So if you are connecting with Oracle, you might choose Oracle here, and if you are connecting with SQL Server, you might use something else here. So this URL will change, and also the driver class name will change. You just need to update that according to your database. And then followed by where the instance is running, under which port, and the schema name, and followed by username and password. Now once we establish the connection, we can execute the commands using the statement object. Now within the statement object, if you don't know what sort of command it is, you can actually use the execute command. Execute and followed by any SQL command. Now here I will say insert into account values of id, that is let us say 4, and then followed by some name, some d, and the balance field, let me say some 5000. Now here we are executing the command, and this is the insert command, which should be a valid command in the database. And then when you are looking to update any database record, you can use the execute update. Execute update. Execute update returns the number of records affected by the command. Now here, when you are trying to update, or when, let us say that when you are using delete from account and you want to know how many records deleted, the return value will be an integer representing the number of records affected by this command. Or if you are looking an update account, set balance equal to balance plus some 100 or 1000. Let us say 100 to make it easy. Now the return value will be an integer indicating that the number of records affected by this command. Now this is execute update, and execute will be used to execute any command, any SQL command. Now it returns a boolean value, and it returns true if this command is a query, so that you can fetch the result set and later process it, and returns false for other commands. And when you are looking to execute a query, you normally go for execute query. Select all columns from account. Now there are 3 types of execute commands here. Execute for any SQL command, execute update for executing the DML commands such as update, delete, where you want to know the number of records affected. So the insert, update and delete commands will result in the number of records affected by that command, and execute query to fetch the result set. And the result set will have a beginning of file followed by the records obtained as a result of this query, and then the end of file. So initially result set points to beginning of file. To get the first record value, you need to call the next at least once so that we can point to the first record. And then you can fetch the record field values using the field names or field column numbers. Now the column number begins with 1. id equal to rs dot getInt of id. Now here I am using the column name and then string name equal to rs dot get string of name and double balance equal to rs dot get double of balance. Now and then we can print this system.out.printf id percentage d name percentage yes comma balance percentage f. Let's give id name balance. Now this operation you want to do for each record. In that case we can put this inside the while loop while rs dot next. When we say while rs dot next, as long as there is a record, it fetches the field values of that record and we are printing that. And this is a slight enhancement to what you learned in the previous example. Now here we have seen what are the different execute methods: execute, execute update, and execute query. Execute for executing any command, any SQL command. Execute update for DML commands, and you need to note that it also returns the number of records affected by the command, and execute query to execute a query. Now here let's print number of records affected. Let us print that value. Now let's run this and see. So the number of records affected are 4 because there are 4 records after the insertion. Now if you want to execute it one more time, let us say it is 5, and then while printing, let us print that into new line percentage yeah. Now let's run this one more time. So the number of records affected are 5 now because this update command doesn't have any where clause, and you can see that these values are 1100, 1200 because you incremented it twice, and for the last record you incremented it once. Now let us see how to write some parameterized queries, and we will also see what is a prepared statement in this example. Now here let us remove all those things. Now in this example I will accept some ID from user through the command line input, and once based on whatever they enter, so I would like to retrieve that information from the DB and display it. And for that I would say first I will prompt for ID, enter ID, and for reading the data I will take scanner for now. Scanner object, when we connect the scanner to system.in, it allows us to read the data from console. And then int id equal to scan.nextInt. So I am waiting for data, and once they enter the ID, we will use this ID to query the DB and fetch the data. And for that the command would be select all columns from account where ID equal to, and here we should pass the actual ID, so the entered ID. and we will need to run this command and then fetch the results, and for that we need a statement object. Statement st empty equal to connection dot create statement, and using the statement we can now execute the command to fetch the result set. Result set rs equal to statement object dot execute query and the command. And here the command is select all columns from account where id equal to the given id. And how can I know that if there is a record or not? So there is a simple option, if rs dot next. If you got the record, then it will certainly point to the first record. If not, then we can say that no record found with id and this id. If there is a record, then we can use it to print it. id rs dot get int of 1 first column, because I know that the first column is id and the second column is name. Rs dot get string of 2 second column and balance. Rs dot get double of 3. Now if there is no record, then it comes here and prints that there is no record found. If there is a record, then it will print the record. So this is how we can actually send a parameterizer statements to the database. Now let's run and see what is the result. It prompted for id. Let us give 1. You can see that we got the record. Run one more time. And for id, let's give 10, which is not present. You can see that there is no record found with id 10. Problem with this approach is that it is prone to SQL injection attacks. See, something like when you ask for enter id, I may enter 10 and then followed by some space and then insert into or something like this. But this is not possible from the command line, because anyway we are asking for only the next integer. Just think that there is a username and password dialog box in a window, and user is typing the username and password, and alongside the username they might also insert some command. And when you query the database, like select all columns from user where username equal to the given username and password equal to the given password, something like this. Select all columns from user where username equal to the given username. You might actually append some username here, user field value here, plus password equal to the given password here. But the problem is here they might enter some insert commands, and they might enter they might sneak into the database and violate this. Somehow they violate this command and they can enter into the database or without even logging in. So those kind of attacks are called SQL injection attacks. And to avoid such kind of scenarios, we need to use prepared statement. We should not construct the command like this. Instead, what we should do is we should actually name it as a parameter. And to make it easy for you, I would say I would remove this command, connection dot prepare statement, and this is called as prepared statement. And prepared statement allows you to place parameters inside the command, and these parameters must be given the value using the set methods, and after that you can execute this command and fetch the results. Here I can say this is the first parameter, statement dot set int, first parameter, the value is id. Now if you look at this combination, we are creating a prepared statement object. Select all columns from account where id equal to question mark. Here the question mark is what we call the parameter, and this parameter will be set with the value using the set methods. And once we set the parameter value, then you can use the statement dot execute query and you will get the result set. And based on the result set, the rest of the operations will remain the same. Now this is not prone to SQL injection attacks, and this is the ideal statement for parameterized statements. Now let's execute and see what is the result. And you can see that when I say 1, you can see we got the results. Rest of the things will remain the same, just that all the parameters will be given the value after creating the statement. And that is the advantage of going with prepared statements. So now, up to now, we have seen two kinds of statements. One is a simple statement and then the prepared statement. And prepared statement is the one which allows us to give parameters. In this example, we will take a look at how to manually control a transaction. And also we will take a look at one more example for prepared statement. Now before that, we should understand what is a transaction. A transaction could be considered as a sequence of operations which should be carried over as a unit. That means either the entire operation should be successful or the entire operation should be cancelled. Now it is better understood through a simple example. Let's consider a scenario where we want to transfer some amount from account 1 to account 2. Now if you take this example, we will actually perform two operations here. One is debit from account 1 and then credit to account 2. Now if you want to treat this transaction as successful, both operations should be successful. If any of the operation fails, we should cancel the entire transaction. We will see how this can be achieved through JDBC. Now here we have account 1 with balance 1200 and account 2 with balance 2200. Now let's begin with the example. For that, first let's create a new project, which is a Maven project again. JDBC example 5 and sample for the package. Now I will copy the code from the previous example. Now we have seen what is a prepared statement. Now again we will see that through another example now. Now here we will ask for three values. One is the source account ID. Enter the source account ID. You can consider this as source ID. And then let me remove this here and paste it. And then enter the destination account ID. Consider this as destination account ID. And then the amount to transfer. Now the amount is a double value. And for that we need to take next double. Now we read three values. One is the source account ID, the other is the destination account ID, and the amount. Now we need to transfer the amount from source account ID to destination account ID. And for that we need a prepared statement. Prepared statement PS equal to connection dot prepare statement. Update account, the operation is update account, set balance equal to balance minus question mark, where ID equal to question mark. So let's take a look at the command here. Update account, set balance equal to question mark, where ID equal to question mark. So here we have two parameters. First one is the amount and the second one is the ID. And now let us transfer the amount. PS dot set double. So the first parameter is the amount. Let us set it to the amount value, and then PS dot set int second parameter, which is the ID, set the source ID. And this operation, if you execute this operation, it will deduct the balance from the source ID. Now PS dot execute update. Here we updated the record, so we debited the amount from the source account. Now we need to do the other operation, which is credit. Now PS dot set double, first parameter. Now this time I will give negative amount. I'm just using it as a trick, otherwise we can take another statement and we can do the plus operation here, but this is a simple one. We are giving the negative amount so that negative of negative, which becomes positive. And then PS dot set int second parameter with the destination ID. Execute update. So here we are performing the debit operation, and here we are performing the credit operation. And technically speaking, both should be successful for the transaction to be successful. But still we did not handle the transaction here. So by default each operation will be auto committed. So let us execute and see what is the outcome. So the driver class is not available, and this is because we did not add the dependency here. Let us bring that dependency from the previous example. Now we have the dependency. Let us now execute and see. So enter the source account ID. Account ID is 1, and enter the destination account ID, that is 2, and enter the amount to transfer. Let us say something like 200. So the operation is performed. Now let us see what is the content of the table. Now previously we see that for account ID 1 the balance is 1200, and for 2 the balance is 2200. Let's run the query one more time. I can see that the account ID 1 balance is now 1000 and account ID 2 balance is 2400. Now this is good. Let's go back. I'll run this program one more time. And now the source account ID is 1 and the destination account ID I will give this as 10, which is a non-existing account. In this case, you should cancel the update operation, but because we did not handle this as a transaction, it is auto committed. Now in this case, the debit operation is successful. From account 1 we debited 200, but there is no account 10. Now because there is no account 10, the update operation did not update any record, but we did not handle that. Now let us see what is the content in the DB. The previous balance is 1000. I can see that the balance now changed to 800. But where is the credit operation? The account ID 10 doesn't exist. Now we need to handle this kind of scenarios. So that entire transaction should be either successful or fail. Now that means if the number of records updated by the first command and the number of records updated by the second command, both should be equal to 1. Only in that case we can commit the transaction. Otherwise, we should roll back this transaction. Now this means that we want to commit the transaction only when both the update operations are successful. Otherwise, we should roll back. Now by default, the basic default transaction management mechanism is it is auto committed. So each update operation will be auto committed. So for that, in order to manually handle that, we should say connection dot set auto commit false. So we should not auto commit the operation. Now because we left the connection uncommitted, before closing the connection, we should manually either commit or roll back. So the first thing is we should say that auto commit false, and then now you know that when both the updates are successful, now we can commit this. So we can say connection dot commit. Now if any of the operation fails, we should say connection dot rollback. Now let us run and execute this program and see what is the outcome. Java application again. But before entering this, let us check the balance. Now the current balance for account 1 is 800. Now the source account ID is 1. Destination account ID is 10. Now amount is 200. If the operation is committed, account 1 should now have the balance 600. But let's see what is the outcome. Let us check the account. You can see that the account 1 balance is not changed because the update operation is rolled back. Now let us go with the successful scenario. Source account 1, destination account is 2, amount 200. Now let's check what is the balance. You can see that the account 1 balance is now 600. Account 2 balance is now 2600. So to manually control the transaction, we should initially set the auto commit to false, and before closing the connection or when the operation is completed successfully, we should commit the transaction. Otherwise, we can roll back the transaction. In this lecture, we are going to understand about callable statement. Callable statements allows us to interact with stored procedures. So for demonstration purpose, I created 2 stored procedures here. They are pretty simple. First one is my insert proc, which actually takes 3 parameters. And here when we say in, which is an input parameter, so that is an incoming one. So this will only take the value. There are actually 3 types of parameters in stored procedures. In parameters will take input, out parameters will return back the output, and in-out parameter, which both act as input and output parameters. In this case, there are 3 parameters here. One is account ID, account holder name, and balance. And once you call this procedure with these 3 values, it will simply insert that into the account table. This is a simple one. And there is another procedure called getVal, which actually takes the account ID as input and returns the account balance, which is an output parameter. So here I used the query select balance into account balance. So the value balance is now copied to account balance from the account table where the ID matches with the given account ID. Now let us see how we can make the calls to those procedures. And for making the stored procedure call, we need to use callable statement. CS1 equal to connection dot prepare call. And to make a call, we first need to open the braces. So this will actually mark as the beginning and closing braces will mark as the end, and in between call and followed by the actual procedure name. And the name of the procedure is my insert proc. So take my insert proc, and it requires 3 parameters. So first question mark, and question mark. So callable statement is an extension for prepared statement, and hence it also supports parameters. And cs1 dot set integer, first parameter is integer, let us set that as 99. cs1 dot set string, second parameter, that is the name, let's say demo abc. cs1 dot set double, that is the third parameter, let us give something like 9999. Now cs1 dot execute. That's it. The application is done. Let me go and query the table again. You can see that we inserted the record with ID 99 and with the name ABC and the balance. And this is first one kind of procedure which actually accepts only the input parameters. Now, how to make a call to a procedure which also returns some value? And for this, let me take the statement 2, and here we need to make a call to the second procedure, that is get balance. And in the get balance, you can see that one is the input parameter and the other is the output parameter. So get balance and with 2 parameters, one for input and another for output. Second statement. Now the first parameter is the account ID. Let us set the account ID, let's say 2. Now the first parameter value is 2, but we cannot supply the value for second parameter. Actually this is an output parameter, so we will receive the value instead, but without setting the parameter value you cannot execute the statement. And for that we need to register this particular parameter as output parameter. So cs2 dot register output parameter 2, and the type is types dot double or numeric. This indicates that the second parameter is an output parameter, so that it doesn't wait for the value for this particular parameter. Once you execute, now you might have obtained the result in the, for this parameter. You can extract the result using balance equal to cs2 dot get double of second parameter. That's it. Access it using the parameter index itself. Now let's print obtain balance and the balance. I'll comment out the first one. Now let's run this procedure. You can see that the obtained balance is 2600. Let me cross verify. Yes. So Up to now, we have seen three kinds of statements. One is a statement, and the other is the prepared statement and the callable statement. Callable statement allows us to make the calls to the stored procedures. Prepared statement allows us to send the parameterized commands, and statement for everything. Let us understand how to use data source and connection pooling mechanism. Before that, you need to understand the difference between connection per request and connection pool. Think about a scenario where hundreds of requests coming to the server, and if you open a connection per request, you might end up opening too many connections. And it also impacts the performance of your application, because opening a connection is a costly operation in terms of performance. Instead, you can create a connection pool so that you can acquire a connection from the pool when needed and return it back to the pool once done. This way, you can share the connections and also limit the number of connections for the application. And you can configure it in a way that you can pre-open the connections as per necessity. And also, you can increase the connection count when needed and release the connection when not required. And these are the things which could be pre-configured as well. So connection pooling gives you more benefits. So let us see how we can use it in our application. Now let us get started with the example. As usual, let's create a Maven project. And here I will give JDBC example 7. Sample. And first thing is we need the MySQL driver dependency. Let us bring that from this project. We need one more dependency here, that is Apache Commons DBCP. This gives us the basic data source implementation, which we can use in our application. So let us copy this dependency from here. Now let us copy the example from the first application. In this example, we are opening the connection directly. Instead, we need to obtain that from the pool, that is the connection pool. And for that, we need to just slightly change this code. Instead of manually registering the driver and establishing the connection, we can create something called as basic data source. Data source is the object which is responsible for giving you the connection and maintaining the connection pool internally. Now, basic data source and pooled data source are the two different implementations that you get from Apache Commons DBCP. So you can use whatever the data source that you want, but here from the example perspective, let us use basic data source. And once done, we can configure this data source, that is the what as explained earlier. We can set the total number of connections, we can set the minimum number of idle connections, etc. Now for that to work, data source set driver class name. This is as usual the one which we used earlier, com mysql cj jdbc driver, and data source dot set url. Again, this is the same JDBC main protocols, MySQL subprotocol, MySQL instance running in my local host under port 3306, schema name demodb, use SSL is false. Then data source set username demo user, data source dot set password demo pwd. And for this data source, you can set the maximum number of connections that you want to open. Set max total. We are saying maximum 10 connections. Although this is a console application, we don't need the data source. But the intent of the application is to explain you how you can configure the data source and acquire the connection from it. Now, data source dot set maximum ideal connections. Set max ideal sets the maximum number of connections that can remain idle in the pool. And similarly, we can also set the validation query. Select one to check whether the connection is valid or not. And there are so many other configuration parameters which we can use in production. But for now, just think that this is a simple configuration. We are setting that the maximum total connections should not exceed 10 and maximum ideal connections in the pool should be 2. So what data source does is, depends on the load, it actually increases the number of connections till a maximum limit of 10. And if the connection is idle, it will release the connections as and when they are not required. Now, instead of manually creating the connection, we can now obtain the connection from the data source because we configured the data source. Now, connection con equal to data source dot get connection. Now, this returns a connection from the pool, and once you close the connection, it is not the direct close operation. This particular close operation returns the connection back to the pool. Now, inside your application, we should obtain the connection like this, so that we can obtain the connection from the pool. Now, the rest of the things will remain the same. So, we are creating a statement, we are executing a query and printing the results. Now, let us execute and see if it is working or not. You can see that we got the records. This example is very important for you to understand. You will come to know the significance of this example by the end of this lecture. But for the example's sake, I am dropping the existing table here. I am recreating the new table with the same name, that is account. The only difference between the previous table structure and this one is we selected the ID column for auto increment. The column, when it is selected for auto increment, its value will be incremented automatically. So, if you look at the following insert statements, we are not supplying the value for ID column. We are only giving the values for name and balance columns. So, the ID column value will be auto incremented. Now, let us see that. I'm dropping the existing table. I'm recreating the new table with auto increment. Now, let us insert these two records. Now, let's query the table and see what are the records available. Now, you can see that the ID column value is auto incremented. That's fine. Now, let's get started with the example. Let's create a new Maven project. And the artifact ID JDBC example 9. And the package name, let us select the sample here. It's fine. Now, we will copy the dependency from the previous example. As usual, MySQL connector. And also, let's copy the app from the older examples. So now let's run this and check the results. I'm running the application. You can see we got the records. Now this is fine. Now I'm going to transform this example. Carefully observe what I'm doing here. I'm going to create a new class and the name of the class is, I will call it account, and for the package I will select this as model or domain. Now in this class I will create the fields which match the record structure. So that is, if you look at the records, you have ID column, name and balance column. Now let us create the same type of fields here. ID, name and balance. And it's always a good practice to declare them as private and generate the getters and setters for these columns. So I will select the getters and setters for all the fields. I can see that we got the methods like get ID, set ID, get name, set name, get balance, set balance, etc. Now this is good. This is normally called as a POJO, which stands for plain old Java object, or this is also called as a domain object, because the main purpose of the domain object is to hold a record. So we call it as a domain object as well. Now I am going to create a new class, and again I will call it as account repository. Package, let us select this as repository. And here I will write the find methods, something like this, find by ID, and let's say return null for now. We will actually complete it. To do and save. So let us import the class. We imported the account class from the domain package. Now account repository gives us the methods which enable us to query the account table and fetch the results according to the necessity. Now here we have two methods, one is find by ID and the other is save. So we need to define these two. Now let us first start with find by ID. The first step here would be to obtain the connection and then fetch the record, and for that the existing code, so the driver registration, I will put that inside the static initializer of this class. Let us catch the exceptions as well. Let's not worry about the driver registration and connection establishment here. And then to establish the connection, I will write a method called get connection. I will say throws exception. Now these two could be done differently, and we are not trying to understand how that can be written efficiently. We are trying to understand the behavior of how the repository operates. So let's not worry about those two things now. Now here, first obtain the connection, get connection, and then because it throws the exception, we need to handle the exception. That's fine. I'll say throws exception for now. Once we obtain the connection, so we can create the prepared statement, connection dot prepare statement, and the command is select all columns from account where id equal to question mark, and let us run the result ps dot execute query, and next. Once we obtain the results, if rs dot next, if there is a record with this id, then we first need to create an account object, account equal to new account, and then account dot set id, and query the result set and get the integer value for the first column or the id column. I'll say id column, and account dot set name rs dot get string of name column value, account dot set balance rs dot get double of balance column value, and return that account. If there is no record, then it comes here and it returns null. So this I will say try. I'll slightly adjust this code. Connection equal to get connection, and finally if connection is not equal to null, I'll close the connection. So irrespective of exceptions, when the control enters the try block, it comes inside finally and it closes the connection. Now this is good, but if you carefully observe here, we are not returning the result set. Instead, we are mapping the record values to an object, and then we are returning that object. So the ID, name and balance values obtained in the record are mapped to the ID, name and balance fields of the account object, and then we are returning that object. And if there is no record, finally it returns null. Now irrespective of exceptions, control enters the try block, and inside finally we are closing the connection. Similarly, let's work on the save operation as well. The user will give us the account object, and we need to save the information back to the database, and for that the logic would be something like this. Template remains the same. So here, while saving, we may actually insert a record or we might update an existing record, and for that scenario we will say prepared statement. We will create a prepared statement in a different way. If account dot get id is not equal to null, which means that this is an existing account record and we will update the account record. If not the case, we can assume that it is a new record. So here, when account ID is null, I would say just reverse it for easy understanding. If account dot get ID is null, okay, we need to change this to integer because it is not a nullable type. So if account dot get ID is null, that means that the ID is not there. So it is in new record. Now if the account ID is not equal to null, we can consider that as an existing record. In that case, the statements might slightly vary. Connection dot prepare statement, and here because ID is null, we will run the insert command. Insert into account, and values are name and balance. Values question mark, comma question mark. So we are supplying the values for name and balance fields, and the values are given as parameters. Now let us supply the parameters. First parameter, account dot get name. Second parameter, account dot get balance, and ps dot execute update. Now if the ID field is null, then we are running the insert command. If ID field is not null, we will run the update command. Update account, set name equal to question mark, comma balance equal to question mark, where ID equal to question mark. Now the first parameter is name, the second parameter is balance, and the third parameter is ID. Okay, now this should be clear. Now here we are mapping the account object to the record values, whereas in this case the record values are mapped to object. And do you know what this is? This is something like ORM, called as object relational mapping. Now if you understand this carefully, we have an account POJO or account domain object, and there is a table named account, and instead of directly manipulating the account record through the result set, we are mapping the record to the object. So here we will create an object, we will map the record to object, and we will process this object, and finally we will again map the object to record. This is what we call object relational mapping, and the name implies object, relational means table, and mapping. So, and do you know what are the frameworks that operate in this fashion? And that they are Hibernate and today JPA, Java Persistence API, which is also derived from Hibernate. And there are few other prominent object relational mapping tools as well. Through this example, I tried to brief you the internal operation of these frameworks. And the framework actually what it does is, you will define certain find methods, and what it returns is called an entity object or a domain object, and internally it runs the basic SQL commands, and it maps the results to the object, and we will obtain the object or we will process the object, and then we will try to merge back the changes to the table, and this is how we normally do. Once we operate the object, we will again give it back to the entity manager to save the object, and then if the ID is null, then it will try to insert the record, otherwise it will try to update the record. We don't need these things now. Create an object for account repository, and then let's fetch the account object. Let's say account 1 account repository dot find by ID 1. Now this repository returns us the account object. Now we can start modifying the account object. Let's say account 1 dot set balance. Say I will give 99999, and now account repository dot save the account 1. That's it. Let's not worry about the exceptions. Now what is the existing balance of the account? Let us check that through the DB itself, or we can print the current balance. Now let's print and let's execute and see. This is the current existing account record details, ID 1, name A, and balance is 1000. But once we updated the balance and we also saved this info back to the DB, let's go and query the database table. You can see that the balance got updated. In this section, I am going to build an end-to-end application which will help you understand how the components are layered in a typical software project. And through layering the components, you will also establish the interaction between the components, which is very important to understand. Now let us see that through an example. In this example, I am creating a new schema named bookdb. Create schema and followed by schema name. In MySQL terms, both schema and database are almost same. Now when you run this, we created the schema, and this command create user creates a separate user. Now create user followed by username and identified by and the password. Let's create the user. We created the user and we need to grant the required privileges to the user. So grant all privileges on bookdb dot star. So all objects that belong to bookdb. So we are granting access to this user. So we granted the access, and then let us select the schema, that is bookdb. Now when you create the table, it creates the table within this schema. Now let's create the table. Here we have a book table with ID column, which is an auto increment column. This is called as surrogate key, and followed by title, author, ISBN number, which is also unique. We cannot have more than one primary key, so hence we need to use the combination not null and unique for ISBN column, and published date, which is a date column, and price, which is a numeric column of size 10, 2. Now let's create the table. Now this insert command will insert a sample record into the table. Now here we are not specifying the value for ID column. The ID column is selected for auto increment, so the value will be auto incremented. The rest of the columns are given the values. And now here we will insert the system date. Now let's run and insert this command. Then let's see what are the records available in the table. I can see that we have one single record. That's fine. Now let's start with Java application which interacts with this particular table. Now let us get started with the example. Now let us first create a new Maven project. And the archetype is quick start. And then, so let us give the group ID as com TekCreek Java. So that's fine. And for the artifact ID, let us apply something like sample project. Now for the package name, I will give com TekCreek Java and sample project. That should be good. Let's create it. Now we created a Maven project. Now you can see that we have the pom.xml. Now here we need to supply two dependencies. One is MySQL connector and the other is Apache Commons DBCP for data source configuration. Now we need to insert those two dependencies into this project. I will say, so these two dependencies, one is the driver and the other is Commons DBCP for data source configuration. So here we have a book table with ID, title, author, ISBN, published date and price. Now let's create a domain class for this one. I will create a new class. I will call it as book and the package I will give the domain dot domain. Now the fields include the ID, which is an integer field, and the title, which is a string field, and the author, which is again a string field, ISBN, again a string field, and published date, which is a date field, and then the price field, which is a double field. Date, let's import the date class, or before that let's remove this. I will use the Java SQL date here, that's fine. Now let us create the getters and setters for these fields. Source, generate getters and setters, and then followed by the field selection. Now this is the common practice in programming, get and set. These are called accessor methods, get and followed by the property name and set followed by property name. The first letter of the property will be capital case. Now let us create a class, and for the name of the package I will select repository, and here I would call this as book repository. And for establishing the connection, I will create a class called connection factory. Let's create connection factory, and this will return the connection to the callers, get connection. And for now let's return null. The connection, let's use the SQL one. Now the book repository requires the connection, so it can obtain the connection from the connection factory. So let's create an object for connection factory inside book repository. is a private field. Observe this component here. Now book repository depends on connection factory. So this is what we call as dependency. And because this is a normal Java application, we created the object directly here. If we are using something like Spring or some other framework, this might have been injected into the book repository, and this injection is what we call dependency injection. Now because we are not using any framework, we created the object directly. And now using the connection factory, book repository can obtain the connection. Now let us complete the connection factory here. Now here we will configure a data source. Earlier we have seen what is a data source and how to obtain the connection from it. So let us configure the data source, basic data source. And we will initialize this data source inside the constructor. And here the driver class name is the same, and if you look at the URL, we are using the bookdb, and then the username is sample user, password is password, maximum total connections we can just keep it to 2, maximum idle connections we can keep it to 1, and the validation query as usual, it might vary from database to database. Now whenever somebody asks for a connection, we can now use the data source and we can obtain the connection. Now in case of an exception, let us throw SQL exception. Now we designed the connection factory. Now we can start working with the book repository. Now let us start adding methods to the book repository. As an entry point, let us define something called as find by title. It might be a list of books. Find by title returns all the books that match the given title. So it returns a collection of books which matches the title. Now let us define that. And here the book is this one, and the list is Java util list. Now first thing is we need a connection. So let us take the connection. Connection factory dot get connection. And then we need to run a prepared statement. Connection dot prepare statement. And the command is select all columns from book, say book, where title like question mark. So here we will supply this title for the question mark, or we can, if we want to do an exact match, we can give equal to, and then ps dot set string of first parameter comma title. So we can also use percentage title percentage if we want. Let's say percentage followed by title and followed by percentage. So to match all the books which match with contains this title. Now we will run the command to obtain the results. Result set rs equal to ps dot execute query. Now this is fine. Now what I will do is I will just try to give the connection. So that I can close the connection inside the finally block. Connection is not equal to null. Connection dot close. Now these methods are throwing an exception. We will see how to handle these exceptions. And when we run the query, we get the result set. And for each record obtained in the query, we need to map it to book object, and then we should return that as a list. So let us create a list of books, the result, array list of type book, and here while rs.next, we can map this record to book object, map to book rs, so that is the record, and then add it to the result.add, add the book, and finally return the result. We need to define what is map to book. So let's create a book object, new book, then book.set id rs.getInt of id column. Next, book.set title rs.getString of title column. Book.set author rs.getString of author. Next, book.set ISBN getString of ISBN. Book.set published date get date of published date. Set price rs.get double of price code, and return the book. So these methods throw SQL exception. Let's say throws SQL exception. And then these methods, let us say, throws exception for now. We will handle this within this project now. Now as you can see this example, we are just mapping the result set record to the book object, which we have seen earlier how to do an object relational mapping. So this is nothing but a record is mapped to an object, and then the object is returned back to the caller. Now let us test this example up to now and check whether it is working or not. Let me create a book repository object, and find by title Java. Just let's print each book. For each book B in the list of books, B. and this throws SQL exception. Let us throw that as well. Throws exception. And now inside the book class, to print the object, let us generate the toString method. Source generate toString with all the fields. That's fine. Now let's run this program. Now because we are printing the object directly, the output of the toString method is printed here, and for that reason we generated the toString method. Now let's run this program and check if it is working or not. So you can see that we got the book. So here we created a connection factory and we configured a data source to establish the connection, and book repository has a dependency for connection factory, and it uses the connection factory to obtain the connection, and later it might have several find methods. Here the first find method is find by title. It uses the given title, it queries the book table and fetches the records that match this title, and for each record it maps it to the book object and it adds that to the result, and finally it returns that result. Here in the example we just obtained the list of books and we printed them. Because we have seen it working, now let us also translate the exceptions. Here in the book repository, throws exception, don't do this in your projects, this is the dangerous thing to do. We need to actually handle the exceptions properly. Now for this, I will create a class called persistence layer exception, which extends exception class. Now we will also select the constructors from superclass. Okay, so now we created a separate exception called persistence layer exception. Now whenever there is an exception from the book repository, we will throw persistence layer exception instead of exception. And this is how the translations are done. Each layer will have its own set of exceptions, and that layer will throw the exception, the corresponding exception according to the type of failure that occurred. Now here persistence layer exception, we consider that as a common exception. Whenever any kind of failure occurs, we will throw this exception. Now let us say, so let us first catch the SQL exception here. And then in case of SQL exception, we will throw new persistence layer exception. And the root cause is SQL exception. So the root cause is given as input to the persistence layer exception. Now let us see what it is. So we are creating an object for persistence layer exception and we are setting the root cause as the SQL exception. And then here we need to handle this as well. So this actually surround with try catch, and again do the same thing. So from the find by title method, you can expect something like persistence layer exception. And now inside the app, I will say persistence layer exception. So exception handling should be very specific. Don't use throws exception in your projects. Now for now the rest of the things will remain the same. Let's run and test. That should be fine. Let's add a few more methods to the repository. Just like find by title, we will also add find by ID and find all methods. For that, find by ID. Now here ID is an integer, so hence take integer field, and the command will be select all columns from book where ID equal to question mark, because we are expecting a specific book record with the given ID, and the first parameter is ID and the set method is setInt. Now you can execute the query and obtain the result set, and here we are expecting only one record, hence if rs.next, if there is a record, then we will map the record to the book object and we will return that book. If not, we can return null value, which indicates that there is no book record at all. And the return value is not list here, we are returning a specific book. And rest of the things will remain the same. So this is now find by ID. Find by ID returns a book object associated with the given ID. Now if there is a record, it returns the book object, otherwise it returns null. And here within these two methods I see there is something in common. I will extract this and make it a method called close. And inside the find by ID, it translated this code to close of connection. Let us keep push this to the end of this method. Now we have two find methods here. One is find by title and the other is find by ID. We can also write one more method called find all. Make it find all, and find all doesn't accept any arguments, it returns all the book instances, and here we don't need the where clause. Now execute the query and rest of the things remain the same. So it runs the query and returns all the book objects associated with that query result. So these are the three different find methods of find by title, find by ID and find all. Similarly, let's also define the save operation. Let's say save the book object, and here it throws persistence layer exception. Now here if the ID is null, we will insert the record, otherwise we will update the record. So connection initially null, inside the try block connection equal to connection factory dot get connection. Now we obtain the connection. Now let us create a prepared statement here. So let me correct this. Prepared statement PS1. Now here if book dot get ID is equal to null, this means we will insert the record, else we will update the record. Now here to avoid the confusion, I will name it PS2. Connection dot prepare statement. Here we need to do the insert operation. So let us bring the insert command from here. Insert into book. and the columns are title, author, ISBN, published date and price, and its values and these values are supplied through the book object. So, first parameter is the title, second parameter name, third parameter ISBN, fourth parameter is date and time, and fifth parameter price. Let us apply the values for that. ps1 dot set string, first parameter, obtain that from name, get title. ps1 dot set string, second parameter, book object dot get author. ps1 dot set string, third ISBN. Now here we are doing a reverse mapping, that is object to record. Previously during the find methods we mapped it from record to object. Set date, fourth parameter is date, book dot get published date. Set price, which is double, fifth parameter, book dot get price, and ps1 dot execute update. So if the ID is null, we executed the insert command. If the ID is not null, we need to execute the update command, and for that update book, set title equal to question mark, author equal to question mark, ISBN equal to question mark, published date equal to question mark, and price equal to question mark, where ID equal to question mark. Here this is PS2. Now parameter sequence, let us check that. Title first parameter, author second parameter, ISBN is missing here, ps2 dot set string, 3 book dot get ISBN. Now 3 is ISBN, 4 is published date, 5 is price, and sixth parameter is ID. So set int sixth parameter book dot get ID and execute update. In case of SQL exception, let us throw new persistence layer exception of E. Finally, let's close the connection. So this is the save method. And to be more clear, let me rename it to or save or update. So if ID is null, this is performs the save operation, otherwise it performs the update operation. This is good. Now we have 4 methods inside the book repository: find by title, and then find by ID, find all, and save or update. Let us check the save or update now. First, what we will do is we will create a book object, new book dot set title, let's name it JDBC, let's say Sagar, set ISBN, I will say ISBN 123, set published date, and here we can supply new java.sql.date, and the date and time is obtained from new java.util.date.getTime. Now here we constructed the SQL date object using the util date. Now its long value is given as input to SQL date constructor so that it constructs the SQL date. And then new book dot set price, let's say some 200, and then repository dot save or update new book. Okay, it's my spelling mistake. So set price is expecting a double value which is given an integer value. I will say 200.0. That's fine. Let's run and execute and see whether it is working or not. Go back and query the table once. You can see it inserted the record. Now, if we populate the ID and say, let us say this is as JDBC, we will populate the ID new book dot set ID of 2, and then instead of small JDBC, let me say JDBC. Now let's run. It should have updated the record. Let's go back and check. Now you can see that it has updated the record. So we now have the repository class with all the find methods and save or update methods. Now let us move to the upper layers of the application. So here the repository classes and the domain classes, they form the persistence layer of the application. As the name implies, they deal with the data persistence. That means how the entity is stored in the database, how it is retrieved, etc. Now let us take a look at how we can develop the service layer. Now let me create a new class, and for the package I will give dot service, and the name of the class, let me call it as book service. First of all, what is a service? A service could be considered as a piece of work. Say for example, when we say purchase a book, now it doesn't mean that purchase a book will simply interact with one single entity. Now it might perform multiple operations to complete this service call. For example, it might actually update the stock, and also it might add sales entry, and it might take the help of some other mailing service to send the notifications, and so on. Now all these operations combined to perform a single service operation, and this is how we can define the services. Now you can clearly see that one service might interact with other service as well as part of the operation. Now if you consider book service, this class might contain all the services which are defined as part of book service. Now let us say get book for the given ID. Let us return null for now, and get all books, return null, and then create a book, the given book object, update book. Now this is just for demonstration purpose, and hence the operations are quite simple, but technically you can see that each service might have several interactions before completing the operation. If you carefully observe, here I am using the domain object itself. Now this may vary across applications, because some applications will use the domain model object itself till the UI, and some applications might create a separate model object, might be similar to the book object, and then we may map the obtained book object to the model object. But for the example sake, here I am using the direct domain object. Now also one more thing, we will create a separate exception class, which is, we call it service layer exception, which extends exception class. Also select the constructors from superclass. Each layer should have its own set of exceptions. That's a good practice, and you should properly map the low level exceptions to the upper layer based on how we can handle that exception. Now here we defined a service layer exception. This is an exception defined at this layer, that is the service layer, and for all the methods we can say throws service layer exception. Now here service layer exception is a single exception. We can also subclass it and create subtypes for service layer exception and throw the right exception based on the type of failure. Now let us complete the operations here. I will push this to the bottom, and book service might need to interact with book repository. So let me create that as a field. Book repository is a dependency for book service, and injecting the dependencies is what we call as dependency injection. And because this is a console app, we are not using any framework, we directly created the object. Now here it is plain and straightforward operation calls, but normally you might see something like this in a complex application. Now get book, so we already have a method book repository dot find by ID. Now this particular repository class throws persistence layer exception. Now let us handle that here, and instead of throwing persistence layer exception to the upper layer, we will translate that to service layer exception. We will throw this as throw new service layer exception. Similarly, we need to make a call to all the other operations. It is for get all books, we have find all, and create book, nothing but book repository dot save or update book, and update book, nothing but save or update book. Now these are the service operations. Book service provides this get book, get all books, create and update book. Once again, if you go to a complex project, this might not be this simple. Each operation might have several repository interactions and also several other service interactions. Now let us check if the book service is working or not. Let's create object for book service, and book service dot get book with id 1. And let's print the book. Now here the exception is not persistence layer exception, so we need to throw service layer exception here, and let us not handle this for now. Let's change it to throws exception. Now let's run and check what is the output. I can see that we got the book. Now we define the service layer. Service layer provides the list of all services which are available. It may be on top of the book or it may be something else. And you will see service as a complex operation with multiple repository interactions and multiple service interactions. Here for the example sake, I just created a book service with get book, get all books, etc. Now each operation will make a call to the corresponding repository entry. And why the exception translation is important? It is very important to decouple the upper layers from the lower layers, because say for example here we have a persistence layer, and persistence layer, on top of the persistence layer we have service layer, maybe called as a business layer as well. Then we will have the API or the controller layer. Now if API layer directly handles the exceptions of the persistence layer, we call it that API is directly tightly coupled with persistence layer. Now in that case, the changing the persistence layer will become very difficult. Now instead, API layer should have the exceptions thrown by the service layer, and service layer should have a corresponding mapping exceptions from the persistence layer. So each layer should have its own set of exceptions, so that API is now directly dependent on service layer exception, and service layer exception can map the persistence layer exception. Now just think about a scenario where we directly handle persistence layer exception. Now in that case, you can directly see that API is now tightly coupled with persistence layer. So this should not happen. So exception translation is also important while designing the layers in the project. Now that we have seen the service layer, let us now get started with the API layer. me define a new class and I will call it book API. The package I will also select API. API actually acts as an interface, and API is the means through which clients will interact with the application, and the client code is the one which consumes the services. Now the client may exist within the same application or it may be an external system. Normally you see that API is built using HTTP REST API, but for the example sake here I will just make it a method call, but in reality you need to think that this API is a REST API. Now let us define the methods. Let us say public, and we will see what is the return type, get book with the given ID. Normally this get book might be a handler method for the REST API call, something like this. The request method is get and followed by /book/ some book ID. Now this method might be a handler method for this API call, but here because it is a simple Java application I am ignoring the REST API calls now, and get book response might be something like get book response. Now this we need to create a POJO. Let us create a POJO. We will say dot modal objects. These API methods normally doesn't throw any exceptions because we are supposed to send the status code back to the client indicating whether the request is success or failed. Now in this case getBook response might have a field like status and some description. Now this status might indicate that whether the status whether the request is success or not. Now let us define the getters and setters for this. Now while sending the response we will also send the status. Now as part of getBook response we might just return the book as well. So the basic book info which will actually contain the book related information, and generate the getters and setters for this as well. Now this should be good. For the given ID we will make a service call, and through the service call we will collect the response and we will return it as response. Now for response call we will need book service. So you may consider this as a private field. Now let's make a call to book service. Book service dot get book with the given ID. Now if book is equal to null, then the book is not obtained, the ID given ID is invalid, otherwise given ID is valid. Let us create the response object, response equal to, and in the response we will say set status. Now in this case we will return the status as not found. Now for that we just need to create some constants so that we can make it as a standard. I will say new interface. I'll call it response status, and I will say success, say 10, not found, say something like 20, failed, I will say 30. Now, if you want to exactly match the HTTP status codes, we might say success as 200, not found, let's say that as 404, and some internal server failure or something like that, let's say 500. And now, in the API, we will set the status as response status dot not found. Now, in case of success, we will send the response status as success, and also we will set the response dot set book. Now, we need to handle one more thing here. Now, this particular get book might throw service layer exception as well. So, we need to handle the exception as well. Let's move this response to here, and let's add that inside the try block. Catch service layer exception. So, now if the response, if a normal response is obtained and if it is null, then we are sending the response code as not found. If the book object is obtained, then we are sending the response code as success, and also we are setting the book object inside the response. Now, in case of any exception, we might actually send that as failure. Let's say failed, and the description should be the client specific description. So, this will be defined as part of the API. So, what should be the actual response sent? But here, for the example sake, I am setting the description as the exception dot toString, the first line of the error itself. Normally, that is not the case. We don't send any exception specific information to the client. And finally, return the response. So, this is how we can expect an API call. So, here because this is a simple Java application, we are not implementing it as REST. Otherwise, this might be a REST controller and this might be a method handler for get and followed by the request path book / id, where id is called as the path parameter and whose value is supplied by the client, and based on the given id, we will query the book. If the response is obtained, then we will set the response, otherwise we will send that as not found, and in case of any exceptions, we will send them as failed. Now, let us check this and test this one. Let us print the response. Now, here inside the getBook response, I will also add the toString method, generate toString. Now, run this and check. Now you can see that the response code is 200 and the description, because we did not set, it is null, and the actual book object. And let us supply something which is a non-existing ID, let us say 10. You can see that the status is 404, that is not found. So this is how the basic API is built. Similarly, let us build the other API as well. So like getBook, getBooks, where there will be no ID, and getBooks response. This might be handling a REST API call, something like get and slash books. Now let us create the getBooks response class as well. And just like how we kept the status and description, we will also keep that inside getBooks response. But here, instead of a single book, it will be list of books. And from the API, we will call get all books. Now if books equal to null, then not found. This is not the case, it always returns an empty list, and if the books are obtained, then we can supply. If the books are obtained, then we can set it to the response object, and here the response is of type get books response. So this is actually not required, let us not set this. Now based on the service call, we will simply set the success response status if the method returns normally without any exceptions, and we are setting the books object inside the response. Now if in case of any exception, we are sending the response as failed and along with the description. So this is get books. You can make an API call and check. Comment out this. There is no toString method, and that is the reason we got this kind of output. Let us go and add the toString method. See, we got the status 200, and there are two books, one is the book ID 1 and other is book ID 2. Similarly, let us define the other API methods as well, create and update. Let us go back. And for create, normally if it is a REST API call, we might have mapped it to a post request and followed by book. and the request body might have the JSON that with the book info. So here we will say create book, and I will call it as create book request, and create book response. So let's create these two classes, create book request in the modal. Similarly, create book response, and as usual in response object, let us copy the status and description. Here we don't need to send anything back, just we need to respond back with the status. So create book response will only contain the status and description. Now create book request might actually contain the book JSON, the book object which need to be created without the ID. So let us also set the, let's import it and also generate the getters and setters. It's good. Now in the API, we take the create book request now inside the request you know that there is a book object. It may be a single book object or it may be an array of book objects. So array of book objects are normally used for bulk insertion or bulk creation. So here we have only single book object, get book. Now let us call the service book service dot create book. We are not doing any request validations here. Ideally we might have to do the validation again. Now if this method normally returns, then we can say that the operation is successful. And if it throws any exception, then we can say that the operation failed and we can send that as a response. And similarly, we can also make an update book request call. I will say update, and updates are normally mapped to put if you know HTTP, otherwise you can ignore this. We can say update book and the request might be update book request, and here update book response. And let's create the update book request anyway. And similarly update book response. Now update book response, just like create book response, it also has only status and description. And update book request again, like create book request, it to contain the actual book object. And now coming back to API, we will make a call to update book. And rest of the things remain the same. So this is a plain and simple API. So here we have 4 API operations. One is get book, get all books, that is get books, and then create book and update book. So this is how we normally define the API. API is the one which is used by the external clients usually, and external clients will make a call to the API and they obtain the response, and in response based on the status code they consider that whether the call is success or whether the call failed. Let's also check the create API once. Let's go to the app call. And here we have the code to create the book. This is not supposed to be populated. Say some other thing, the API. So the rest of the things, let's keep it same. And here we need to create book request. And we need to set the book object to the create book request. And now we need to make the API call create book with the request. Response equal to and print the response. Now I will generate the toString method to print it in a proper format. Now let's check this. Yeah, it got created. So to check whether this is working or not, we can use the API itself. Let's go back to our get all books API. And here in the toString, I will add /n to make it easy, so that each book object comes in a single row. Now let's print it. You can see that the first book ID 1, 2 and 3, this is the one which we just created. So the record got inserted. Similarly, we can also test the update operation. So now we exposed the API for the application, and we will now see how the client interaction happens. The only downside of this is it is a plain simple Java components. Normally this used to be a REST controller with all the REST method calls. Now if you look at it, API is interacting with the service layer is interacting with repository, and the exceptions are translated accordingly. When it comes to API, exceptions are not thrown from API. Ideally, they are translated to the proper response codes and then they are sent back to the client. Now you got the idea about how to design the persistence layer, service layer and the API layer. API actually stands for Application Program Interface, which is the interface for external clients. Normally, there are two types of clients which can interact with the API layer. One is the view, which is the UI part of the application, and the other is the external client. And external clients might be using the API directly through the web service calls. This is fine. Now, how to design the view? Because our current project, we are not having any view, I will simply use the command line interface to design some view, but I will like to explain you what are the different components which are part of the view layer. Now, if you look at the view layer, most common pattern used is the MVC pattern. MVC stands for Model View Controller. Now, let's understand what is this Model View Controller is all about. Assume that you are looking at the Edit Book View screen and where you are editing the book details. Now, once you click the update button, the request might go to the book controller, and controller might then initiate the actual operation by making the respective API calls. And once the response is obtained from the API, based on the success or failure, it might direct you to the next view. Say for example, if the operation is successful, it might send you the book list view so that you can see the list of books, or it might send you back to the edit book view screen if the operation fails because of some validation errors. So something like that. Now in this case, the component which is displaying the details is called the view component, and the one which is controlling is the controller component. And in between, the exchange of data is done through the model object, which is a plain POSO normally. This model object contains the data. Now, if you combine these three components, they become model, view, controller, and this is called as MVC. So, view component will render the data, whereas controller will decide the view, and also it is responsible for sending the right model objects, and API is the one which performs the operation with the help of service and persistence components. Now, if you are building an application using MVC, this is what you need to understand. But for the current example, I am going to use the basic console app. So, we don't see this architecture in this project, but anyway, you should now get the fair understanding about what is MVC. This is not so important because I am not defining it efficiently, but just to complete the example, I am creating a command line interface. Now, let me create a new class, and for the package I will give it as controller, and for the name I will say book controller. But this is actually not a controller, so this is just for the naming sake I created the controller. Normally controller is the one which decides the view and collects the data back from the view and initiate the respective operation and send the next view to the user. But here this is just a menu driven app. Let me first show the menu to the user. Show menu. And here you give 1, get book, and for reading the data I will create the scanner. Choice equal to scan dot next int and return the choice. Now we displayed the menu. Now inside the controller I will say, please don't follow this example, this is just for example sake. From the view part you are normally supposed to design it using the MVC. Now start. do choice equal to show menu to the user, and if choice equal to 5, then you can break the loop and you can repeat this while choice is not equal to 5. Now, based on the choice, let us call the respective operation. So, if I say switch choice case 1, now here you might need to call the get book. So, let me say that as get book. Case 2, get all books. Case 3, create book. And case 4, update book. And default, if not in this case, I will simply display invalid choice. And again the control goes back and displays the menu and takes the user action. Now let us also create these methods: get book, get all books, create book, and update book. Now this controller requires the API, and this is the variation. So it might be calling the API directly. Normally this will be a web service call. So let's make a call to get book. Now get book response API dot get book with the given ID. So here we need to accept the ID. So based on the ID, so for that let me print enter the book ID scan dot next int. Now pass this ID to the API, fetch the response back, and if response dot get status is equal to response status dot success, then display the book. So this is fine. So if the response status is success, then only we are looking at the book content, otherwise we are simply displaying the status. Now let's run and check the first option. Go to the app. I will also comment out this. So the app, you can say book controller, Start. Now let's check the output. So you are given the options 1, 2, 3, 4, 5. Select the option. Let's say 1. Enter the ID. Say 1. So you got the book details, and again we got the menu, and again enter the ID. Let's say 1. Enter the book ID. Let's say 10, which is non-existing book. So failed with status code 404. This is not found. And similarly, let's complete the other operations as well. Now here to exit, I will select 5. Let us now complete the other operations as well. Get all books, just like get books. Now here we don't need ID. And if the response status is success, then display the books. Otherwise, failed with the status code. That's fine. Now let's try the create book. And for create book, we need to supply the book object, and we need to also accept the book details. Let us say, so let us see what are the details required. ID, title. We don't need the ID. This date, let us read that as string. And we will ask them to enter this in BD and YYY format. And for publisher date, we need to first construct the date. Let us get the date from the et equal to, I'll say, so because this is in string format, we need to parse this and get the date out of it. And for that you need a simple date format object. And dd pattern. Date format dot parse. This will be java.util.date. Now we need to convert this to SQL date, and for that new date object of pt.getTime, and this is java.sql.date. And this parse might actually throw an exception. Let's surround it with try catch for now. Equal to null. So I'm not worried about what is the flow here. Let us leave it. We accept the date in this format and we parse it to obtain the date object, and this date should be converted to SQL date, and for that create the object for SQL date and pass the long value of the time to the constructor, and then the price. So now that we accepted the book details, let us create the book object. We are not populating the ID because this is a create request, and we need to construct create book request object, and we need to set the book to be created, and then we can call the API create book, and if response dot get status equal to response status dot success, successful, else wait status code response dot get status. So that's it. Because we are using the domain object book directly, we are forced to pass the SQL date. Normally in the API calls, the date values are obtained using the string and parsing happens on the server end. Now let us also complete the update operation. Update is almost the same, except that we will also accept the ID. And we will also set the ID. And instead of create book request, we will do update book request. And the API call update book. And here this is update book response. Updated successfully. Updation failed. So that's it. So let's run and check that once. Let us now select the create book. So there is an enter character which is causing this trouble. So scan dot next line is skipped because of the enter character that previously entered. I will introduce one scan dot next line, an empty scan dot next line to capture it. Now let's say create book, enter the title, let's say new Java to author, ISBN. So publisher date, let's say that as something like 12/09/2018. Price, let's say, you can see that book created successfully. Now let's check get all books. So we have created the record. And now for this I will update. Let's select the update book ID 4, and this is the problem. So because this enter key after the 4 will actually skip the next line call while entering the title. So this is a trick, it is not the ideal one, but it works. For update book, enter the ID for title, say new Java, author, Sagar, it's a ISBN, I will call it as 9. Publisher date, let's give that as 0, 9 and 28 here. Price, say 500. So get all books. You can see that the ISBN is updated and also the price. We need to make one more change to this project. If you take a look at connection factory, we have given these values directly inside the code. And this is not the right approach, because if you look at the projects, we might be running the project under different environments, and these URLs and the username password values might change per environment. Say for example, projects might be deployed in dev environments and where the connections and username and passwords will vary. And similarly, if deployed in QA, it might change. Like that, these properties might change per environment, and it is not a good idea to put them inside the code. Instead, we need to put them in the properties file. Let us create the property file for this and move these properties into that file. Now for that, I will create a source directory here. And the name of the folder is src main resources. And then inside this folder, I will place a file called database.properties. These property files are nothing but a key value pairs. So anything that starts with hash is called the comment. And here the structure of this property file is left side it will be key and followed by equal to, and the right side RHS is the value. Say for example, this is the driver class. So instead of keeping that here, let me create a new property for this. Data source dot driver class equal to this one. Similarly, data source dot URL, let us change it to URL property. Now we created the property file. Now we need to obtain these values from this file. If you are using Spring or some other frameworks, then loading these properties is much easier. But because this is a normal Java application, we might need to load these things manually. And I will show you how we can do that. Now I will create a utility class here. Let me create a new class and I will create a package called utils property provider. Now inside the property provider, now I will create something called as get driver class. Now this is also, let it keep it as now. Now we will use this property provider. Still it is not completely implemented. We will use this property provider to obtain the properties. So let's go back to the connection factory and we need one more dependency, that is property provider. create an object for this class. And then use the property provider to get the driver class. Now, inside the property provider, we need to load the properties from the database.properties file, and then we need to return those values from the corresponding methods. And for this, let us use the properties utility class. Let me create an object for properties. Properties is a utility class which is a kind of a hash map with key and value pairs. And the additional advantage of using the properties is that it supports loading the properties from the input stream. I will show you how. During the constructor, let us load the properties here. Let's create the method called load properties. Now, in general, in the main projects, you will actually have something called as config directory, and inside the config directory we will place the property files, and we will use the config directory to load all the properties which are specific to that environment. But here, because I kept these properties inside the class path, we might have to load it using the class loader. And placing the properties within the project class path is also not a good idea. So, we need to keep it outside in the configuration folder. We need to set aside that this is the folder where the configuration is kept, and we need to load the properties from that folder. Now, here, because I need to load that from the class path, I just need to use the class loader. So, let us say even if you did not understand this completely, that is not a problem. Just go through once or twice, you will be able to understand it. Class dot get resource as stream. Now, here I will say database dot properties, which is a very specific name, but normally under the config directory all the property files are loaded. And this actual method gives you this file as a stream, and because we are loading it using the class object, it loads it using the class loader. So, the class loader will actually search for this property file within the class path. So, input stream. Now, if the resource is loaded, and that is if the resource is found, then it returns an input stream, and using the input stream you can now access the properties. So, properties dot load then from the input stream. We need to catch the exceptions here. And we need to do this only if the resource is found, that is if input stream is not equal to null. So, I will say here in the finally block in dot close, and again surround with try catch. So, inside this class what we are doing is we are actually trying to load the database.properties from the class path, that is nothing but this folder at the moment, and then once we load this file as input stream, we can use the load method inside the properties class to actually load all those properties. Now, that is nothing but a key value pairs. Now, here the key would be this one and the value would be this one. Now, what we should do? We should actually, once the properties are loaded for the driver class, we need to use this key. get property, and this is the key. So here we need to say integer dot value of. This converts the given string to integer. Similarly here, integer dot value of. So if you look at this one now, we loaded the properties once you create the object, and once we load the properties, then we are using those properties to extract the values. So, and this property provider will actually give the properties for connection factory so that it can establish the connection. Now, this way we have externalized the properties to the property file, and this property file will change per environment so that each environment will have its own property file. But for this example, I am loading it from within the class path, but ideally in the applications, this will be loaded from external configuration folder. So, the way we load the file might slightly change. We might use the file object and provide the path to the file before loading it. Because this is for demonstration purpose, I did few things manually. Normally we might be using a framework such as Spring, and that has built-in capabilities to load the properties. Now let us run and check if it is working or not. Go back to the app, run as Java application, and we got the exception, and this is because the file is not loaded. So this can happen if the file is not loaded properly. So instead of class, let's take get class loader. Now we are using the class loader to load this resource as stream. It actually loads the file from the class path. So there are certain folders which come within the class path. You can see that it is part of the same application. Just think about it like that. Anything that comes within the source directory will come under the class path. So we are using the class loader to load this particular file within the class from within the class path as input stream so that we can read the file, and using it we are loading the properties, and later on we are accessing the properties using the keys. So these keys are predetermined keys, don't worry, but the rest of the things, the values will vary per environment.